universal language for any idea and concept. Algorithms, tools for expressing your ideas. Agile, flexible, science, art, architecture, medicine, philosophy, and logic speak the same language. This ushers in the era of new opportunities that will unleash human potential, and human will instill meaning into technology. AIJ 2025, a journey into the world of artificial intelligence, starts now.
Заместитель председателя правительства Российской Федерации Дмитрий Чернышенко.
Deputy Prime Minister of the Russian Federation Dmitry Chernyshenko. Senior Vice President, Head of Technology and AI Block of Sber, Andrei Belevtsev.
Доброе утро, дорогие друзья.
Good morning, dear friends. I'm happy to welcome all of you here in day 3 of our international conference. This day will all be about science. We've had almost 4,000 guests in these halls. We decided to introduce a new track to expand the platform of the conference. We have this new track called Deep Dive, where we explore technology in more detail, where we explore the work of our scientists and researchers in more detail. I think this year, it would not be an exaggeration to call this year the year of science and research. This year, we got the first research results achieved by AI and accepted for an international conference. I don't think any research from now on will be done without AI helping scientists. I would like to thank Mr. Chernyshenko for his unyielding support of AI and science in Russia at the highest level. Mr. Chernyshenko, thank you very much. Thank you, Andrei. Hello, everyone. A very important day today, a day of science in AI. And today the focus of our attention will be on the ideas that define the future of our country. I'd like to thank all the organizers. Let's give them a round of applause for this exceptional organization of the event. Day 3, still going strong. As you remember, the first day was marked by a visit by the President of Russia. I do not think any head of state, any state, would be as deeply involved in this topic, appreciating the importance of this topic. And what's even more important is that visits such as this one always result in concrete assignments. Yesterday, the President defined very important aspects, very important streams of work related to the development of AI in Russia and the world, and he mentioned that it's not even a race among major companies, but countries racing for foundation models. It's also a competition for power supply and computing power and the possibility to train your own foundation models. In order to achieve the national goal of technological leadership, and it's more than sovereignty, it's leadership, meaning that we need to be ahead of other countries in the world. We need to make sure we have our own talent. We have specialists in research, in production. We need to support different areas of science, and obviously we need our infrastructure. To make sure we have all that, we need a strong foundation, scientific foundation, and this will enable us to face any challenges of the future. This year, We've had a very important development. As a result of the previous AI journey, we spent the entire year doing foresighting in AI. It was an international foresight that brought together scientists from more than 36 countries, and throughout the year, over 25 sessions in different countries. What they came to was 10 commonly recognized areas of work in AI science. They will provide the groundwork that will become a launchpad for us for all kinds of discoveries and breakthroughs. These breakthroughs are happening almost every day. One of the 10 key areas that we will be exploring today is probably something that turned into a bit of a buzzword, that's AGI or super AI. One of the founders of AI working in the organization whose name starts with M and which is prohibited here, believes that the momentum will be with physically embodied models. These are models that understand the world context instead of simply analyzing text. The world model, as you probably know, there's recently been this release. A model was published of this kind. Fei-Fei Li, the Chinese scientist, agrees. Importantly, opinions vary depending on the scientists and researchers, but science is a global thing. It goes beyond localized regional contexts. We have scientists that are participants in the AI Alliance who also do foresight. They are driving this area forward, and as a result of that foresight, we will have 10 key areas, as I mentioned, depending on the practical solutions on the market. They will be, generally speaking, raising the bar, raising the overall level of excellence in terms of architecture and data processing standards and many other things involved in the foresight. So I'd like to assure you that this is a system-wide approach, this is a systemic approach. The Ministry of Economic Development has been regularly holding selections, grant-based competitions. As a result of such competitions, we now have 13 research teams which form part of the Russian scientific elite. They include research centers of the third wave. The third wave took place this year, and the centers that we selected fully dedicated themselves to the 10 key areas identified as a follow-up of the foresight. We're looking forward to the fourth wave of selections and competitions, as a result of which we will issue grants to different scientists and researchers, and hopefully this will once again strengthen our foothold and ensure even more breakthroughs. At this stage, we have a slightly different approach than the rest of the countries. Scientists work together in a transparent and in an open manner, and we invite anyone who shares the same principles and who believes in AI not for the sake of profit, but for the sake of actual progress. I hope you will join us. Unfortunately, there are certain illusions or hopes that humanity had at the onset of this technology, and the ambition for profit became the barrier for development. Many companies got carried away by commercialization and opted for closed models, closed research instead of open source models. Sometimes they even take advantage of bad faith in humans, stoking their fears or encouraging them to abuse these AI-based tools. Russia has a different path, has a different approach. I'm very happy to see more and more scientists joining us on this journey, meaning that they share our values. Historically, thousands and thousands of doctors back in the USSR and in Russia were receiving education, were studying. They came from Asian countries, and then they got back to their home countries to improve their domestic healthcare systems. And there was this COVID pandemic, which many of us have forgotten, but which was very, very recent. Russia was helping almost 50 countries in the world, sending doctors and medications. Which other countries did that? So now, facing global challenges, and there will be even more challenges, it's very important to make sure that such initiatives as the International AI Foresight wouldn't belong to just a handful of countries. It should be something that is shared by anyone who's interested in making the world a better place and who's not necessarily a part of a specific agency or institution. The logic is very simple. Over the year, we've been doing this together, we've been working together, and the result that we got absolutely needs to be open source, it needs to be publicly available. I suggest we have some common agreements or manifestos or memoranda to make sure we're on the same page with regard to the main principles. Hopefully, we maintain a positive outlook, a positive mindset on the development going forward. Andrei just said that SBIR, together with our research centers in AI, opened access to the AI platform for research, which will significantly accelerate research cycles. It already has modules to browse research papers, for example, on the stability of proteins or climate forecasts. So if you're a researcher or a scientist or an aspiring one, you have this unique opportunity to be the first to scan this QR code, to access the platform, test it, test drive it, give us feedback. Our experienced researchers will be creating the foundation for other researchers and scientists and for empowering them with new tools, with new opportunities. I would like to invite you to this session at 13 o'clock, 1 o'clock Moscow time. We'll have a lot of Russian and foreign scientists who will talk about the fascinating jobs, the fascinating objectives that they have for themselves, recognized by the international community. These objectives help us focus as the government on what matters in AI. It helps us involve different businesses. Hopefully this will be interesting and useful to all of you. I wish you every success, and I hope you will enjoy the conference. Thank you. Please give a round of applause to Veronika Romanova, the conference host. Once again, your applause for Dmitry Chernyshenko. Thank you for this dynamic start of Day 3 of AIJ 2025. Thank you for the motivation. Today will be about science. Intensive, precise, bold. Here, knowledge sets the pace for the technological tomorrow. New questions, new methods, new data, new answers. We are connecting hypotheses and practice to understand what AI has in store for us next. And a powerful conclusion of today and the entire conference will be 3 award ceremonies. At the end of the day, we will give out the prize for the best research paper for the scientific journal AIJ Science, and we will also summarize the results of AIJ Contest and AIJ Challenge. And before we begin, I would like to thank our partners for their cooperation and support. Title partner of the conference, Force Agro. General partners, Yandex, T-Bank and Sbertech. Investment partner, Russian Direct Investment Fund. Our thanks also go to the official partners, Uralchem and Navio, and also the companies of Sibur, Cloud.ru and Moscow Exchange, bearing the status of conference partners. On behalf of the conference organizers, I express our sincere gratitude to our partners for their help. Well, shall we begin? If you want to see tomorrow, ask those who are building it today. We are literally talking with the future of world science. 4 young scientists, 3 countries, Russia, India and China, right now. They will talk about new ideas, engineering, creativity and skills that will actually be useful. Welcome the participants of the session, the new generation of artificial intelligence. Xiwen Sui, silver medalist of IOAI 2024. Shaleen Bhatia, winner of AI Challenge 2021, founder and CEO of Brainwave ML. Denis Dingmuhamedov, gold medalist of IOAI 2025, student of the Computer Science Department at HSE University. Zun Yan Duan, silver medalist of IOAI 2025. And the session moderator, Vice President, Director of AI and ML Technology Development Block at Sber, Maxim Yeromenko.
Good morning. Good morning, everyone. It is my great pleasure to welcome all of the participants of this conference. Today, we are wrapping up this conference with this day that is going to discuss the development of AI in science and fundamental research. Before we go to the discussion and panel discussion with our participants, sorry, I don't have the clicker, I think. Anyway, I wanted to show you a couple of pictures. I'm going to use voice command. We have a voice readiness technology implemented. Anyway, the first picture, I think you have seen it. It is a recent report of Microsoft report in terms of they're talking about the speed of the penetration of AI technologies in large-scale use. As Microsoft shows, AI technologies, I mean, if you start with ChatGPT of November 2022, AI technologies just had to go through 3 years of journey to get an audience of 3 billion people. And this penetration level that you see on the slides, on this one, yeah, it's 20%. That means it is also compared with electricity, with electrification, and the internet and mobile phones. And as you can see, the similar level of penetration required decades for the previous technologies. AI just needed 3 years. Skeptics would say that the term AI appeared more than 70 years ago, but the ubiquitous use of AI and large-scale implementation of AI before the end of 2010s, like somewhere in 2019, no one was talking about AI and in its active implementation. And this is the first idea that I wanted to mention before the start of our panel. The second idea is the role of the young people. Here you have the diagram of ChatGPT use, and as you can see that during summer vacation, the number of users go down almost threefold. that testifies to the fact that this service, the use of the LLM models, big models, is especially popular among young people who are studying in schools and universities. In this relation, we're going to discuss one item on the agenda, and meaning how to actually use the technology to develop our skills, including cognitive skills, and maybe another idea that I would like to address today is that we have two diagrams here. The lower diagram is a kind of a forecast in terms of the number of scientific articles that are going to be published at the top conferences if the dynamics as we have now remains in place. On the other hand, the majority of the significant part of the articles are going to be written by and authored by the generative AI, and we see the first articles appear. I think that with one of our scientists we had a discussion in terms of when the first article that is going to be fully generated by AI is going to be authored. And some people said in 5 years, but actually I think the first article appeared in 2025. It was fully generated by AI. It was a scientific article. And when we'll have the last article that was authored by a human that didn't use AI? And, that's a good question. I mean, if you make a projection for 2030, there is an opinion that around 1 million articles per year are going to be written and published by AI. The question is whether you can digest, being a human, all this number of articles without AI, and the place of AI in the cutting-edge scientific research. What will it be? Now, moving to our main panel discussion, I wanted to quickly introduce everyone. All of the panelists are the young people who achieved great results on the global scale. They're all winners of international contests and international Olympiads, and they're winners, silver medalists. I mean, on a global scale, having gold or silver or even bronze means that you're one of the best in this area, because they're not just using AI, they are contributing to the AI's development, and a huge contribution is delivered. It's not a PR hype when the young, bright people of the working in huge corporations, for these people, other companies want to hunt them and pay them millions, like with the footballers. So I would like
to avoid some miscommunication of the translation. So our first panelist is Tsunyan Duan. He is a silver winner of International Olympiad on AI, initiator of the AI Science Teen Cup. So a couple of days ago, here in Moscow, at the first day of the conference, the president of the Russian Federation, Vladimir Putin, addressed the very important question. So how should we use the AI in educational process in the way that will avoid us to decrease or impair the cognitive skills of kids, of teenagers, and so on, but in the way that will help or assist us to make the educational process more efficient. So to equip teenagers, kids, with a significantly new tool that provide us the better capabilities. I mean the generative AI as a part of educational process.
Yeah, I get your point. So firstly, we should teach students how to distinguish, how to use AI correctly. Like AI is trained on like all humans' knowledge, so it got its wisdoms. But on the other side, it have illusions and may give answers that's completely nonsense. So, in my perspective, we should teach students how to distinguish which part of the answer generated by AI is useful, and we could put it in use and learn from AI, and just drop the nonsense parts.
So, as a father of 3 daughters, starting from 6 years old to the 12 years old, should I restrict them the access to the large language models to avoid the game in the system, or should I address some guidelines for them, or should I use it as a tool to the improvements of their skills, maybe to cross-check the results of the homework and so on?
Yeah, I believe like letting kids use AI is not a right or wrong question. It's a to what extent question. Like to what extent do we allow kids to use AI? Like surely we could not let them use AI to do all their work because they would not like learn and think about what they're doing. But if, as I've said earlier, if we tell them how to use it correctly, how to learn from it, then kids would definitely achieve better with the help of AI.
Okay. So, and the next point, do you believe that AI, especially the generative AI or the multi-agents, will become the helpful assistant for education and as well as for the scientific research in the next few years? Or it's overhyped and we should consider some practical reasons that it will be restricted in terms of the usage and the popularity?
Yeah, AI could definitely help with scientific research. So firstly, AI could help us help scientists brainstorm new ideas and somehow get new insights. So with the help of AI, they could easily like know about what the frontiers in the area is doing, and AI could help them gather information and they could find a better topic. And secondly, AI-related methods is a significant breakthrough in artificial intelligence. So let me give an example. So in years later, maybe scientific discoveries would be data-driven instead of formula-driven. So we would tell the pattern from real-world data. So there's a company in Beijing that I know. So they are using AI to solve problems with molecular dynamics. So instead of solving the really complicated differential equations, they're just using an AI model to predict the dynamics, and that would increase the calculation speeds by like hundreds or thousands more. So that's how we could use AI to help with scientific research.
Thanks so much, Chuan Yan Duan. So it sounds that we will increase or improve our capabilities to make more scientific research in the time of the unit. Yeah. So, спасибо. Я, наверное, снова переключусь на русский язык, потому что у нас следующий спикер из России.
I will switch to Russian, back to Russian, because the next speaker is from Russia. Denis, I think like 2 or 3 years ago, together with Alexander Gasnikov, the rector of Innopolis, we were debating not really a problem, but something that we can see in the first years of the school program, school curriculum. Those who are participating in mathematical contests participating in STEM contests. Well, I mean, physics is not in the curriculum in the first couple of years at school, but, you know, let's say STEM contests and some contests that there are in high school. Like if you increase the funnel, the conversion of the conversion rate of those who participate in the first years of school, if you save and maintain this number of those who participate in the first years of school Olympiads, so that they participate in the same numbers in the higher schools and then enter universities, join universities, because the more people that have a passion for STEM enter universities and those who want to showcase that they that you know, this Olympiads, this contest is like a high-level sport. But anyway, to cut it to the chase, I mean, you are the winner of the international contest. I think you can't go higher than that. But at the same time, you have such a great background. This is your 10th contest, I think. I guess so. The question is, what it gave to you and what it delivers for other participants. To what extent it is good for the development of the new talents and the science. Thank you very much for the question, Maxim. As for the benefits of international contests, I would categorize them in 3 buckets. First of all, it's your personal privileges. I mean, obviously, if you talk about Russian big tech companies, you have some lower entry barriers to join them if you're a winner. And as you prepare for these contests, you go through a lot of practices that it's pretty hard to go through by yourself. The best coaches are working with you. They prepare you to do the very complicated tasks. Apart from hard skills, there are soft skills that are developed as well. Working in the team, UAE, International Olympiad, we had a team task, and we were preparing for the task as part of the team. Collaborating with folks from other countries also helped to boost these soft skills. The third thing that is very important is that you can share your experience with others. So you have gone through this path and you understand some of the things that less experienced guys do not get. And at some conferences like AIJ, you can share your experience and say what you should do and what you shouldn't do. It will help the younger generation in the future. When I was in the high school, it would be great if I had some podcasts with these guys, and so that where they share their experience. I would eagerly listen to them. Apart from your dialogue with Alexander Gasnikov, I think that this conversion funnel delivered by the contest will give you the boost, really. If you do STEM in high school, if you are passionate about that and committed to sciences, it is much easier for you to enter the technical university and to become a scientist. You know, if you compare it to a person who just do not have any scientific background, and just starting in this area. Yeah, by the way, you know, thank you very much. The soft skills is, I think I heard about soft skills when I was like 30 years old. You understand the value of it, and so you're very lucky here. In international contests, I don't know whether there is this effect or not, but this is our 10th annual conference, and during these 10 years, we organize contests and hackathons, and among grandmasters and contestants, you can see that you start to unite in the team and share the knowledge between the participants, and it gives a great leap forward because you cannot achieve those results by yourself. And when you contributed to a in your shared task, then it's great. It's easier to be better than the average, but get into the top of the board, to get in this point something percent, that's very complicated. So did you experience that? Yes, I think on the Russian official Olympiads, usually it's distributed beforehand, like either you resolve the tasks, the problems within the team or as a standalone participant. But anyway, I think that the teamwork gives you the boost in hard skills and in soft skills. Because someone decided to use one model, someone else decided to use another model, and when you combine these solutions to the problems, the overall solution becomes a better one. Yes, thank you, Denis. Well, teamwork obviously gives great results. Thank you very much. Round of applause, please, for Denis's take.
Once again, I switched into English. Shalin, we met each other 4 years ago in 2021. You was one of the winner of our AI Journey contest, and you also decided to go to the part of our team. So you passed through the internship program of Sber, but a few months later, you decided to come back to India, and what was the reason that you made decision to return? Because I know that you got here lots of opportunities to get the education in the best universities of Russia, and what was the main reason that you made decision to return, apart of the cold winter in Russia?
Thanks, Maxim. Yeah, it's a good question, actually. So my moving to India was a very personal decision of mine. It comprised of my family, of my people there, my friends there, and something to even contribute to my country. But for speaking about AI in India, we have many collaborations that companies are making. For example, just a few months back, the OpenAI decided to open their office in New Delhi, and then Anthropic CEO also visited with the Prime Minister. So a lot of exciting things are happening, and along with that, we have a vibrant developer ecosystem in New Delhi, Mumbai, and Bangalore, in which they have experience with many companies from Middle East regions, from Indian companies, and from companies from Europe. But in India, a lot of things are happening, and that's why I wanted to get into the chase, and that's why I made a decision to come back to India and help my community.
Okay, Shalin, thanks. And let's imagine, or let's assume that now we're living in 2041, so you are, correct me, 35 or 34 years old. What is your vision of your ideal role in the development of the AI as an entrepreneur, as a researcher, or as an executive of the large technological company? What is close to you?
So exactly, a lot of things are happening in the industry, and things are moving very fast. Compared to even few years ago, LLM was something that few people knew, very few people were doing research in those domains, and now we have companies, great companies from Russia, from China, and from all parts of the world who are contributing to this community, contributing to open source, and making huge companies with huge valuations. But I believe that across, as you said, 2041. It's a huge, it's a big problem for me to decide what's going to come in future. But all I can say is people need to integrate with AI. They need to learn AI. They have to understand AI. What's the power of it? What's the limitations of this great technology? And then use it to their opportunity. Make use in their workspaces. Make use in their daily lives. And because in future, most of the work is already going to be automated using my robots or AI, but the ones who are going to succeed are the ones who use AI, utilize AI in a very positive way, and make the best opportunity out of it. Yeah.
Thank you. Thanks so much, Shalin. Давайте поблагодарим. So, my next question to Vinsui. So you're one of the winner also of the International Olympiad or Olympic Games. I don't know how it's better to call Olympiad on AI. Yeah. So what are continuing the idea of how you're winning and your outstanding results in the math and as well as in computer science will help you in the next few years, especially when you will be at the choice of the career tracks and so on. Do you consider yourself as a researcher in scientific world, or it's more passionate to you to develop your talents as a manager in the company? What is your vision on your career track?
Thank you for your question. So for me, my personal previous experience is working as a competitive programmer. So the experience of competitive programming actually involves more about solving small, elegant problems. And you mentioned another option is to work for the society and solve some large-scale problems. But for me personally, I would choose to go on in a theoretical or a scientific research. Because there's one critical reason. So in the current era, with the new technology of AI, there's a boost or a big explosion in researches about social matters or large-scale problems. But eventually, after some times, the technology will reach a break that the current technology cannot solve anything any large-scale problems beyond that brick. But eventually that comes to the technology or the techniques behind. So it is that the development of the backend techniques that can really push the our solutions to the big problems in society one step forward. So I think I will be more a researcher or more with the techniques or technologies in my future.
Okay, thanks so much for your answer. And so at the beginning I said that some guys from Silicon Valley got very nice job offers from the new company that trying to compete with the big tech companies. I mean, the intellectual machine of Mira Murati or the ASI team of Meta. So they are offering the hundreds of millions of US dollars per year. And you consider that to be a researcher, it's practically better than to do some engineering stuff. Or so now I suppose you can combine your scientific background with something practical, yeah, in the such company.
Yeah, of course. If you're talking about if some big company provide me with good offers with a big salary or something, I mean, the salary part isn't actually the greatest part or greatest deal of my considerations. So if I'm lucky enough that in my future I got a job offer or an occupation that is high or like involving making some great decisions, and that's the part that I like most. So if you're like doing scientific researches, it's about a somehow narrow part into the technology. But if you actually have the ability or the possibility to make great decisions that can push humanity forward, or maybe not that big deal, but just some important decisions that can help others or guide others to the correct path onwards, and that would be the actual exciting part for me.
Thanks so much, Seven Sui. Thank you. And my next question will be to each of you. So the question will be about how you can change the world. So you are a young genius, young prodigies, and if you had one super task that you had to solve with the usage of AI, with the benefits of AI, advantages of AI, let's say in next 10 years, not only for money or for the fame, but for the humanity, what it will be?
So I believe I will contribute to the area of high school AI education in the next 10 years. Thank you. So because like me and Chiwen, we are from really large cities in China, and we could have like somehow the top educations in China, and that would give us a chance to learn AI and compete in AI Olympiads. But in some other regions of China, like the education isn't so great, so students are struggling with their schoolwork and they don't have their free time to like study about AI, even though AI is crucial for the society, like for you to live in the society and for you to work right now, but they do not have the chance to somehow learn about it in high school. So I believe that would be a crucial problem for us to solve in the future.
Thanks so much. Денис.
Да, я считаю, что, ну, вообще у меня такие две задачи, которые...
I personally have two super tasks. The first one is the one set by the president. The goal set by the president. You mean the demographic one? That as well, but I'm talking about the one related to AI. It's true, it's difficult to say to a child or to show a child how to use AI correctly, because many children these days grow up using smartphones, and in the future they will have a model embedded in them by default. And so children will learn how to use these models from a very early age. It's a difficult issue. It's hard to come up with some solution. How do you encourage a child to not just press a button mindlessly, but engage intellectually? And another goal, another task, a more applied one, a more practical one, is automation of production. I drew this inspiration from China. I learned that they already have factories that are fully automated, fully robotized. So this is something I would like to replicate here in Russia. Production is very labor-intensive. It requires a lot of investment. So if you can automate it in large scale, I think that would save up a lot of money, a lot of resources. Thank you. Shangyan?
Yeah, I think I will also contribute to my community. In India, there are many kids and many children who have great mindset of improving in future, and they just lack opportunities. And if given chance, they could get this opportunity and do great wonders. So I believe high school children, college children, and then university students should get the knowledge of AI. They should apply, contribute to open source communities where they are making, every models and all these documentations for free and for everyone to use. So that would be a great contribution to humanity as well, as everyone is joining a race which is towards positive sides of humanity. And I would like to do similar for that in India as well. Make a great developer community, an AI-intensive community, and get more young children and young people involved in it. Yeah.
Thank you, Shaleen. Suvinsi?
So they have talked about some realistic parts associated with the society. So I'm gonna say something different. It may not be that realistic, but we're just predicting the future, so it's fine. For me, if AI technology is that good in future years, I would love to have it, have it create problems for themselves and solving it. So currently, AI is kind of good at solving all the problems that humanity raised to them, but they have not reached the current stage, or they have not had the ability to create problems for themselves and solving it. So with that ability, they can revolutionize themselves and make real scientific research with solely AI themselves. And that would be really great if it is actually in the future, but maybe that will just not happen. I don't know, but I think it's actually a good thing. Yeah.
Thank you. So, you are very young guys, yeah, so you're each of you below 20 years old, because if I'll have a discussion with the guys who are after the 40, they will say that they will like to make some scientific breakthrough in the life longevity, digital immortality, and so on. But you are not both about that. Yeah, so you are too young. My next question will be also to each of you. We get almost 10 minutes, so two minutes for each of you. What would you recommend to the others, young people who are watching on you? What is your advice for them? How they should develop their own capabilities and skills? How should they handle with the AI in the era of generative AI and fast-growing technology in every sphere of in every field of our life?
Yeah, that's a valuable question. So from my perspective, I would urge the young students to pursue their passion. So with the help of AI, people could accomplish more than what people did years before. So maybe before, we need a team to build a project and make a company, but in years later, with the help of AI, I could help you to accomplish nearly everything. You could learn from AI. You could use AI to solve basic problems and do repetitive work. So you are the one to give ideas and be innovative. So if you are passionate about something, you could just pursue it. AI could help you. So for example, if you wanna develop a game, so you could use AI to draw the arts, to design the gameplay and to write the codes. So maybe before AI, you would need a whole team. You would need programmers, artists to help you build that game of yours. But later, you could just use AI to do all the work. So just do the things you want to do and you have interest in. So the only limitation is your passion. Thank you.
Thank you, Цунян Юрань. So, Denis?
У меня есть более такое глобальное.
I have a more global recommendation. I think you should once again engage intellectually way more rather than ask an LLM to think for you. From my experience, I can say that when you are trying to solve some difficult problem, it's quite a challenge to refrain from turning it to an LLM for answers, for hints. But that's exactly what makes you better, trying to think for yourself. Once you get a hint from an LLM, you lose something. And another recommendation for those who have already started working on AI is do not limit yourself to just one topic, to just research or just practice, but do both. Because when you're focusing only on research, for example, it's hard for you to understand how big services work from the inside. If you're only focused on practice, it's harder for you to come up with something new, to generate new ideas. So work on both areas rather than just one. Thank you, Danis. Charlene?
I think young children have a great exposure, I think, of AI and social media. So already they know much more things compared to the older generation, like our parents. I think I can see, so many cool things that are being made using AI, using these AI applications, like using APIs, model APIs, then using vibe coding, websites and apps. So like the playing field for even the senior guy and even the like a normal child who has use of AI has become same. So for example, a senior guy who has an experience of coding maybe like 10 plus years, and compared like to a child who has access to AI, now they're at the same level because he can just vibe code the apps and websites. So this has never happened in our civilization, because there was always an exchange of power. There was always some benefit that some other people had, but now the playing field is same. So I believe from here, young children should, or young people under the age of 25, I believe, should associate themselves with more experienced people, I believe, because experience is unmatched. Some people have great experience in industries, collaborating with people, that's a big thing also. And keep learning new things, I believe, and participate in these competitions, like this great AI competition by such a great bank, and that'll be my advice. And enjoy your life. That'll be my advice.
Thank you very much. Thanks so much. So, Tsubei.
Again, I'm mentioning my experience as a competitive programmer. So what I want to highlight is the word competitive. So it is an really important trait. Like passion is also important, but if you lose the competitive part, you only got passion. It's like our future with AI is like a long expedition. And if you lose the competitive part, you're like walking alone by yourself. You may get far, but more likely you will get lost. So this is what competitive comes into part. It's not about like comparing yourself with others, like I'm the winner or he's the winner, but it's more like with competitiveness, you get a companion on your path with researching or in your future with AI. And there are like many ways to keep yourself competitive, like joining competitions. Like we have a perfect competition for the teenagers, and also you can like have a companion in your researches, and you can share your ideas, compare your ideas, and that helps you get farther and not get lost.
Thanks so much. So we got almost 4 minutes. Maybe a couple of questions from the audience here. If
there's anyone who wants to ask a question to these brightest, very successful speakers, if you could give the mic, I can give mine. Maybe address the question. I think I will put a general question. My name is Alexander. I am a student of program 360. I have this question that I just came up with. it was told that there will be some model in the smartphones, and from very early childhood, kids will start using AI. Obviously, that opens up new opportunities, and we were focusing that these opportunities will be used for some applied educational purposes. I mean, developing games is some proper application, but if they start to use AI, and if they are kind of frozen to AI, you know, just using it merely for entertainment, should we restrict them from using them, or they should go through their own way and grow themselves and understand what is good and what is bad in AI? And this is the question to, well, like to everyone. Yeah, I think I'll jump in. I think this is the task that was one of the tasks that was set by the president of Russia. I don't think there's one silver bullet for all of that. I mean, should you limit your child using the phone? You know, if your child has been growing from the smartphone, with the smartphone in hand from very early ages, that means that he's limiting himself, you know, in terms of communication with other kids and teenagers. So can you restrict them from ban them from using big models? I think you can. You know, just I don't think that they should have gadgets when they're very young, because sometimes it puts barriers to socialization. Thank you very much, Denis. Any more questions? Maybe one more question, and then we'll wrap it up. Sorry, I can't hear you without the mic. I just, kind of answering the previous question. So you said that restricting kids from LLM, banning them from using LLM and other developments of civilization will limit their socialization capabilities. But as someone who just recently have been very young, I would say if you restrict kids from using all these developments of civilization, will that not create an outcast from kids? You know, for example, those who had Nokias before in school were laughed at by other kids with smartphones. Maybe using LLMs, kids can fine-tune their communication skills if they're introverted. Maybe it would be great to think about that. Maybe it's a good thing rather than the evil thing. Also, being the moderator, unfortunately, we're out of time. But at the same time, everything that you have said, personally, I resonate with that, because this is the effect. Kids should not only hear the words from good literature, but also some swear words, obscene words, so that they know that they should not use them in while communicating with others. But as a father of 3 kids, I can say that sometimes when your kids are using screens for more than 10 hours a day, you think, well, maybe you need to kind of limit that usage, because it starts to compete with the real communication with other real kids, with homework, with sleep. So there are 2, extremes: to totally ban LLM, and the other one is to give full freedom. And people as well as kids can overuse something. But you know, it's like when someone is limited in terms of LLM, and there's just one kid on the playground because everyone else is using LLM and their parents allow them to use that. This is the scenario that we wouldn't like to see. Thank you very much and for the questions and for the comment and for this little debate that we had. I'd like to thank everyone. Unfortunately, the time is up and we're wrapping up this session on a kind of a suspended note. We have a couple of questions that were left unanswered, but anyway, I would like to wish all the participants and viewers to achieve great success and to be inspired by your work. And I would like to thank all of the participants. Thank you very much for giving such a great vision. I mean, the guys have proved to themselves and to the entire world that they're one of the best. And let them be the showcase of what can you achieve. Let them motivate others to achieve the similar level of success. I would wish a very productive third day of the conference, the Science Day, and I wish you all the success in science and research and its applied tasks. A round of applause for all of the panelists and a special thanks to Maxim, the moderator. Thank you for bringing together such bright visionaries. Obviously, we do thank the audience for the answers and the comments. I'm confident there are many questions. The offline guests, the guests who are present here, will be able to ask this question during the conference. I mean, you can meet the participants on the booth, in the booth area, and if you're connecting online, you can scan the QR code, write your name, and answer, and put your question. The most upvoted and interesting questions are going to be forwarded to the speakers. We would like to thank all of the viewers for your active interest and for your active involvement. Thank you for being interested and excited by science. It is the great feeling that it gives us. Our first speaker is going to talk about the new advances in bio-inspired meta-heuristics, where biological principles meet modern algorithmic approaches. The most progressive ideas on this topic, coming from the capital of Serbia, Belgrade. Let's welcome him, the Vice Rector for Scientific Research at the Department of Informatics and Computing of Sengidunum University, Nebojša Bakacin Jakula, with the report Latest Advances in the Bio-Inspired Meta-Heuristics, Theoretical Insights and Practical Applications.
Okay, hello everybody. It's very nice being here. My name is Nebojša Bakacin Jakula. I am from Serbia at Sengidunum University. I work as the Vice Rector for Scientific Research at Sengidunum University and Head of Applied AI Scientific Program. So today I'm going to give you a presentation on the topic Recent Advances in Bio-Inspired Meta-Heuristics, Theoretical Insights and Practical Applications. So we have many slides, so I'm going to try to be as brief as possible. So, okay, there's the second slide. So basically, this presentation is aimed towards showing some practical applications, which my research team and I were doing for many years, and all those research are published in scientific journals. So let's start with meta-heuristics, which is the main topic of this. So meta-heuristics are used for solving MP-hard challenges as optimization problems. And as we all know, optimization problems seek to minimize or maximize objective function. And the goal is to identify the global optimum. Here we practically focus our research on global optimization challenges where we have many local optimus and one global optimus. So in this case, traditional deterministic algorithms are not able to obtain a practical solution in reasonable amount of time. That's why we should use meta-heuristics. Meta-heuristics are methods which approximate solutions, so they're able to generate satisfying solutions with a reasonable amount of time. And again, one more important thing, since machine learning and deep learning is a prominent research areas, in machine learning and deep learning we have a problem which is called hyperparameters tuning, meaning that each model should be adapted for a particular data set and the data. So in order to solve the hyperparameters optimization, which is NP-hard challenger in the nature, meta-heuristics are good methods for solving this. Okay. Non-deterministic polynomial hard problems, again, are the problems which cannot be solved in a reasonable amount of computational time. That's why we can use meta-heuristics. And specifically, again, in machine learning, we have hyperparameters tuning because each and every machine learning model has many hyperparameters that should be tuned, because each model should be adapted to a specific problem. And this is NP-hard challenge because we have a very vast search space. Okay, so I'm going to skip this. So one of the most commonly used in the literature NP-hard challenges is this traveling salesman problem you can see on this slide. And the characteristics of TSP challenge is so-called combinatorial explosion because if we have n instances, n cities, the n factorial permutations are in TSP, so it means that the search space becomes too large. And meta-heuristics are good in solving this. But basically, when we talk about NP-hard challenges, we have two types of problems. One is combinatorial problems, like this traveling salesman problem. Another is global optimization problem, where the goal is to minimize or maximize some function with real numbers. Okay, again, meta-heuristics are good for solving NP-hard challenges because they're very fast. They're able to generate approximate solution, meaning satisfying solution within reasonable amount of computational time. So for solving NP-hard challenges, we're not able to use deterministic algorithms. These are the algorithms which for the same input always generate the same output. So we cannot do like the brute force like with these deterministic algorithms. That's why we use meta-heuristics, which are able to find satisfying solution, but in a reasonable amount of computational time. Okay, there are many types of meta-heuristics, and there are also many different taxonomies of meta-heuristics we can find in the literature, but here is only one taxonomy. So meta-heuristics can be trajectory-based, like simulated annealing, taboo search, and so on. And these are also known as the single solution meta-heuristics because they work with only one solution. Then we have so-called population-based meta-heuristics. The population-based meta-heuristics are working with a population of solutions, and they're trying to iterate to improve those solutions in so-called iterative process. And then they, at the end of iteration, which is set of iterations is called a run, they output the best solution. Some of representative examples of population-based meta-heuristics are genetic algorithms, particle swarm optimization, variational neighborhood search, and so on. These are well-known meta-heuristics. And finally, one of my favorite types of meta-heuristics are bio-inspired meta-heuristics. Bio-inspired meta-heuristics are inspired by the nature. So nature is wonderful. In the nature, we have wonders. So the researchers were thinking that if we are taking some principles from the nature and incorporating into artificial algorithms, that we can make something good. And they were right. So that's how the field of bio-inspired or nature-inspired meta-heuristics emerged. So when we talk about the bio-inspired meta-heuristics, we can divide those methods into two groups. First is evolutionary computation. The most prominent example is genetic algorithms, genetic programming. And then we have so-called swarm intelligence with many examples, like particle swarm optimization, ant column optimization, BAT algorithm, Firefly algorithm, cuckoo search algorithm, whale optimization algorithm, Harris-Cox optimization, and so on. And my research team and I were working with all those types of meta-heuristics. We're trying to improve them. And currently, we are working on our own meta-heuristics, which will combine successful components like exploration mechanisms from these different meta-heuristics. But there is also criticism about the nature-inspired metaheuristics, and if I have time at the end of this presentation, I will tell you what are critics about these metaheuristics. Okay, so these are examples. Okay, now I'm going to show you some practical research, and this research was done by my research team and I, and all those research is published in state-of-the-art journals. Okay, so this research focuses on hyperparameter tuning of machine learning. As we all know, one of the most, rapidly development area of AI is machine and deep learning. And as I mentioned, there is a problem of hyperparameter tuning because in machine deep learning we have so-called NFL, no free lunch theorem, meaning that we should adapt each and every machine and deep learning model to the particular task. Because machine learning, deep learning models have parameters which are not being adjusted during the training process, and those parameters are called as hyperparameters. And this is MP hard challenge because the search space is vast, so we used metaheuristics to adapt and to tune the hyperparameters for specific challenge. And now I'm going to try to be as brief as possible to show you some of the research which was published in state-of-the-art journals. So first we have a variable neighborhood search from LSTM, from theory to LSTM applications. So the first, the first is NeuroVNS. So we used VNS to optimize the long short-term memory for EEG anomaly detection. So as we all know, EEG is a non-invasive tool for recording brain electrolytic activity. But manual analysis is prone to errors, which is called also inter-observer variability. So the goal here is to detect anomalies like seizures, EEG signals, by using the long short-term memory, and long short-term memory model should be adapted for this specific challenge. So this is basically time series classification. So we took publicly available data sets from Kaggle as well as some other data sets. Okay, we use the VNS, Variable Neighborhood Search Metaheuristic, which is one of the oldest one and which is very well known. So they're using the core strategies like all other metaheuristics, which drives the process of exploration. So when testing the basic VNS, Variable Neighborhood Search algorithms, we noticed some deficiencies, especially in the exploration. So we tried to improve these metaheuristics. In order to improve the exploration process of metaheuristics, we used the following strategies: chaotic elite learning, and we used the logistic map for diversity. Then we used the Levy flights, which enables the long jumps. So if the search process gets trapped in some of the suboptimal domains, then we can use Levy flights to make long jumps to, go to some other promising region of the search space. And finally, we performed the hybridization with a well-known Firefly algorithm, which is known with its very good, outstanding exploitation capabilities. Okay, so we name our approach the VNS with dynamic strategy change, VNS-DS, and here is the pseudocode of this algorithm. I'm not going to, explain this. You have this in the paper which was published. So we applied this improved VNS with dynamic search strategy algorithm to LSTM hyperparameters tuning, where we tuned various LSTM hyperparameters like the learning rate, dropout rate, number of layers, epochs in training, number of neurons per layers, and so on for EEG anomaly detection. So this is the flow chart of our proposed approach. Okay, so what did we do? We took the data set with 5 patients. So the patients A and B group of patients, they were completely healthy. The patients with group C and D had epilepsy, and the group D is the epilepsy with active seizure. So basically, we performed 3 types of experiments. First is simply binary classification to distinguish between the healthy and non-healthy patients. Second one is again the binary classification but the data set in the second experiment was imbalanced. So it means that we should use a different error function, different fitness function, not just the error, for the imbalanced data sets. And we used, in this case, Cohen's-Kappa coefficient. Another, fitness function which is very good for imbalanced data set is MCC, Matthews correlation coefficient. But in this research, we saw that the Cohen-Kappa works better. And finally, in experiment 3, we used the multi-class classification, where we had healthy patients, patients with epilepsy, and patients with active epileptic seizures. And according to experimentation results, our VNS with dynamic strategy change performs the best, and the results were published in the state-of-the-art complex and Intelligent Systems Journal, where I am associate editor, and this paper was published first with editor-in-chief Mario Koppen, which is very famous, and with my colleague Branislav Radomirovic, who is here present, who is also representative on Serbia for this AAJ event. Okay, next application is dynamic PSO, particle swarm optimization, advancing CNS optimization with diversity-aware PSO. So what did we do? So, as you know, the cybersecurity is very interesting, important area, because there are a lot of cyber threats and so on. So we named this application the MetaGuard. So CNN convolution neural networks enhanced intrusion detection system for IoT metaverse security. So there is a problem with traditional intrusion detection systems in the realm of cybersecurity. They suffer from the high false positive rate, so that's why we should apply machine learning to make them more smarter. So what did we do? So, okay, I'm not going to use the slides for this. So basically, we created a two-layer framework. In the first layer framework, we used the CNN, convolutional neural networks, which are good for working with images, but also they're good with textual data for extracting useful information from the textual data, like extracting the features. And then in the second layer, we basically replaced the final, dense layer in the CNN architecture, which is used for classification, with some traditional baseline machine learning models, like AdaBoost and Categorical Boost, for doing the classification itself. And again, in the both layers, layer 1, layer 2, we use this diversity-aware PSO, which is our improved version of the PSO algorithm, to do the hyperparameters tuning. So basically, this research is really, rich of experiments. So again, we tested the basic PSO, particle swarm optimization algorithm, on standard benchmark set on the CEC functions, congressional evolutionary computation functions, which is the standard benchmarks for these types of problems. And we noticed that the PSO emphasizes exploitation over exploration. So exploration should be improved. Again, we did it by using a lot of experiments. So in order to improve the basic PSO algorithm, we incorporated a few mechanisms. So first, we implemented the quasi-adaptive learning in the initial phase of population generation. Then we used the diversity monitoring to monitor diversity of population by using the L1 norm. And finally, we use the dynamic update with the threshold. So what does it mean? It means that if diversity of population is below the threshold value, it means that we may have the situation of premature convergence of the whole population, which leads to poor results. And for this reason, we used this dynamic diversity update in dynamic threshold, and we measured the population diversity in each iteration by using the L1 norm. And again, our approach is named diversity adaptive PSO algorithm. Okay, here's the pseudocode. Again, I'm not going to explain this. You have this in the paper, which is published. Okay, so basically, yeah. Yeah, why? Okay, sorry. So, diversity-aware PSO optimizes CNN skipper parameters like learning rate, dropout, epochs, layers, neurons for IoT attack detection, metaverse security. So basically, again, the CNS was used in the first layer of the framework for extracting the features, while in the second layer, we used the categorical boosting and other traditional baseline machine learning methods for performing classification. Here is the flow chart of proposed framework. Okay, again, we use the famous SIS IoT 2023 dataset, which contains rich data about the cyber attacks for both the binary and multi-class classification. So we performed 6 experiments, 3 for the binary classification and 3 for the multi-class classification. And we used, because this data set is highly disbalanced data set, we use the MCC, Matthews Correlation Coefficient, as the objective function. And according to experimental findings, our proposed PSO, modified PSO algorithm outperforms basic PSO, VNS, genetic, as well as other 8 state-of-the-art meta-heuristics. So this is the distribution across 30 different runs of our optimizer. Okay, this is the convergence speed graph. This is the all versus rest performance and all one versus rest classification results. Here we can see the confusion matrix and precision recall curves. So this is the best CNN structure which was extracted in the first layer by meta-heuristics. And again, in this CNN architecture, we replace the final dense layer with those baseline machine learning models to perform classification. This is the paper which was published in the journal Engineering Applications of Artificial Intelligence, which is very good. Okay, now we have application of the CryptoCast. So what did we do now? In the CryptoCast, we try to forecast the Bitcoin price by using the modified sine-cosine algorithm with variational mode decomposition for time series decomposition and long short-term memory. So as we all know, the forecasting of the prices of cryptos is very important. So for forecasting the price of the Bitcoin, we use a few features: S&P 500, VIX, Euro USD conversion rate, exchange rate, Great Britain pounds USD exchange rate, and the tweet volume. And since this is a time series which is very complex, which is non-stationary time series, we use the VMD, variational mode decomposition, to decompose the original signal. And then in the second layer, we use the long short-term memory and bidirectional long short-term memory to do the classification, to do the forecasting, sorry. Again, we devised the hybrid self-adaptive sine-cosine algorithm, which improves the basic sine-cosine algorithm. Here's the flowchart of our proposed methodology. So again, we notice that the basic sine-cosine algorithm suffers from slow convergence and limited exploration in high-dimensional spaces. So that's the conclusion we drew by testing this on the Congress on Evolution Computation test functions. Again, we incorporated 3 modifications in the basic sine-cosine algorithm to improve exploration. Again, I'm not going to talk about this. I don't have enough time, but you have everything in the paper which was published. This is the pseudocode. Okay, this is the best extracted long short-term memory, architecture. And again, finally, at the end, we applied the Shapley additive transformations, explainable AI technique to see which feature has the most influential impact on the outcome. And again, here's the root mean square error which was used for the fitness function. This is the SHAP diagram, and this is the paper which was published. Okay, now we also applied some kind of research for environmental sciences. So we applied hybrid meta-heuristics for Thulen behavior modeling. So as we all know, Thulen is a neurotoxic aromatic hydrocarbon. It's a major volatile organic compound, or VOC, known as for its abundance. So what did we do here? We tried to, predict the amount of Thulen in the air by using the extreme gradient boosting XGBoost tuned by the hybrid Reptile search algorithm. So Reptile search algorithm is another nature-inspired meta-heuristics. And again, by testing this on the standard sets functions, we observed some deficiencies, and we tried to improve this. So we try to improve the exploitation of the basic RSI algorithm by hybridizing this with the Firefly algorithm for better optimization. Here is the pseudocode of our research. Okay, we use the data set for the 2 years from the different measurement stations in Pančevo in Serbia. Okay, we can see convergence graphs, we can see the dispersion of results by using the box plots, diagrams, and swarm diagrams. Here is the comparative analysis, interest of the fittings function, which was the classification, which was the error rate, and the best values are marked with bold. As we can see, our model is the best. Okay, here are the SHAP diagrams. So we perform clustering by using the UMAP based on the SHAP values. Okay, this is the published paper. Then we use the RespiTune, PSO-Tune CNN for respiratory classification. So what is this all about? So we have a few audio signals for patients with different respiratory conditions. And we converted the audio signals into the images by using the MEL spectrograms. So basically, we converted the audios to images. And then again, we use the 2-layer approach. In the first layer, we use the CNN to extract the features from images. In the second layer, we use standard optimizers to perform classification. Okay, again, we use the Matthews correlation coefficient as the fitness function because it's good for the imbalanced data sets. And we use the meta-heuristics to tune this layer 1, layer 2 model. The meta-heuristics which we used is known as the genetic diversity guided PSO, and it achieved 97.8% accuracy with balanced precision recall for both healthy and ill subjects. Okay, this is the best extracted CNN layer, not layer, but structure, sorry. Okay. This is different types of visualization, like all versus one, rest versus one, precision recall curves, and so on. Okay, in the layer 2 framework, when we applied CNN for extracting the features from the images, we used the ADA boost, adaptive boosting, for performing classification. And in both layers of our proposed framework, layer 1 and layer 2, our method, a genetic diversity guided PSO algorithm, remained the best optimizer. And this model performed accuracy of over about 79%, which was very good. And this is a very practical medical application. Okay, this is again the best extracted CNN structure from the first layer. And these are the key findings. As you can see from the results, our method performs the best. This is the published paper. So if you want, I can share the papers with you. Then we have AgriPredict, meta-heuristics optimized weight agnostic neural network for crop yield prediction. So crop yield prediction is very important, thing in the agriculture and farming. So in this research, we use the 2 data sets, one the crop yield data set and one blueberry prediction data set. But here, in this research, we used lightweight networks which do not require extensive training. These networks are called the weight agnostic neural networks. You may see a lot about this in the literature. So again, we devised the 2-layer framework. In the first layer of this framework, we try to optimize the weight agnostic neural networks architecture. And in the second level of the framework, we try to optimize the weights of this. So we applied the reptile search algorithm again, but improved version of this. So we call this algorithm the multi-swarm RSA algorithm, where the basic reptile search algorithm suffers from poor exploitation as well as exploration. So that's why we combine the RSA algorithm with the Firefly algorithm and with the ABC, artificial bee colony algorithm. The Firefly algorithm, devised by my co-mentor or my PhD students from the Cambridge University, Xi Yang, exhibits a very good exploitation while the ABC algorithm devised by Karaboga and Bastuk exhibit very good exploration. So that's why in this multi-swarm approach, we combined basic RSA algorithm with ABC and Firefly. Okay, this is the pseudocode and algorithm, but again, you may look at this into my research. So again, as I mentioned, we use the two-layer approach, and this is the flow chart of our approach, as you can see on this slide. Okay, and according to experimental findings for the blueberry and crop yield data set, our approach obtained the lowest mean square error and R2 coefficient of determination. And this is the published paper in the very, very esteemed journal called Narrow Computing and Applications, published by the Springer publisher. Then we also have another application which is called All Forecast. So in this All Forecast application, we tried to predict the crude oil prices by using the multi-headed recurrent neural network. So what is it about? So predicting crude oil prices is very important. So we used several different features in order to predict the crude oil price. And we use this multi-headed recurrent neural network. So it means that for each network head, we enter the input, which is one feature. And then we use the self-attention layer, like in transformers, to aggregate the outputs of different heads. And finally, we got the output. And according to findings, this is a very promising approach. Again, for tuning this multi-headed recurrent neural network model, we use the variable neighborhood search algorithm, but in its upgraded form. So we use the diversity-oriented VNS algorithm. This is the proposed pseudocode, as you can see. And we managed to obtain the best results. Again, since I don't have enough time, I'm going to go fast. You can see everything in my research. I can share the papers with you if you want. Okay, then we went with optimized plant disease detection. I'm going to be very fast. So basically, we got images from the apples, leaf of apples, with 7 types of diseases. And we use, again, two-layer approach with convolution neural networks, and the data set was highly disbalanced. So we tried to predict which disease the apple leaf has. And then we used the model distillation and tiny machine learning framework to condense the model. So we then put this model on ESP32 chip and Arduino. And then we tried also to embed this on the drone, so the drone can fly over the, leaves of apples and to detect which apple has which disease and to put pesticides on this. Okay. Now, I also, at the end of this presentation, want to emphasize that there are a lot of different applications and fusions between meta-heuristics and machine deep learning, which is state-of-the-art. And this was also the topic of the Foresight session. So, first of all, we can use this fusion approach between meta-heuristics and transformers, diffusion models, and large language models. So, for example, we can use efficiently meta-heuristics to tune diffusion models, and diffusion models are the future of AI, and they're changing the foundation of generative AI, definitely. There are many real-world use cases. Okay. Then we can use meta-heuristics along with federated learning. This is another paradigm which is very important. In federated learning, we can train our models without exposing the private data, which is very, very important. And now, one of the most important challenges in machine learning is the scarcity of the data. We simply do not have enough data. And we have a lot of private data which cannot be exposed publicly. So that's why we can use federated learning. It means that the models are trained locally, and then only the weights of the models and architecture are being updated to the central component without exposing private data. So federated learning is very good paradigm. So in the federated learning, we can use meta-heuristics for, optimization, aggregation for privacy and efficiency. And the focus is decentralized learning in real-world settings. And there are many approaches in this. Then we also can use meta-heuristics along with federated learning for the security enhancements, which is also very good. And promising research field, we haven't performed research in this area, but we are working on this. This is very, very promising. And this has a profound real-world impact like in the healthcare, smart cities industry. And let's see the future perspectives of meta-heuristics development. So I should emphasize that there is a high criticism of the nature-inspired meta-heuristics. Because, there are more than 300 nature-inspired meta-heuristics these days published in scientific papers. But basically, in the nutshell, all those meta-heuristics are combining exploitation and exploration equations from the well-known meta-heuristics like variation neighborhood search, particle swarm optimization, genetic algorithm. So that's why we are dealing with those baseline optimizers, because all those other nature-inspired solutions, are simply using the components of the previous ones. So this criticism is on the place, and I'm fond of this. Then we also have emerging technologies like the quantum-inspired meta-heuristics, which uses some principles from the quantum computations, like the superposition. And each individual in population is called a cubic. It's, again, the term which was inherited from the, quantum-inspired computing. Then we have, when we work with meta-heuristics, we have sustainability goal. So we want to establish a green meta-heuristics, carbon neutral computation, and in order to achieve this, approach would be to make so-called efficient algorithm design. Okay, then there are a lot of research opportunities like self-adaptive algorithms with self-reflected AI, with AI feedback. So it means that we are using AI systems to improve themselves without human control, which is really good. Then the vision ahead is that meta-heuristics by the 2030 are going to be more adaptive, more stable, and we are going to have more trust in meta-heuristics and in general in AI. And finally, we have the paradigm, which is again one of the focus of this fourth session that we are having here. The multi-agent systems are autonomous agents which are working together in some kind of collaborative tasks. And multi-agent systems are very important in the AI. It's the novel field. And meta-heuristics can optimize coordination and decisions of the multi-agent systems. And the focus here is decentralized dynamic environments. So I can talk a lot about this. But again, I already, took all my time. So sorry for this. So, okay, on this slide, you can see that how meta-heuristics can be applied to multi-agent systems. Also, when you talk about multi-agent system meta-heuristics, they have profound application like in robotics, multi-robot exploration with, let's say, particle swarm optimization algorithm. Then we have application in the energy, like smart grid with multi-agent systems. And of course, in transportation, we can use the multi-agent systems along with meta-heuristics, for example, for traffic scheduling. Then the multi-vision of the meta-heuristics is so-called, we have adaptive dynamics. So meta-heuristics, according to our findings and according to the vision of other researchers, can cut the cost of implementing multi-agent systems as well as other solutions by even 30%. Because they're very efficient, they perform very fast computations, they generate approximate, not exact solution, so we can reduce the costs, but also we can have profound effect of environment. Okay, future potential, again, by using meta-heuristics with multi-agent systems as well as other profound technologies like diffusion models is profound. And basically, that's it. Okay, I apologize for, going over my time. I had a big presentation. Okay, so I had few researchers here shown in my presentation. If you want to know more about this, I can share my papers, okay? And everything. Thank you so much. Thank you so much.
Nebojša Bačanin Zakula.
Nebojša Bačanin Zakula, round of applause.
Presentation for your performance and for sharing with us your achievements. Еще раз ваши аплодисменты, громко, громко, громко.
Round of applause again. This is the third day of the conference. Science Day of AI Journey 2025, and another keynote speaker from Russia, Ivan Aseledets, is going to talk about the successes and problems of LLMs, where they increase the speed of coding and analytics, and where they experience barriers. A round of applause, and we're going to learn that very soon. The Doctor of Physical and Mathematical Sciences, Professor of the Russian Academy of Sciences, General Director of the IRIF Institute, Dean of the Faculty, Dean of Artificial Intelligence Department at Lomonosov Moscow State University, Ivan Aseledets, with the report Successes and Problems of LLMs. Good morning, everyone. On the one hand, I'm going to talk about the success stories. There will be some announcements from our institute. In the end, I'm going to go through some problems and what problems are we addressing, try to address, and what results and outcomes our efforts provided us with. 93 articles with A* conferences, so pretty good results. So that's more than any other centers who are engaged in this effort, which is good. But I mean, articles is not written for the articles' sake. We have quite a lot of practical applications, implementations, integrations in healthcare. And I think 30 speakers on this conference with their reports and presentations. So it's not only my presentation that is going to talk about that. We can walk a lot around the exhibition and see our results and applications. There was an interview of Andrei Karpaty, 1.5-hour interview. And it's great. And don't use summarization for that in ChatGPT or any other Telegram channel summarization of this interview, because it is really exciting. The topic that was not very evident for me and that I got really interested in is, sometimes the people say that LLMs, they just remember. We say that usually it works like that. We pre-train the model, we upload the data from the internet, we train the model, and the general public understood that, but some did not get it correctly, and they now we see the messages that, okay, look, an LLM can be trained on Reddit and Wikipedia. How can it be an artificial intelligence? It just remembers some trash and just regurgitates it in your search results. And yes, we can hear that opinion. And after we have explained how it works, we have to explain to the general public that they got it wrong. The LLM uploads a huge number of text. If we just talk about the text, that's text, okay, but hundreds or 300 of terabytes, because that might include videos and images. But if you look at large language models that are being published right now, there are models with trillions of parameters. The GigaChat, the flagship model, is 70 billion parameters. So the entire world is more of a 20, 30, 70 billions. There are some models that are a bit overflown with hundreds of billions of parameters, but you give them 300 trillion tokens, and you have 20 billion parameters at the output. So that's a very noisy selection and a very good compression. So if you take a piece of pre-training, even after cleaning it, you won't be able to understand how these models are trained. But basically what they're doing is that they do this absolutely outstanding compression effort. And if we talk about the main success story, it's that the community and the researchers as well as companies understood that now it's we know how to scale it. How do we improve the quality of these models on a system-wide basis? We get more data, we clean data, we label data, we launch new trainings, we get some new hardware. For that, we do it in a more efficient manner. There are new algorithms that appear. I'm going to talk about that later. So it's a kind of an iterative development, but we're talking about the scale of one architecture, which is Transformer, and which has become pretty successful. Although it has some problems, and I'm going to talk about that, and you can give many similar examples to that, but maybe the most radical analogy is the analogy with the Zeppelins. When people started to build them, you understood that you can actually scale them, you can make them larger and heavier, and they will become more efficient, and they can get more people on board. But then after the planes were developed, the Zeppelins were not needed anymore. You know, it might be the same with Transformers. If you look at the trends, at the research, people are trying to come up with next-gen AI. How do we get this experience that we have with the LLMs to create? How can we leverage it to create something more lightweight and quick? A couple of figures how it all works. So the super large model training is not started just like that. You use small models with 3 billion of parameters, but you need 512 cards to train any model. By the way, the scaling is reflected on the slide, but we're talking about thousands of GPUs, and you need to do a lot of experiments on the first stage to move to a larger scale training that takes months. This is where we're at right now, and there are no major alternatives. I mean, if it was easier, someone would come up with a solution. And the success stories are explained by the number of GPUs that countries were able to buy. USA, China, and Europe. We don't know the exact figures, especially for China, but I think these ones more or less reflect the reality. In the US, we're talking about 1 million GPUs in OpenAI, hundreds of thousands of GPUs in China, that's for sure, around 30,000 GPUs in Europe. That's one of the largest cluster. So for now, the more GPUs we have to get the more data, the better it works. It is a viable rule. But here we're not talking only about the hardware development. There's quite a lot of relatively small or more important algorithmic improvements. The improved optimization. Optimion became a very important improvement, and here we have Leon Sophia, of course, and many other things related to the optimization of communications, mixture of experts. All of these are architectural improvements where we still work in transformer paradigm, but we get the speed up improvements of 10-20%. If you look at the token parameterization, went down in a year by tenfold. If the cost of the token costs 10 times less, that means that we can do the inference 10 times quicker. So the algorithms are developed. if the algorithms are being developed and being sped up, why do we need all these GPUs? But this first step, meaning the 1,000 various experiments with various architecture, means that you can do more experiments. That means that it's not that you have one very costly launch where you try to train your model, but you have thousands of options on the small scale, and then you scale it to a large launch. So for now, that works like that. I mean, it would be great not to use that many GPUs and to get some great ideas. And there are some ideas that emerge. For example, DeepSeek, that made the reasoning technologies much more affordable and boosted this story really. And that was 2025. In February, and I think it looks like it was such a long time ago, but it was just done in February 2025. So one of the areas of LLM development is scaling or hyperscaling. These are algorithmic improvements on the level of math and low-level optimizations. There's quite a lot of things to gain there, and obviously the procurement of new hardware. That's one of the areas. Does that mean that we're approaching AGI? I think absolutely not. So this story related to large pre-trains is in some way saturated. I guess we need to go back to the start of the day. There was a fantastic session related to the there was a fantastic panel. The guys were participating in contests, and right now we are on the level that we do contest winners with LLMs. They can quickly resolve problems, the solution to which is already known. You know, don't want to sound evil, but I've never participated in Olympiad contests. Olympiads and contests are very great, but you know, being a professional athlete does not mean that your people in your country will be healthier. The same with the Olympiads. These are the tasks that have been already solved and can be resolved and can be solved in 2 or 5 hours. And scientific problem means that there is no solution, and this is what you need to resolve. So I think this is the way, not only our way. I think that the Chinese scientists champion this way, that creating AGI means that we need to create the systems that first resolve the problems that are first of all very important for the humanity and for the economy, and secondly that we don't know how to resolve. A couple of examples is healthcare, new drugs, new pharmaceuticals, designing and talking about materials. If you talk about the construction, I mean, you understand that's a daunting task. And when you get this daunting tasks and you ask ChatGPT about that, about resolving that task, they will give you a rubbish response. But what do you do about that? How did they resolve this task in healthcare?
Their solution was very simple. Let's collect all textbooks and examination questions, and let's train the models to pass exams. GigaChat was great at a medical exam for different specializations. Does this mean that such systems can be doctors? The answer is no. Why? Because these test questions have nothing to do with actual complicated practice, which is reasoning, clinical thinking, and as for the data, it's not millions of examples, but dozens, hundreds of examples, hundreds of cases. But that should be treated separately. When you are trying to solve a complicated problem, you are trying to think of ways to make an LLM into a multi-agent system. There are a lot of new emerging tools here that have to do with the fact that we need to write sophisticated code. In May this year, AlphaWolf DeepMind published this paper, which showed that an LLM can in fact write code by itself and solve problems by itself if and only if you can check if the solution is correct. So you can ask it to solve an equation or or write a difficult equation, or in the simplest case you can ask it to write a prompt that helps you solve a specific problem. You can submit the prompt, you can start the system, get the answer, and get a benchmark metric and check if the answer is correct. Such algorithms are for the lazy people, such as myself. You simply set a task for it, you ask it to send you back an answer, you check the answer, and then you ask it to rewrite the answer again. And then there are all kinds of tricky evolutionary algorithms where the mutation algorithm is the LLM model itself. It has its experience, it has memory, a program of outcomes, it has its insights, what it came up with, and its goal is to combine those insights into new programs. First author of the paper by AlphaEvolve is Sasha Novikov. He's my postgrad student. He left the country a long time ago, but we're still in touch. And there are a lot of not less talented people at the institute. One of them is Valentin Khurkov, who analyzed it for a month and got its own result. We called it Giga Evo. With extended functionality. It's an open source model. You can check it out for yourself. Here's an example of how it works. First, practical problems, and then an example with a mathematical problem, positioning of triangles. It does happen, but there are practical cases as well. So, as I said, you can download it, you can try it. It works with any LLMs for practically any problem that you can try to improve. We use it to improve prompts, for example. We also improve regular ML models, and we improve multi-agent systems. So we give it a multi-agent system as an input, we give it a benchmark and ask it to rewrite it again and again. You just leave it for the night, you come back in the morning and see what it came up with. You can connect an open router or locally deployed inference, but still you can see on the chart that the quality of the model, the quality of the generated program grows after each generation. A huge case, we've invested a lot in it. The main goal now is to collect a large enough quantity of cases, of use cases, because once we've done that, we will see what is the uniting factor for this strategy to solving problems. Another thing that we are bringing to open source, we have been working hard on multi-agent systems, making assistants. Well, that said, everybody's making assistants. Any one of you can make an assistant, a multi-agent assistant, in 30 minutes. But what do you do when it makes a mistake? We have worked out an approach based on the Maestro framework that lets us decompose a problem. It's a methodology framework. So a problem like medical diagnosis or presentation by demand. How do we check each step? How do we optimize it? How do we implement it? It's rather elaborate, complicated, multifunctional framework. There's a lot of other institutes can take advantage of that we would like to share with everyone. This is a detailed description of our approach related to the train of thought. The chain of thought. We decided that it will be much more useful as an open source model rather than a closed platform. We have a backbone for developing agents, and we have this evolutionary thing that can improve these multi-agent systems. We will be combining the two, meaning that our approach at the moment, our approach to the development of AGI is about, first, selecting complex problems, second, building systemic multi-agent systems that can guarantee accuracy in problem solving, and this is an intermediary step. Why? Because such systems learn, or rather not learn, but we make them solve problems well, but then they start generating a lot of synthetic data. So we are handling the problem of data deficit in difficult industries, in complex industries such as healthcare. They don't have these chain of thoughts. So a multi-agent system is an intermediary step, but without them we will not be able to progress further. And now the rest of my presentation will be about the problems that LLMs are facing. And I would like to highlight this paper that really inspired me. This is a piece of purely academic work. The group led by Amon Shashua from Israel. He's this great guy. They showed that there are problems solved algorithmically, but at the same time, we cannot use FT or Rally or any other approaches. We cannot learn the correct solution. Very simply put, there is this repositioning of vector elements, and there are vector elements plus one, and we want to determine the target. We do not know the P, but we can have as many pairs of X8 and Y8 as we want. A simple problem, and it shows that even if you have these chains of thought that lead you to the correct answer, you will need an exponential number of these chains. The idea is simple. It can be described in layman's terms. How do we do it now? We have a problem, we have an answer. The main approach now is through chain of thought. We need to make 10 steps. We've written 20 versions of the way that we want to handle the problem, and then we train the model to predict the next step with 0.8 accuracy. So it's predicting each new step with 0.8. We take 0.8 to the power of 10, and you get the rate of accuracy with which you will progress along the chain of thought to the correct answer. But if at some point it makes a mistake, everything else collapses. In training, we do not have the rollback one step function. There is an interesting solution proposed in this article. The article is also interesting in that it doesn't have any experiments. It's a purely academic mathematical paper. An alternative approach. What if we try to think of why is it happening instead of just pumping in data? And it's true that if we were working with complex problems, we see that it generates steps in a very plausible manner, but if you give it certain freedom in terms of these steps, the rate of error, the rate of mistakes grows colossally. Another problem is lack of memory. When you open the chat, each and every time, it greets you as if for the very first time. Maybe it does retain some basic information, what's your name and the rest, but overall, when it's interacting with you, it's not learning, but it's just remembering certain episodes. If the discussion is very long, or if we want to upload a knowledge base, the problem that attention is scaled quadratically persists. At the Institute, we have a lot of interesting papers. For example, the team led by Mikhail Burtsev and now led by Yuri Kuratov, with this group, we try to come up with new architectures which do not require quadratic scaling. One of the approaches is neuro-inspired. It's associative recurrent meta-transformer. In science, when you come up with an idea, this idea starts to inspire other researchers. Titan became a solution inspired by ARMT, so it's one of the approaches that is currently gaining traction. It's very interesting. You can train a small model, but the main problem is you come up with a new idea, a new architecture, it's great, you try to scale it to the same amount of tokens, the same scale the transformers use for learning. But then it turns out you need to reinvent all the heuristics all over again that underpin this large-scale learning. And then what you do is not maths, but something closer to engineering. Another interesting paper by Yuri Kuratov accepted in oral form at the ICL conference with a very simple idea. What we showed was we can take 1,500 tokens and we can compress them without losing any information into a single vector. The space in which language models operate is way bigger. It takes up we give it much more space than they actually need. This paper was very interesting for a lot of international researchers. For example, I visited China. I start talking about this paper, and then people start raising hands and saying, "Oh yes, we know this paper. We are already trying to borrow some ideas from it," which is why good research papers are so important, because they become sort of a business card for you, your signature. It gives you credibility within the community. It's very important to talk about what you're doing in the form of a research paper. So compression is great, but how do you get this compression representation fast, and how do you use it for generation? Actively working on that at the moment. And this is my paper together with Gleb Mezentsev, saying that while in Kuratov's work we are taking the vector to decode token by token, here in this case we took a step further and decided that we can decode in a way that we can encode in a way that decoding will only take one forward. 64 instead of 1,500, still a compressed representation, and it allows you to work with continuous vectors rather than discrete vectors. I'm mainly talking about our own papers. Penny Lee, our PhD student, an employee of IRI, we thought about the following problem. What if you have a maths problem without a clear solution? If you have this clear solution, you can use GRPO, you can use reinforcement learning, but it turns out that large language models can be trained even if you do not have the correct label. The idea is you ask the same question 10 times, you get the answer 10 times, 10 different answers, and the most frequent answer will probably be correct. So as Baron Munchausen, you start to pull yourself up by your own hair. So the model is training using its own answers. This drastically improves the quality of work with mathematical benchmarks and code without any labels. You can do a lot of interesting things with this. I have just 2 minutes left, and in the 2 minutes I would like to discuss other architectures. Diffusion models in text are emerging, and I really like it. Diffusion models are now at this new level where you can scale them. They have reasoning. Google has announced Gemini Fusion. They haven't published it yet for a number of reasons. But the idea is that we're not generating text using just one token, but we're trying to generate all of them, all of the portions, just in different places. The mathematics there is absolutely gorgeous. You significantly speed up inference several-fold. You go to ChatGPT, and instead of waiting for it to reason, it starts writing the answer straight away. This will drastically improve the quality of user experience. Some other ideas, many of them are available are discussed in this interview by Karpati. What we would like to see is a model that trains during inference. You ask it a question, it answers something, and it has learned something. There are examples of this. The Confidence is All You Need paper is describing precisely that. We take a model and we make it learn using its own answers. It's just that gradient learning steps during inference is very costly, so we need alternative learning methods. A lot of people are thinking about how to do it best. They try using the old Hebbian rules. It gives small changes, but still, we can draw this analogy with what we do during the day, and then we go to bed in the evening. During our sleep, our neural networks continue to learn, and then we wake up in the morning, and there you have it, some new experience. Models currently do not do that, and this is something that we want to ensure. Also, it's completely unclear what this model should look like. I can share with you my hypothesis, and there is some consensus on this. The size of the model is not the key factor. Models with trillions of parameters just a year ago are more stupid than current models with just a few million parameters, or a few billion parameters. So we're talking about a model that can do reasoning, logic, has basic knowledge, and has access to search, internet, and databases. My near-future vision is that we will have a model for 20 billion parameters and then a 2 billion parameter model that can do this well, but doesn't have any excessive knowledge, because with trillions of parameters, you put in a lot of excessive information which the model doesn't need at all for learning. And that's pretty much it. That's my presentation. I have a Telegram channel. Join it if you'd like. Thank you for your attention. A round of applause for Ivan Osiledis. The interpreter does not hear the speaker.
Профессор университета Сан-Паулу
Professor of São Paulo University, Alexandre Ferreira Ramos, characterizing the regulatory logic of transcriptional control at the DNA sequence level by ensembles of thermodynamic models.
Hello, good morning. So it's a great pleasure to be here. I'm honored to come. And thank you for the organizers for making my travel to Moscow so smooth. So today I'm going to talk about framework that we developed for characterizing the regulatory logic of control of gene transcription by means of an ensemble of DNA sequence thermodynamic models. This model was, they were validated using Drosophila embryos. And one may ask, what is its relationship with the artificial intelligence journey here? So sometimes to see, one needs to go beyond the Earth to see that it is blue. So it's perhaps we could look at biological systems and see that to each element involved in a typical artificial intelligence process, there will be some correspondent in biology, and that correspondent can be useful for enhancing our artificial intelligence models. For example, by offering inspiration on finding loss functions, or to figure out good dynamical systems that would enhance optimization processes. So the outline of this talk is, we first would like to introduce some concepts which can be useful for us to state the cells as entities, computing entities, specialized in learning in the statistical sense of the term. Then I would like to demonstrate that, discuss that by means of some experimentally established facts. Then show our technique for understanding the regulatory logic of transcription in metazoans, multicellular organisms, and in the end, to present some concluding remarks. So in short, if we were considering computing as Turing devised, we could consider that we need an alphabet, we need an infinite tape, we would need a states machine, and we would need a head that would be capable of reading and writing into this infinite tape. And our state machine would react to the information contained into that infinite tape. If we look close in the flow of genetic information that is taking place inside the cell, we can map each of the elements that are happening there as a Turing machine. So we would have the tapes that can be either the DNA or the RNA. We have an alphabet, which is composed by the nucleotides, ATCG. We do have a writing machine, a read and writing machine, which is the polymerase, which takes the information that is in the RNA and translates it into a sequence of amino acids. So the sequence of amino acids at some moment is going to become a protein into its folded shape, which will enable it to perform its function inside the cell. And we do have a states machine, which can be written in terms of the genetic code, which is setting the translation of a given triplet of codon of nucleotides into a given amino acid. So with this in hand, this is a very explicit formulation of molecular biological process in terms of as a computation process. However, there is one extra thing in the biology, which is that the information, it is regulated, so it doesn't come up anytime. It can come up sometimes or not, depending on the context. And that was seen back in the 60s by Jacot and Monod, who were investigating this little system of gene expression called lac operon, and in which they were showing that if there is presence of lactose, so this system is going to be expressing. However, if there is no presence of lactose, this system will not be expressing. So regulation here happens by physical blocking. So a repressor protein binds into a specific DNA site, and then it avoids the information to be expressed. So it's a genetic switch. So with those two examples of computation in molecular biology, we can have a phenomenological understanding of how we can consider what is going into inside the cells as a computing process. And that perspective was actually formalized by Lieberman from here, Moscow, and who did not only the theoretical but also several experiments to show that the cells are behaving as if they are following some algorithm. And this algorithm then must be discovered. So if the cells are operating algorithms physically, how were those algorithms learned? So when we are talking about learning, and since we are talking about cells being computing systems, what we should be, the perspective of learning that we should have is learning in terms of a computer program that improves its performance with experience. So this is, or in terms of statistical learning theory, the cells need to discover some function, biochemically, some function that enable them to perform well in the environment where they are located. So how was that learning learned then? Well, we can consider evolution. And two problems. So the improvement of performance happens as an adaptation. And of course, there are multiple ways of learning how to handle the environmental conditions. So there's also speciation. So besides learning how to adapt to a given environmental condition, it is possible to adapt in several different manners to that. That is interesting because if we are looking for ways of defining loss risk functions or loss functions, adaptation is one way of doing that, and hopefully we will be able to use that in our favor for improving artificial intelligence. Besides, we will see that there are multiple ways of doing this. So, if the cells are learning machines, we should discover the biological laws of what are the error functions, what are the equivalent of statistical models in terms of the internal machinery. So look, we are always talking here about some mechanisms that is implementing a given functional, computing a given functional. So in other words, we are talking about somehow Church-Turing hypothesis, physical realization of it. What are the input data, the ever-changing environmental conditions? So we are always learning, we are always living things are always improving. What is the optimization process? So this is interesting because is there any sort of a special dynamical systems that is defining trajectories within the, let's say, parameter space of DNA that are making learning fast enough to avoid that the living thing will be extinguished because it must learn fast enough. So let's go back to the information flow and remember that a genome may have billions of base pairs. It encodes multiple enzymes and it also has numerous biological mechanisms. And this part here is important because once a DNA learns how to handle environmental conditions, it does it encoding several functions. Let's consider in terms of representation theorem. So it's being done, it's adaptable, as we saw in terms of that example of lactooperon. If we inject lactose, it will express, otherwise it won't. However, there is a challenge here. If we look at the genetic code and we look at the DNA, we know exactly what are the proteins that are being encoded. However, if we are taking a look to understand how cis-regulatory code works, that means how our system, the cells adapt to the differential information that are coming in, then there is no clear picture of it. You know, I cannot put you guys a table like that states machine back on the previous slides. So there is a challenge. It's an open question that we need to solve. And in order to solve it, it is useful to have a good model system, like this beautiful fly here called fruit fly, Drosophila melanogaster, which life cycle is about 10 days. There is an interesting property of it, because when it is in this phase here as an embryo, when the cells still do not have any membranes, they do form some patterns of expression of several proteins along its anterior-posterior axis, which will correspond to the formation of segments which will encode the organs that are going to be part of the adult fly. If we look a little bit closer into this embryo here, what we see is that after a series of cell divisions, nuclei divisions, all the nuclei will be in the internal surface of the embryo, and there everything is going to happen, which means all the pattern formation of proteins that will give rise to the segments into the adult will appear. So this is a molecular resolution perspective. This is nuclear resolution perspective on the expression of several proteins inside the embryo of the Drosophila. And this is a maternal protein which will regulate the expression of those genes here that will form gaps. So here we do have a gradient. Here we will have a gap pattern of expression. That's why those genes are gaps. In the adult, there will be a missing part like a gap in the adult. And then there will be the so-called pair rule genes. They will form stripes like that, 7 stripes. And in the end, there will be the segment polarity. All of this regulation happens hierarchically, so the proteins that are above, they regulate the downstream and so on and so forth. So, and we will focus on the expression of this particular gene, EVE, and we will use it as our model system to try to understand how biological systems are learning how to encode a multiplicity of functions to deal with the environment within which they are. So if there is an information, as I said, information is not only encoded in terms of the sequence for a given protein, but it is in a given gene loci. It has a lot of DNA sequence that are not responsible for encoding for a protein, but actually to encode for regulation of the expression encoded here, of the information, of the expression of the information encoded here. So here we do have, this is the encoding, this is the regulation, including regulation of this protein, not only during the embryo phase of the life of this fly, but also when it is aged during its late time. There are also in the heart and so on and so forth. So there are specific, each of those segments are encoding regulation of this information to be expressed in specific contexts, and each of those green ones are encoding for the regulation of expression of those stripes here. And if we look inside each of these squares, what we will see is a multiplicity of binding sites for different transcription factors or proteins that are regulating the expression of this gene and ensuring that it will appear with this pattern at the proper time, in the proper quantities, and at the proper regions of the embryo as well, so that it develops viably. It's good to know that since we are talking about a model that we want to validate experimentally and with which we would like to learn the mechanisms of life to evolve and cope with its environment, data is obtained by immunofluorescence, which will emphasize the presence of specific proteins or its absence. This data is collected by microscopy and quantified, and then we can get a pattern, a spatial pattern of expression of a given gene along space and time by looking either at transcription factors, that is proteins, or mRNAs. And now another thing is to understand the regulatory mechanisms underpinning this. So what we have is multiplicity. The expression of the information not only depends on the binding of the protein to the DNA as it happened for the operon in the bacteria, but we are talking about a more complex organism. So it has a lot of additional effects of the interaction among bound proteins that are driving by increasing or reducing the expression of this gene in differential contexts. And this is important because that is what is providing the Drosophila embryos to learn how to express information into a much more complex manner than it would be if it was just a bacteria. So this is just a pictorial representation of the mechanisms of regulation. And what is important to emphasize is that there is not only the binding of the regulatory factors to the DNA, but also their interaction once they are bound. And then this is a view of what this modeling is doing. I regret that I didn't put the equations, but if we were looking at the, so for a given input, so a given regulatory profile in a given position of the embryo, this is along the anterior posterior region of the embryo. If we are looking at a given position, it will have a specific regulatory profile as provided by the concentration of the transcription factors. This is 2 different positions of the embryo. The DNA is the same, and if we were looking only at the affinity between the transcription factors and a given DNA region, some regions would be more favorable for the binding of a given protein than others. However, because of the concentration of those proteins, the vertical bars here indicate how activated a given region of the DNA is to induce transcription. What we would see is that there is a convolution, and this convolution will modify a preliminary configuration into refining and finally indicating the region that is going to be activated and inducing expression of this gene. So this is some sort of, we could say that this is some sort of, we could consider a representation theorem and use this as a neural network, of course. However, an interesting thing is that differential regulatory profile would cause adaptative weights for the neural network. As you can see, we can we can recover the pattern of expression, but we can also indicate what are the regions of the DNA that are inducing the expression of each of the peaks of the EVE gene. And this is really important because now we can sort of interpret how this function is leading to a observed pattern of expression. And we can also consider this problem as an optimization. So we do an optimization in order to recover that pattern, which has 2 steps: a regression that recovers the pattern of expression, and a classification that aims to recover the regions that are inducing the expression and classify them as corresponding or not to experimentally established facts. So some of the optimizations will be kept, others will be discarded because this pattern here is caused by the activation of this region of the DNA, and that does not correspond to experiments. All right, so, and if we look at the parameter space, we see that there is a wide range of parameter values that enable the same patterning. And that leads us to the second question. Let's suppose that this is not an artifact, but this is an actual biological phenomena, and this is some sort of a prediction. So, is it possible that a differential regulatory profile would provide the same patterning? And if we do this by looking at different species and taking the DNA of a different Drosophila species into Drosophila melanogaster, so we are taking the DNA of another Drosophila, another embryo, Drosophila jacoba, Drosophila erecta, Drosophila obscura, and then we are trying to see if we take this piece of DNA that regulates the expression of the EVE gene at the region that forms the second of those 7 stripes. Would it be possible for us to recover, changing the DNA, recover the same pattern of expression? And what we see experimentally is that, yes, it's possible. So you change the regulatory region, that means you are changing the weights of your neural network, and you are still getting the same output of your function either way. So that's a good thing. That means that eventually finding different regulatory regions causing the same pattern of expression may have a biological meaning, and then that leads us towards the need of using ensembles of models for multi-parametric systems. But if, let's say that we decide to go beyond, and instead of looking in Drosophila embryos, we decide to look in Sepsid, which is a very, very different species, quite a way separated from Drosophila. If we look at their DNA, the loci for even skipped gene, they differ a lot. And then let's look only at the stripe 2. You see, this is in Drosophila, this is in Sepsid, quite different. And then if we set the DNA region of the Sepsid into the regulatory profile of Drosophila melanogaster, put this piece of DNA here, and we look to see if we get the stripe 2. Look, we do get the stripe 2. So what it means is that we can have a degeneracy in terms of the regulatory region and still get the same functional, get the same information, the same genetic information or the same function into our system. So that is actually interesting because if we look at the DNA sequence differences, we see that Sepsid is quite away from Drosophilids. So it's remarkable that changing DNAs for so differently, we still can get the same pattern of expression. And that can be done using several different species, using the same model, with the same parameters, just keeping the same regulatory profile, that is the same concentrations of transcription factors driving expression of the gene, but changing the DNA sequence of the regulatory region. So what we can do is to get the same very useful patterns of expression, and we can recover what has been observed experimentally, either using a Drosophila species or Sepsid species. So that being said, I would like to come back to the understanding that, so can we use ensembles of models, ensembles of optimizations to understand regulatory logics, and can we learn a little bit more about how living organisms, how cells, they learned to process environmental information to improve their performance in that environment, and how they do navigate through their parametric space so that they can get good optimizations within a sufficiently short time so that they will not be extinguished? The answer is yes. And if we were looking for risk functions, what would be the ones? Well, we should search for invariant quantities. Interestingly, is that if we are talking about a Drosophila, we are talking about some thousands of genes. Let's say that those would be, and then we would get several gene networks, and those networks could be mapped as neural networks. So we would be talking about several neural networks, each of them having one invariant quantity. You know, the pattern formation is only one of the invariant systems inside the Drosophila embryo. And talking about gene networks, this brings us to the equivalent of the statistical models for predicting. You know, a cell must cope with its environment, so it reads input from environment, rewire it fastly, its internal machinery fastly, and adapt to it, respond to it. One example is if we had some milk during the morning, we promptly must know how to metabolize that, and that is done by activating operon. And then two interesting questions would be, how is the optimization process performed? So how do the cells fastly enough learn how to handle new stress? And that is a nice challenge for mathematics. And let's say, is there any sort of spatial dynamical systems? Who knows? So this is a nice question to be responded, and I'm pretty sure they will have some impact for the artificial intelligence field. So with that, I would like to finish and thank Alan Sabino, who did the work on the characterization, and Rieli, who helped on the optimization using simulated annealing, and Professor John Reinitz, with whom I have been collaborating to this project for a long time. So thank you so much for your attention.
Alexandre Ferreira Ramos.
Alexandra Ferreira Ramos, thank you.
Еще раз аплодисменты всем.
Once again, a round of applause for all our speakers. Many see AI as something similar to a miracle, but in fact, this miracle is managed by algorithms and mathematical laws. Where are the boundaries of the possible and what can be proved? Let's hear from the Berlin University professor, head of Stochastic Algorithms Lab and Non-Parametrical Statistics of Weierstraße University, Vladimir Spokojny, with a presentation on AI and mathematical laws.
Okay, nice to be here. I'm a mathematician from my background, and in my group in Berlin and now in Moscow, we're studying some foundations of artificial intelligence. And probably the central question we're looking at is whether one can explain the performance and behavior of any artificial intelligence system by mathematical laws. So this is a question of the study. And first question, which we are trying to understand, is what artificial intelligence system is really doing. And can we explain very popular system like deep neural networks or large language models or generative models by mathematical laws, and what these mathematical laws are, so actually. And whether, if we succeed, whether we can predict the performance, explain the range and scope of applications of any artificial intelligence system. So this is the outline of the talk. My first question is what artificial intelligence is. So could one here in the room explain a few words in one sentence? What is artificial intelligence system? Any guess from you? Yeah, so, no? Okay. This is very simplified but useful answer. Actually, AI is a computer with a huge computing power and memory trained by large data available nowadays. So this is a very simplified answer, but it is useful to understand what is happening with the artificial intelligence system. Okay, now the next question. What artificial intelligence is doing? Again, any guess from the room? Predict. So another answer? Machine learning. So it's synonymous. So I would say artificial intelligence is machine learning.
Essentially, artificial intelligence does this. It does not have to follow a specific algorithm, but based on the data that it used to train, and based on some input data that it receives for processing during its work, based on all that, it can make a decision, classify something as something that belongs to a target class or not, etc., depending on the task you set for it. It can be flexible.
Okay, thank you. It's a very nice attempt, but now my version. If you want to explain what artificial intelligence is doing, actually, this system or this computer try to solve some optimization problem. So this is mathematical answer. Okay? Now, again, if we look from this perspective, the next question is, what are scientists in the history who made the main contribution to artificial intelligence? Again, you can guess, probably because of lack of the time, I will give you my unexpected answer. So, these are Newton, Leibniz, Gauss, Legendre, and Fisher. Okay? So, Newton and Leibniz, in the middle of 18th century, introduced a general method of optimization based on the first and second order differential calculus. Then Gauss one day developed a new method of nonlinear least square regression to solve some astronomical problem. And then, so he considered this as unfinished and didn't publish this paper. Then Legendre rediscovered this nonlinear least square method, and then Gauss developed new Gauss-Newton procedure. And Fisher, around 1920, formulated the principle of maximum likelihood, which is actually a universal method to solve statistical problem by reducing this statistical problem to optimization. This is the method of maximum likelihood. Okay, now I explain you what the essence of Fisher approach is. Actually, you have somehow the objective function you want to optimize. So Fisher suggested log likelihood as an objective function, and the method of maximum likelihood we tilde is the point of minimum of the negative log likelihood. So because it's maximum likelihood, so we want to minimize in optimization, so it's negative log likelihood is L of V. Now the next question is, this is what the procedure gets out of the data. So this L of V is based on the parameter V we want to find and the data. Data is hidden here in this log likelihood function. Now the question is, what is the truth, what we want to discover? What is the optimal parameter? And actually, Fisher shows that this truth can be formulated as another optimization problem, which is based not on the data, but on the data distribution. This means the only difference between these blue and red problems you see on the screen is that in the red problem, you take expectation of the log likelihood, which means you replace the data by their distribution. And actually, it appears that more or less all statistical procedures known nowadays can be viewed as within this framework of Fisher. And now mathematically, what this means? Mathematically, this means actually that we are looking at the problem of perturb optimization. This means the ideal solution is a red one. And the ideal parameter V star is defined by solution of the problem based on the data distribution, but we don't know this data distribution. And what any statistical method is doing, what artificial intelligence is doing, it is trying to solve empirical version of the real optimization problem. And the question is here, what is the discrepancy between V tilde and V star? So this is a mathematically perturbed optimization problem. Okay, now I will explain you what is the problem of modern statistics and what are mathematical phenomena behind of this by means of two examples. I start with a very simple example, absolutely classical. So it's about logistic regression. So what we're observing are the labels yi's and the corresponding feature vectors psi's, which are p-dimensional, where p could be big, large, or even huge. Okay, now what we want to build is to built a predictor, is a function of the feature vector, which explains the probability of the response of the label, given this feature vector. And due to Fisher theory, the solution can be given by the maximum likelihood principle, which is written on the bottom. V tilde is a minimizer of the corresponding negative log likelihood. So this is the classical problem. And if you follow the Fisher theory, then you see that the behavior of the estimator is well understood. And in particular, you know that this root n accuracy, n is a sample size, and even the limit distribution is known and described by the Fisher information matrix here. And this is a classical result in any textbook. Now, the question is what happens in the modern setup? What is the problem nowadays? Okay, now you can think about, so maybe the same story as Euclidean and Lobachevsky geometry. So, I mean, for the Fisher theory, there are some assumptions here behind this. One of the major assumptions is that the P is fixed and n goes to infinity. This is the analog of Euclidean two parallel line never cross. Yeah? Only parallel line never cross. Now, in the modern statistics, the problem is that n could be probably moderate or even small, and P is huge. So this is so I mean, parallel lines, not only non-parallel lines, do not cross. So this is the same story. And it appears that if we change the setup, immediately new phenomena arise. And I only show you the small list of new issues, challenges, and phenomena discovered in the context of the logistic regression. And in particular, it appears that if P is larger than n, the method of maximum likelihood does not work properly. And maximum likelihood estimator even doesn't exist in some situations. And you need a kind of regularization. So the other colleagues, so Bartlett, Montanari, Saravagiar, studied the problem of impact of the random design here when empirical Fisher information matrix behaves not like the true Fisher information matrix. And in particular, Sir and Candace is sure showed that there is a kind of bias in the maximum likelihood estimator which actually cannot be explained by the classical Fisher theory. And this is only because of the random design. And it appears in this setup you need somehow another theory, another law. And then people discover some new phenomena. In particular, this phenomena, like double descent curve, hopefully known to you, which means if you do overfitting, at some point the quality of generalization becomes very poor. But if you increase the number of parameters, suddenly you can achieve a perfect fit and very good generalization. Again, no chance to explain this by the classical Fisher theory. And people also discovered the method of the second order developed by Newton doesn't apply here. You need to go back to the first order method, which can help in this situation. Okay, so I started with study of this problem, and it realized that this simple problem requires to develop new results and new methods in the study, which relies on different mathematical disciplines. In particular, perturbed optimization, random matrix theory, theory of random tensors, and regularization for inverse problems. So I don't have a lot of time to go through the details. So maybe I show you one result in the perturbation theory, which is depicted on the bottom. So, and it explains the discrepancy between the perturb optimization problem and the original optimization problem, so V circ minus V star. And this discrepancy is actually given by this blue term F minus 1a. I don't explain the notation, but this is what is called Newton correction. Newton develops this correction. This is the leading term of the discrepancy, and this result only apply in the right-hand side of this expression is relatively small. So this result, which is depicted here, is dimension-free. It applies in any dimension of parameter space. This means P could be arbitrary, even if infinite. This result applies, only what you need is the red term is smaller than the blue one. And this gives maybe new law, so I jump over the other details, and I will explain you the main finding of our study. So what we discovered here is that the Fisher condition, that the parameter dimension is much smaller than the sample size, can be replaced by new condition, which means that effective dimension is smaller than effective sample size. So this means somehow we can define new notion of effective dimension. So you can think about effective number of parameters you need to estimate. And this effective number of parameters should be smaller than effective sample size, which is described via the eigenvalue decomposition of the Fisher information matrix. So this is a kind of new law, which is extension of the classical Fisher theory. And actually, it applies to any AI system. So, and what? So maybe I stress my view on the mathematical laws. So mathematical laws are the physical laws, like a law of Newton. If you have an apple and you leave this apple to fall, it will fall down. So this is a law, physical law of Newton. And if you formulate the mathematical law, it should be like this. If you follow this law, it should work. Yeah? Without any training, Newton, fine-tuning. So this is because there is a law of the nature. And so we did some small simulation study only to illustrate this, and we realized, we apply this. Actually, what is depicted here, I don't explain the setup, only point out, you see two curves, blue and pink. Okay, they look very similarly. Probably you cannot see the scale, but for the blue curve, so this is the error of estimation. You see the central point is around 3. And for a red curve, which is error after first order correction, which I described in my main theorem, it is around 0.3. This means the result which I showed you really applies here and leads to improve of the accuracy by factor 10. So this is a small illustration. And then we confirm this by considering different sample size and different dimension of the problem. So this is an example how the mathematical law apply. Now I will speak about another example, which is less trivial. It's about deep neural networks. And I will explain you something about blessing of dimension. I don't know if anybody is familiar with this curse of dimension and blessing of dimension. So for classical statistics, there is a kind of curse of dimensionality, which means the increasing of dimension makes the problem more complicated. Now we explain by means of this example of deep neural network regression that actually increasing of the parameter dimension can be helpful and is helpful. And this is by mathematical study. Okay, So we are looking at the deep neural network. Again, I hope everybody is familiar with the structure. What we are doing, we have original input vector x. You can think about images. And then you are doing kind of transformation of this original vector by sequence of layers. So this x goes through the sequence of layers. At every layer, you have operation, which is multiplication by the activating matrix W, and then by applying some nonlinear unit, sigma. OK? And at the end of the day, what you are doing, you replace original vector x by this transform vector, so which is this bold x. And you are doing usual linear regression using this new feature vector. So if you have a simple shallow network, you are doing only one transformation and then apply linear regression. So this is a mathematical description of what DNN is doing. OK, now we consider the training problem. Training problem means you have data, yi, xi. For shallow network, we have just one transformation. For deep neural network, we have capital K transformations. And the method of maximum likelihood, which actually Fisher method applied here, leads to this optimization problem. We build the log likelihood, how this new transform model explains the data, and try to optimize a set of parameters to build the best prediction. OK? So this is what the training of DNN is doing. And even if you only look at the mathematical literature on this, so you see there is a huge number of papers, ton of literatures about this. None of this explain really the scopes and limits of this DNN training. So people try to reduce the complexity using the idea of manifold regression, but I am not convinced that this theory explains exactly what it's doing here. So again, we'll come back to this issue of curse of dimensionality. First of all, which dimensionality is here mean? So is it the dimension of the feature vector, or it is a number of parameters in the model? So actually, for linear models, this coincides. So, but in reality, so this curse of dimensionality means the number of parameters in the model. And if you consider deep neural networks, the number of parameters is huge because you have many layers, and any layer involves the matrix of weights or activation. So you have, for a really deep neural network, a huge number of parameters. OK? Now, what turns out here, so again, because of a lack of the time, I only state the findings we discovered. And the main finding is that the full parameter dimension, P, actually doesn't enter the accuracy guarantees. Only effective dimension matters, and also geometric property of your objective function, which you optimize, matter here. And it appears that you can replace your original problem by another problem, which is even more complicated in the sense of number of parameters. But then you improve the geometric property of your objective function, but you do not increase the effective dimension. And then suddenly you get the situation when the training procedure works well. So here is a very brief idea how we increase the dimensionality. We replace the original objective function by another objective function in which we include in the set of parameters also all the transformations. So you have original vector x, you transform it at the next level, then you transform again and again, and each time what you get is also parameter of the method. If you increase like this, it appears that the problem becomes much more, much huger dimension. But, sorry for this, important is that this objective function becomes locally convex in the vicinity of the true point. And the effective dimension of this objective function would not increase. So this means increasing the list of parameters, you achieve the situation that your optimization problem becomes more tractable. You can apply classical method of optimization, and at the same time you have no loss in the accuracy guarantees. So this is a finding of this result. So here is a formulation. Actually, we managed to estimate each parameter of the deep neural network with the optimal accuracy. And even to get sharp risk bounds. Okay, now maybe I summarize what we discovered by these two examples. So first of all, actually, if you want to understand the behavior of any AI system, actually you have to look at the effective dimension of this problem. And this effective dimension matters. You can build a very, very huge model, doesn't matter. Important is effective dimension is smaller. Of course, computing in each example is tricky, but effective dimension is the only what matters. And this effective dimension should follow the Fisher law, which is mathematical law, which means that the effective dimension should be smaller than the sample size. Therefore, one of the conclusions here is you cannot train any AI system without data. So sometimes I see, so this is trained by no data. So this is impossible due to mathematical laws. Some information, maybe prior information, is involved in training. And second conclusion is that sometimes it is useful even further increase the dimensionality of the problem, but improve the geometric property of your objective function, particularly by making this objective function locally convex. Then you can apply the perfect machinery of optimization theory, and we know now that the optimization theory is a background for any statistical procedure. Okay, I think this is a good point to stop. Thank you.
Vladimir Spokojny, ваши аплодисменты.
Vladimir Spokojny, a round of applause. Thank you very much for your presentation on fundamental science. This round of applause is for you. Thank you very much. AI is used in various fields. Generative AI is a new tool for doctors, faster documentation, clearer communication, more accurate patient routing. How do you combine benefits and privacy and regulations? This is something that is going to be explained by our next speaker from India, Vice Chancellor of Sai University, Ajit Abraham, with the report Generative AI in Healthcare.
Very good afternoon to all of you. I would like to thank the organizers for inviting me for this important event and presenting some of the research which I was doing during the last several years. I was working in this field for almost 30 years. The initial 10 years I used to work a lot on foundational models, building AI from scratch to understanding how things work. In 2008, I got exposed to some challenging problems facing the society. I got involved in a geriatric hospital where Alzheimer's patients were admitted mostly for taking care of the end of their life. It moved me in different dimensions because these patients, they can't communicate. No relatives, of course, and even medical staffs, they don't want to look after them because it is very tough. So there was a huge turnover of nursing staffs. Nurses, they come, work for a few weeks, few months, they run away. So it was a very complex situation. And then we decided, how can technology be used to ease the situation? So I would say during the last 20 years, from AI, foundational aspects, I started doing a lot of things in healthcare. And the particular project which I was mentioning, we developed a software platform. There is no generative AI in 2008. A multi-agent system, wearable devices using RFID technology, using Wi-Fi, connecting patients with various monitoring systems where a nurse will get alerts if a patient doesn't move for several minutes or if the patient doesn't interact the way it is supposed to be. So we showed that by having this monitoring system, we were able to ease the workload of the hospital system. A reduction of about 50% paperwork. For example, a nurse would go to the room and then record some incidents. At the same time, it improved the operational efficiency of the hospital system. So today I'm going to give you a quick overview about some of the work which we continued from 2008 until, I would say, some of the ongoing works. If you look at life expectancy, especially during the last 10 years, post-COVID, it is continuously increasing. Especially if you see those dark blue areas, those countries have the highest expectancy. And if you look at North, South, West Africa, still we have a lot of challenges. There is a need to improve certain measures so that we can also give all of them equal opportunity to live. So in the next few slides, I will try to summarize what are some of the current innovations in the healthcare field, which, especially with the invention of generative AI, what it has done. From understanding medical images, which a technician sitting in front of a CT machine or looking at X-rays or MRI scans might miss, the generative AI platform can easily pick that, help writing the reports, finding patterns. In a way, it can help to more precise diagnosis. Most of the diseases, especially cancers, neurological disorders, the number of patients are relatively less, and getting data is a very complicated task. Using generative AI, it is possible to generate almost good data which is similar to the data we need, so that we can build AI models which could be useful for detecting such complicated diseases. In turn, supporting radiologists, helping cancer patients, understanding various pathological situations, etc. We have seen how COVID-19 vaccine was discovered. Typically, a vaccine takes 5 to 10 years because you have to do a lot of research, develop the vaccine, do some laboratory testing, take it to clinical testing in a small scale, get various approvals at different government levels, then do some testing in real case, and then finally release it for public consumption. But we have seen how COVID-19 vaccine, for example, Sputnik, how fast we are able to release it from discovery to consumption, few months, less than a year. So AI, especially generative AI, helps us to reduce the time frames, understanding molecular interactions, protein structures, how they dock together. Such simulations and understandings we can speed up using generative AI. Personalized healthcare has taken a new dimension. You can have a doctor in your cell phone, in your pocket. Electronic health records, just by talking to a device, it can note down the prescription, link it with your genomics, your genetic data, your current lifestyle, and give you personalized treatment plans. And personalized means individually, depending upon how you spend your day on a daily basis. So from generalized medicine, we are moving to precision medicine, which has found immense applications in our daily life, especially in the healthcare industry. Virtual assistants, from AI chatbots. Previously, we have seen in banks, in some insurance companies, universities, but nowadays you can also see this in hospitals. Depending upon the need of the hour, it can give you a lot of information. It also makes healthcare more accessible. Imagine someone living far away from Moscow in a remote village. It is not possible to get access to a good doctor. But having such devices helps the general public to access and afford to get the best medical care. It reduces the administrative load of the hospital system, can set up reminders, automatic reminders. It helps the doctors to link many things. Otherwise, doctor would have to ask so many questions. What happened to this one? How it happened? Which day? Which hour? Now everything is linked. Electronically, the doctor can see the summary. And it helps the doctors to make better decisions. Using generative AI, multimodal integration from speech to various electronic records, to your genetic data, to images, to various other vital signs, all these can be integrated with the history. Imagine if a patient who is 80 years old might have a huge file, especially if he or she has complicated disease history. And linking all this together is not simply easy. And all these models will support in real time and with precision medicine. All these things will together help in the best decision making, giving the best health care. Population health management, we have seen towards the end of COVID-19, we have seen how we are able to control the virus spread to some extent. We can predict, given today's data, this is going to move in this direction. So we can allocate resources, do the necessary interventions, set up hospital systems, set up various other logistics. So epidemic management, AI can support in a very big scale by generating various simulations, situations. We are able to understand risk assessments in the best possible way, optimizing resources, and all this will help policymakers, government bodies, etc. So I just want to summarize, especially using generative AI, how much we have come across, how much we have progressed. I would say first is faster image interpretation. From automatic report generation by looking at an image, the radiologist would have to see slices of CT images. It could take several minutes to see all the slices of CT images and see if something is wrong. But using AI, we will be able to summarize it in few seconds to a couple of minutes. Segmenting those organs which has some problems. Could be cancers, could be some abnormal findings. Focusing on those areas automatically. At the same time, multimodal integration, connecting with various other data points, connecting with genetic data, connecting with previous health history, previous images. And it helps to minimize the efforts by the radiologists. Imagine a radiologist looking at these slices of images for one patient, 10 to 15 minutes. The next patient, imagine the life of a radiologist on a daily basis. Quality enhancement and reconstruction, which is, I would say, the beauty of artificial intelligence. A radiologist, probably after a few interventions, 10th patient would miss something in a CT scan, in a particular slice, or few slices. But having AI in place, there is no room for missing such event. So we have seen various imaging schemes, from X-rays to MRI scans to ultrasound, endoscopy, colonoscopy, PET scans, CT scans, and understanding various abnormalities from cardio for the heart, various musculoskeletal injuries, neurological diseases, and several cancers. So in the next 10 minutes, what I'm going to do is, I'm going to show you some of the research which we have been doing, especially during the last 10 years. And I'll not be able to go into details because I'm going to show you various diseases, what you have done, but you will see the QR code, and if you scan it, you can directly go to the publications, and if you have more questions, you're always welcome to connect with me at any time. So enhancing MRI images using thresholding. So by thresholding MRI images, it is also possible to get more insights of these images which a radiologist or a doctor might not get. So in this case, we were able to categorize ALS patients. It's a neurological disorder, lateral sclerosis. About 85% patients we are able to categorize accurately. Similarly, enhancing MRI images using various clustering methods. So in this case, we used a clustering based on fuzzy logic, which takes into account of imprecision, uncertainty, noise. And basically, we are able to see neurological disorders, specifically Alzheimer's disease. Something is coming. Probably it will take several years to show up in a regular MRI scan. So it is more like you're looking at a cloud and telling that it's going to rain in the next 3 hours. Similarly, looking at an MRI scan, and we are going to say that you're going to get Alzheimer's in the next 3 years. Again, using MRIs, using generative AI with various other schemes, we were able to categorize different types of Alzheimer's. Moving to blood, from AML, acute myeloid leukemia, to sickle cell diseases, we were able to categorize using artificial intelligence. And nowadays, there are even wearables. You can feel the pain and suspect that something is wrong with your nervous system, and probably you need to do some blood works. And imagine if you have blood works and then all these AI platforms it can help you to easily identify whether something is wrong. So typically what happens in a real situation is all these patients, number of patients getting leukemia or serious blood diseases, they are very few. And typically when you have symptoms of leukemia, you might have only 6 weeks, 8 weeks to live. And if the laboratory takes 2 weeks, 3 weeks to give you a report, by the time the leukemia might have progressed, you might get the chance to live only for 3-4 weeks. So imagine if you can flag something is wrong with this blood sample, needs some quick intervention. So probably that can minimize or give the patient more lifetime. Intracranial hemorrhage detection, strokes is a very common aspect. Again, using generative AI, we are able to categorize different types of strokes. For example, epidural, subarachnoid, and various other categories. Ischemic strokes. So typically these are, I would say, initial samples that something is going wrong. And you file dizziness and then after some time you're okay. And then you go to the hospital and the hospital will tell that everything is okay because it's already cleared out. So the more delay you have in detecting these type of strokes can also give you more problems, because in medical terms, usually they say that ischemic strokes are some initial points where something big is coming. So it is always better to understand this much earlier so that you can be well prepared. So we tested this in few different data sets and we got very interesting results. Similarly, lung cancer detection, various types of lung cancers, and using an explainable AI model. So usually you get results, okay, you got this cancer, but why? Many times we're interested to know why I got these results. So this model also gives some explanations using some descriptors. Colorectal cancer is another killer, especially for men above 50 years old. And generally it is recommended to have this scan, colonoscopy, every year. Men over 50 years. And typically it takes about 12 to 15 hours. You need to clean up your system, go to the hospital, go to the laboratory, the procedure, then the report, analysis. The whole process takes about 15 hours. And imagine if you have to do this on a yearly basis. And if you use artificial intelligence, whether we can do something better. So we did some initial studies. So you can see that on the screen. So polyps less than 5 mm is considered as, you don't have to worry now, but probably we will wait until the next 6 months or 1 year to see whether it has increased. So using basic AI models, we are able to detect this even better than a conventional radiologist. A radiologist would take several minutes, but a simple AI platform could detect this in a few minutes. We are continuously doing more work in this direction, and now the current work is to detect such polyps just by using CT scans, which means that there is no need for this 15 hours preparation time, but all you have to go to this hospital and take a CT scan, and in 5 minutes, 10 minutes, you will get the report telling that there are no polyps, or polyps are below some threshold, there is nothing to worry. Similarly, cervical cancer is another major killer, and some of our work in this direction has given very good results. Scoliosis detection. So these are, I would say, very minor compared to other cancers or neurological disorders. But again, for children having this kind of vertebral column or spine, it is difficult to give them the best of life. So there is a need to understand these deformalities in the beginning itself. So using AI, we can easily categorize them into mild, moderate, severe, and then flag for further intervention. Lyme disease is a common bacterial disease from ticks found in the bed. It might sound very small, but if you're not giving proper attention, it can spread. It can cause major problems. So just to conclude, I am about to exhaust my time. I will give 2 sets of summary. First is from generative AI. As you know that most of these models are based on data. So we have sometimes what they call as data bias. Handling privacy and security. Many a times we're dealing with patients' data, so managing this is a complicated challenge. Hospital systems, healthcare systems have their own legacy platforms, software. So integrating all this AI-based software platforms, tools, is often a complicated task. And also convincing the medical doctors, the clinicians, or the healthcare professionals that this is important if you use this, these advantages. Many a times, it takes some time to get them convinced. Ethical and accountability issues. Many a times you get decisions from the software, and sometimes whether you can blindly trust the software decisions, who is accountable if the platform or the software makes an error. So deploying AI in healthcare requires careful planning, data governance, proper validation. You cannot simply get some results and straight away implement this in a clinical situation. Need to follow all regulatory compliance and ethical considerations to ensure patient safety and trust from the healthcare service providers. From a healthcare perspective, we have also seen a lot of challenges. First is lack of high quality data. So many times it is very difficult to get data for various studies. And many times we don't have sufficient good quality data, very important. Thanks to generative AI, where we can generate very good quality data. They're always concerned about ethical, legal concerns, concerns about data bias, and how to integrate this in a clinical workflow. Financial barriers, implementation costs. So again, there is a need for robust data governance, more interdisciplinary collaboration. I always see that medical healthcare professionals, they work more like silos. So we need to work together to develop the next generation AI platforms so that we can serve the community in the best possible way. Thank you so much.
Dr. Abraham.
Dr.
Thank you very much for your contribution. That's very important for science and for healthcare. Thank you very much.
Thank you.
Аплодисменты.
A round of applause, please.
Now you can proceed backstage. Thank you. Ваши аплодисменты еще раз.
A round of applause again.
Дорогие друзья, прямо сейчас у нас 20 минут.
Friends, we are having a 20-minute break, after which we are going to talk about how science and government are doing things together. And please leave the stage for that, and we are reconvening in 20 minutes. In 20 minutes, precisely, a plenary session called Foresight, how AI will, what AI will be in 10 years will start. And now please leave the stage. Thank you very much.
начале 2025 года на Череповецком химическом комплексе группы «Фусагра» была запущена в промышленную эксплуатацию российская автоматизированная система управления производством. В отличие от зарубежных аналогов, функционал системы существенно расширен благодаря внедрению технологий искусственного интеллекта. В проекте используется большая языковая модель GigaChat Max, дополненная специальным модулем для работы с внутренним регламентом компании. Для повышения точности ответов внедрен модуль Context Protocol, предоставляющий модели доступ к инструментам и позволяющий реализовать логику ИИ-агентов. Агент выполняет поиск по базе знаний, обращается к прогнозным ML-моделям и другим внутренним системам, обеспечивая точные и актуальные ответы для технологов и операторов. Результат внедрения искусственного интеллекта – оптимизация производственного процесса, поддержание технологического режима, снижение перерасхода ресурсов и выполнение расчетов любой сложности. начале 2025 года на Череповецком химическом комплексе группы «Фусагра» была запущена в промышленную эксплуатацию российская автоматизированная система управления производством. В отличие от зарубежных аналогов, функционал системы существенно расширен благодаря внедрению технологий искусственного интеллекта. В проекте используется большая языковая модель GigaChat Max, дополненная специальным модулем для работы с внутренним регламентом компании. Для повышения точности ответов внедрен модуль Context Protocol, предоставляющий модели доступ к инструментам и позволяющий реализовать логику ИИ-агентов. Агент выполняет поиск по базе знаний, обращается к прогнозным ML-моделям и другим внутренним системам, обеспечивая точные и актуальные ответы для технологов и операторов. Результат внедрения искусственного интеллекта – оптимизация производственного процесса, поддержание технологического режима, снижение перерасхода ресурсов и выполнение расчетов любой сложности.
Пленарная сессия Foresight. Каким будет искусство?
The plenary session Foresight. What will AI look like in 10 years?
Заместитель председателя правительства.
Deputy Chairman of the Government of the Russian Federation, Dmitry Chernyshenko. This plenary session is about foresight, how AI will change in 10 years. Dear friends, I'm very happy to see all of you in this room, in this AI, artificial intelligence journey. This is a great day for the scientific community, this conference. Let us thank Sber and Mr. Grev personally for wonderful organization of the Science Day and the whole AI journey. We are used to thinking that AI is just a system of the new economy, and as our president said, Mr. Putin, at the plenary session yesterday, and a couple of hours ago, we can say so as well, we have unique competencies for the full cycle of forming the fundamental language models, starting from their creation and learning to adaptation to the specific industries. This is something that we're doing already, and I must say that our teams are showing wonderful results in various industries. And I think those of you who have visited the stands realize that this is the true reality. It's very impressive. But it's not just about the development of technology, but about the strategic choice which determines the future of this country and even the countries that are in the AI alliance right now. This choice is not to be done blindly. Other people in this room who know the groove effect, you know about it, right? So for AI, I think this can be especially true because last year, in order for you just to understand where science currently stands in AI and which areas will be prospective and what risks we must foresee in advance, we held a number of foresight sessions in AI. The first foresight was on the 30th of May last year. We were sort of training at that time. And so there were 10 most prospective areas for fundamental research. We determined them, and I underline the fact that this is fundamental research, which serves as a foundation for applied research. And you well know that only after this, commercialization is possible. So 10 areas, they had 37 sub-areas and 113 research tasks, which our scientists thought as the most promising. So based on these results, the Ministry of Economic Development chose a number of research centers in AI. This was already the third wave, based on a very rigorous contest, and the AI as a competence for this research center actually reflected itself in the position of Russia, the number of publications as a whole in AI in Russia, and also it manifested itself in the performance executed by the research centers. But the groove effect is that everything changed in just a year, and our president, Vladimir Putin, said that we should bring this to the international level, and only in this format we may be sure that we are moving in the right direction. And instead of just existing in the state of being detached from the others, it's something that our enemies may want, but we don't want it. So I would like to thank all of the scientists who participated in this international work, including our own universities and research centers, the Sapphire Foundation, the International AI Alliance, and all those who helped. In 2025, the International Foresight in AI was held in 3 stages. There were expert sessions, deep dive interviews, and then we worked on preparing the final report. This was held actually throughout the year, together with research centers, and the event, which we had more than 20 in Russia and abroad. In Russia, there were 10 foresight sessions with our partners, and thanks to our alliance, the International Alliance in AI, There were 11 sessions that were done in Morocco, in the Emirates, in China, 2 times in Shanghai and Shenzhen, Serbia, Pakistan, Uzbekistan, Belarus, Indonesia, Armenia, and Cuba. So a very large and wide geography. This allowed us to calibrate our priorities, considering the fact that there are various scientific schools, so to speak, and it's very important to form a kind of a consensus on all of the tasks. Also, we held deep dive interviews with the scientists in order to determine how they see the prospects of development of science in the area of AI, and why we can actually trust the results that they achieved. You know, it's the scientists, their words that the whole world is listening to. They are being quoted, and they are being learned from. Every of these scientists have a high Hirsch level and publications, 5-star kind publications behind them. So many of them are participants of our foresight sessions, and more than half of them, more than 150 of them, are from foreign countries. So this included Europe, Asia, North and South America, Africa, and actually with the whole advanced part of the humankind, we worked on this task. Some of our colleagues, the foreign scientists, came to AI Journey specifically to share their own vision of the results of these sessions. And I must say that the interviews after the sessions allowed us to gather independent assessments of which areas are still prospective, which areas are stagnant, where we require additional approaches, etc., etc. Also, there were suggestions on alignment of these tasks, because we understand that we must fine-tune these on a regular basis, and we see whether they remain topical. In the most responsible part, everything that we received were put in one pool, and then we finalized the report on the International Foresight. You can see the QR codes on the screen where you can read the digital version of our report and share this with your friends and colleagues, and also would like to hear from you to learn what you think about that. So the results that we see following the foresight in AI, we must say that our Russian scientists are not fundamentally different from the rest of the world. They moved to the top and right with the development curve. So I must say that in a year we strengthened our understanding of the scientific basis and expanded the potential. We need that for groundbreaking results. So this foresight confirmed that the vector for 2024 was right. There are 102 new research tasks, 62 research tasks were changed or clarified by experts, and 14 tasks were either merged with others or removed. So as a result, as I say, the list grew to 102 tasks, and so these considerable shifts are the result of our systemic work. The scientific breakthrough is 100% impossible to plan, but we can change its probability, the probability of scientific breakthroughs, and we must improve the funnel and see that the competences in research is as full as possible, work in all the possible directions, raising the chance of this breakthrough happening. As of now, I think you well know that there's a contest not for the specific technologies, but those who build the ecosystem based on this technology. Maybe even the operating system for the future. Those who are able to do that, those will determine the rules, will set the rules, the others will become dependent on the decisions of others. So we're looking at that in the kind that this is not about chasing someone, but about forming the circuits of the future, which will be based on the shape of the future, based on the specific scientific basis. It should not be just. It should not belong to just one corporation or one nation. It should be for everyone. The 10 areas that the scientists determined for AI, so they can be imagined as a ladder from the foundation to the integration into our real lives. In the foundation we have architectures, algorithms, mathematics, and then we move on to the level of AI agents, models, and security, how they are explained, and then at the top is the integration, AGI, and human-machine interaction. And also the change in the society, the only non-technical part of the research. This is the principle that is in the foundation of our Foresight report. Now that you have it, you can take a look at that. We plan actually to share this with all of our partners, circulated with the government, the UN, also on behalf of the International AI Alliance. So it's been translated into 3 languages, and there were 2 editors and foreign researchers worked on that. So here we are here to listen to those who created this foresight, and I think without further ado we should talk to our scientists. You can see that here there are only 2 chairs, and in this format we're going to work. We're going to invite our speakers here, and the current foresight is under the brand of AI Horizons. The forecast will be updated, and I would like all of us to use this collective brain, so to speak, not something that's given by the generative network, but our own minds, collective minds, to participate in this work and maybe suggest how our unified platform should be called. Let us use this QR code to make your own suggestions. You'll have time to do that. You may think about that. Maybe some thoughts of our experts and scientists will make it easier for you. Then we will calibrate and ask AI. It will help us, tell us that maybe our AI Horizon is a very good name, or it shall remain, or maybe there will be a new one. I would like to invite our first pair of esteemed scientists who will tell us about the areas that are the basis of this research, the architecture, algorithms of machine learning and optimization. I invite the professor from Serbia, head of applied research in the Singidonum University, Nebojša Bačanin Jakula, and the rector of Innopolis University, Alexander Gasnikov. Please, floor is yours. Guys, let us support them with a round of applause.
Прошу, друзья, занимать свои места. Поглядывайте на экран, поскольку вам...
Watch the screen, because you will have a limited time for that, and there will be 2 questions to each of you. Please, Professor Bačanin Jakula, I'm very happy to see you here again. We were in St. Petersburg with you together, and I know you have a very big program in Moscow that you're going to visit the Bolshoi Theater. I'm not sure which play you're going to look, but I hope you like it. Do you have plans? What else do you want to do in Moscow? Well, we can help organize that.
First of all, esteemed Deputy Prime Minister for Great Russian Federation, many thanks for your kind words. It was an honor meeting you in St. Petersburg Economic Forum as well as here. I love Moscow. I love Russian people. So I'll go to Bolshoi Theater to watch opera Dead Souls. That's, you know, because I want to go to this historical stage, because it's of national level importance to go there. And honestly, the second thing I want to go there is because my future wife is here with me in this very hall, and she wants to go to this because she admires the Bolshoi Theater. But besides this, we will see all other, you know, beautiful sights of the greatest city in the world, which is Moscow, definitely.
Спасибо, спасибо, очень рад.
Спасибо. Okay.
I'm very happy that you are so warm about Moscow and Russia. You know, while you were talking, I asked GigaChat quickly who is the most popular composer in Serbia, and it told me Stefan Mokranjac. Is it true?
He's one of the most famous
Хорошо, ладно,
compositors.
GigaChat не ошибся.
Means GigaChat wasn't wrong. So we wish you a nice evening at the theater, but we know that this beauty is based on the structure of the play or a ballet, so it's done on a certain basis. You will see that, but in AI, it's based on architecture and algorithms. So for us to be on the same page, tell us, please, what is there, what is the foundation, why it specifies the framework of all other AI areas?
So this is the first research area, and it's basically the foundation of all other research area in terms of mathematics and engineering, which is basically the core of modern AI. So this research area is important because it connects architectures, optimization, and the learning formulations into the unified process of model creations. So it's foundation for everything else, because models are the most essential here. Also, when we talk about models, we should mention architecture. Architecture defines how AI represents information, while optimization helps, adapts models to the data. And mathematics here is very important because mathematics provides guarantee of stability, generalization, and robustness of all those models. Finally, I would like to mention that the progress in this area is accelerated through breakthroughs in the AI for science, which in the years 2024-2025 managed to incorporate scientific knowledge into so-called world models. It's also accelerated by using the generative models, generative modeling, and also by using the multi-agent systems, which is very important for the future, as well as federated learning. So that's why that's foundation for all other pillars and focus areas. There are also many other things to tell about this, like LLMs here are very important, which are used to evaluate and to create new architectures. As we all know, each architecture should be adapted for solving particular challenge. Before LLMs, we had to do it manually by using neural architecture search or auto machine learning or by applying meta-heuristic, which is my field. I love this, but LLMs are much better in this because LLMs are able to combine basic building blocks or foundations to build the model which adapts to specific problem. Because according to the NFL, no free lunch theorem, there is no universal model which is able to solve all kinds of tasks. That's why we should adapt the model for each and every particular task, and that's why LLMs here are very important in this area. And also, when we talk about the model adaptation, we have this algebra for AI. Which combines the structural components into architectures and optimizes to adapt the model for particular data set. And this is one of the long-term and short-term predictions in this very important focus and research area.
Спасибо большое. Благодарю вас.
Thank you. Thanks, Professor. Actually, our scientist, mathematician here, Alexander, here, today AI is very complex, so that mathematical tools are not usable. We need new algebra, which Professor just mentioned. At the World International Models, we saw the release, for example, of the adaptive system. What are the main challenges in architecture, algorithms of machine learning you see? Dmitry, thank you very much. I think we may be starting with limited generalization, because when a kid and he's or she's being shown the photos of a tiger or a cat, they can discern them one from another, and the networks will have thousands or dozens of thousands of images to understand that. So to bring this to the level closer to the human level, it's actually one of the challenges, and many esteemed experts are talking about that. For example, LeCun. And another challenge is the certainty. So what LLMs give us, whether we can trust them, how can we check it's certain or not certain about the results? This is especially critical in healthcare, for example. So these are the two challenges which are the most important. Thanks a lot. Dear Professor Bochanin Jakula, when we met you at SPIF, at St. Petersburg Forum, you repeated some of these things. You said that there were going to be large-scale changes in the architecture and algorithms in implementing diffusion models and multimodal systems, and then a distributed architecture even. In the near future, what will happen? What will happen in the year during which we will work and then get together one more time and discuss the results? What should be your forecast?
My forecast is first, as I already mentioned, the development of algebra of AI, which enable combination of architecture and optimizers for solving different challenges. Then one of the short-term forecasts is to develop the adaptive, and scalable AI system, which is enabled for continuous learning and rapid domain adaptation. This is very important because by using the continuous learning, it's basically the concept of model to learn the new things, to train on new things without forgetting the old things. This is very important. Another important aspect is domain adaptation. So the models will be able to learn from the source domain and to apply the very same knowledge to the target domain without requiring susceptible or any kind of retraining the model. Also, I think it's very important that we are going to integrate the scientific knowledge into optimizers and architectures to create so-called world models. So now the model is not going to be based just on the data. It's going to be based on the scientific knowledge from the physics, chemistry, and other domains, so the model is going to adapt better to the new tasks and unseen domains. And also there are many hybrid approaches between, let's say, symbiotic modeling, symbiotic learning, then physics systems, and data-driven systems. And also, I think that there is going to be a rapid change in the symbiotic multi-agent systems, which will enable automatization, fully automatization of machine learning pipelines. So that's like our vision, yeah.
If this happens in 1 year, this will be fantastic.
It's going to be so cool if we go to the domain approach to the architecture.
Like algebra for AI and adaptive AI models will happen in the next 1 or 2 years, but these last 3 points are like for longer forecast. For the next 5 to 10 years, I think.
Хорошо, да, понятно.
Okay. Thank you very much. Let's give a hand of applause to our guests for the projections, short-term and long-term alike. Let's look further beyond the horizon. Let's ask Alexander Vladimirovich to give a forecast for the longer terms. What's going to be defining for the architecture of algorithms? Well, to make a forecast, we need to get some kind of a training set. At one point, it became very important to understand that the extractor of markers would be best done not manually, but do a convoluted network that will learn the markers itself. And this idea to automate the marking, this is the idea to delegate something to AI, and this trend is going to be maintained. And some labs are actually working. It's not just one assistant helping the lab; they are actually a set of assistants. And if it used to be, designing data for the model and then use the model, now it's a more of a symbiosis between interacting agents. Each agent doing some kind of a training job. They interact with each other and they develop some kind of a process. So it's more of an evolution thing. So my forecast is in that we will be increasingly taking the knowledge available from the synthetic evolution theory, how the human brain evolved, how we became humans, and we will be integrating that into the AI systems, which will in turn increasingly automate and give us an increasing hierarchy of the processes that we encounter in our work and in our creativity, actually. Thank you very much, Alexander Vladimirovich. I was actually waiting for you as a scientist and user. We'll remember our microservice multi-tenant platform, the only one in the world that is used both by the government and scientists, uniting all our scientific research. That's where we are designing the domain principle. That's why it is called domain science. It's very cool that we're actually talking about this today. Thank you very much. A hand of applause to you. Do rejoin the audience, please. And I'm asking to come on stage the professor from Brazil, the leader from the lab at the University of Campinas, Anderson Rocha, and the director of Systemic Programming Institute, Mr. Avitisyan Artyushkanovich. You've got very long track records, gentlemen. I'm actually having to scroll through 4 pages of achievements. Professor Roshan, you are representing Brazil today at this discussion. Bem-vindo. Can you hear me? Do you have your earpiece on? Yes. Okay. Very warm welcome. You are part of the 2% of the top scientists in the world. You have a rare skill set, starting from computer vision to all the way to digital forensics, digital law. You worked with AI both as an engineer and a research in security and risks. Let's start with a very simple thing, but very important nonetheless. You actually was brought up by your predecessors here on stage. Why is it that the topic of confidence in AI, the trust in AI, resounds so loudly these days?
It's a pleasure to be here. When we enter a plane, we want it to be safe. We want engines to be safe, the fuselage, everything. We want the people that pilot the plane to be also trained, right? So the same is with artificial intelligence. It's here to stay. And it's changing everything that we do, from decision-making to healthcare, to energy, to solving different problems. So when we have a technology that changes everything, we need it to be safe. We need to go as a requirement to have it safe, sound, transparent. We need it to be explainable. So when we have that, then we're going to have social acceptance. But to have social acceptance, it needs to be reliable. When you have a tool like that to help you detect diseases in a hospital, you want it to explain the decision and actually help the doctor, and not just say, yes, there is a tumor and the likelihood is 99%. Okay, but where? Why? How? So when we have that step further, then people will trust it more and use it more. So we need to move from the real tools that are being developed. That's very good. We are here for that. And we need to go to the next step, the explainability.
Thank you very much for your response, Artyushkanovich. Today, the development of AI is moving from the chase of productivity to ensuring the transparency and matching the values of society. What would be your assessment of this transformation of priorities, and what are the main drivers here? Well, hello everyone. Thank you for the opportunity to speak. Dmitry Nikolaevich, I think this is an indicator of maturity for the technology. The penetration of a lot of spheres. We're very much at the outset of the road, but then the implementations really place security on top. And it's important to say that this is not the conventional understanding of security. The social and humanitarian aspects of security are coming to the fore as well. And giving just a tech answer to this is not enough. And, superimposing protections, again, will not be sufficient. Security must be inside by design. Starting from the starting point of development, I will not be responding to your question, in 2 minutes. It's a vast question. The important thing is to set the priorities right for the next couple of years going forward. Yes, secure by design, and for this to happen, we need to agree on the standards, the principles, and what they must be in line with, the common values. For sure. There's one danger lying herein. It's good that we are discussing this internationally, because some countries want to build in their own values. And as IT people, as engineers, we are saying that we need to get technologies that will verify, and the values will be, area specific. In medicine, it will be a bit more different in terms of ethics. In politics, totally different. But technologically, we must give the tools for the policymakers or healthcare professionals or other professionals must realize that, must implement that with area-specific characteristics. We have got actually a presidential decree, 809, to the effect that the values are complied with. We need to look at this together with the AI Alliance members. We need to identify the values that do not contradict each other. We should start with that value set. My question now is to Professor Roshan. We certainly want to hear your projection, your forecast. What do you think waits for us in the in this sphere in the next couple of years?
Yourself mentioned a few minutes ago, 1 year is already very difficult to predict, right? I used to say to my students in Brazil, 1 year in AI is like a decade. So here we did an exercise. What's going to happen, likely, from 25 to 28? That's the time that we need to discuss standards. We need to discuss regulation. It might be in a year or two, but we need to do that because otherwise AI will swallow us. It will be present anyhow. So regarding do we do it or not, I think we should do it. Then what's next? We need to, since now, focus on fighting abuses. There are many people that go online that use technology for abuse, to take advantage of others. So we need to develop the technology and the regulation to fight that. And it needs to happen now as well. Looking further, we need, as it was mentioned before, to design the theory, to improve the theory, to make better models, more models that are safer and transparent. And I think that until the year 2032, we need to have that in place.
Спасибо огромное.
Thank you. Thank you very much. Let's remember this forecast. We're going to discuss that in a year. Artem Ishkanovich, you mentioned healthcare, where the price of an error is obviously very high. What do you think the most important criterion is to apply AI in medicine securely and safely? It's very important to identify the risks and jeopardies in every specific case and use AI depending on that. Sometimes, unfortunately, we will not be able to give it autonomy without the humans, and the regulation, the right regulation, is crucial here. At some point, IT community considers this to be a limitation, but this is not so. And here we are actively working with the medical community, with the healthcare community. We RNA vaccine was announced. We are doing with the academician the reasoning thing. Ivan Seri is sitting in the audience. That's obviously the crucial thing to do, because sometimes IT people do not understand the limitations imposed by the area-specific professionals. If we only are driven by our own knowledge, that will be a limitation. I think going together is the right path. Okay, thank you very much. Do rejoin the audience now. We should stay on the right side of the volume of regulation here. And the Vietnam professor, Anh Huy Phan, from Skoltech, and the director from Mega Faculty, of ITMO, Mr. Alexander Bukhanovsky, please join us on stage. Do not spare applause. Let's give some encouragement to the speakers. The next area of the foresight, computation for AI. As you will know, computation includes the development of both new computing architectures and the software tools that ensure effective use of computation. Mr. Huifan, you lead several projects with Huawei, where you are rationalizing AI, starting from compression of models and accelerating models, all the way through architectural adaptation. What do you think lays the foundation for computation in AI?
Thank you very much for the introduction, and I'm really honored to be here. So this is second time for me, so I attend the conference, the session they hosted by the Deputy Prime Minister, so I'm very honored to. So again, regarding the questions, so what is the fundamental for AI development? Yes. So you see here, that's the scale of the models is really important. So we see the small model from like 10 years ago, and then very big model deliver almost every year.
Close to the mic, please.
Then more important is that we see here the scale of the model, and then the architecture that can support the model to run, to train, and to do fine tuning. And another important is that the architecture is also very important to, the hardware also very important to specialize, to improve the speed of the model and also to reduce the energy. So that's one of the more important factors. So.
Thank you very much, Alexander Valerievich. All the experts convene in the opinion that the main bottleneck for the next 10 years is the computing power. Obviously, the stake on scaling GPU will not be vindicated. NVIDIA are following this path. They recently got some luck. The bubble did not burst. But are there any alternatives? Yes, Dmitry Nikolaevich, actually there are alternatives, and it goes without saying that using GPU supercomputers is a very expensive thing, but we should remember that the quickest thing is the light. So we should go back to the optoelectronic and photonic neuromorphic computers. Unfortunately, systems like that, as often as not, are one-act theaters, so they can only perform one transaction, say transformation of markers. They do not cover the entire length of model performance. But you can use them as hybrid systems. You can use them as boosters, as accelerators. You can merge them with classical architectures, perhaps weaker, cheaper, but that symbiosis will give you a winning solution. And this is going to cover the things that the GPU systems could do. Thank you. Very interesting. Mr. Stefan, how do you treat the symbiotic systems? Quantum photonic systems with the combined with the common GPU systems?
Thank you for the question. So again, I need to ask a few comments to the development of AI system. So we see how the GPU develop like every 2 years, 3 years. So new generation it come and it support us not only to accelerate the computation, but the thing is that it now come to reduce the computational more efficient the energy. So about the quantum computing. So in this, many people believe that the benefit of quantum computing will come in the next 10 years, around 2030 or 2040, and definitely you see that the benefit from quantum computing is not for everyone. So it belongs to some big company and some national lab. It really have high resource, and And we worry about that. This can maybe lead to some the risk that AI might not be open for the public, so for research scientists, educator, or maybe some small company. So there's another way that we think about some open AI. Not open AI, so AI open for everyone. So sorry about that. So it means that how to modify some existing model using the available resource computing to adapt to some specific application. So it happened here that the model is released, and then you want to use the model for some specific application. You train, you fine-tune that, and the performance that you obtain is not the same as the model that is public claim in the original paper. This is because the architecture, the hardware you use, is not comparable to the original one. So somehow we think about that. Okay, how can we exploit some existing model on the hardware that we have to achieve comparable performance, so that it not really reduce the significance.
Очень дипломатично профессор Фан выразил сомнение.
Very diplomatically. Thank you, Professor. 2030, 2040, very diplomatic. But maybe we should remember your turn of phrase, instead of open AI, AI for everyone. Was that the thing you said? Yes. Thank you. Alexander Valeryevich, perhaps very briefly, what would be your projection about this startup that launches a data center into the space, energy consumption going down tenfold, etc.? Well, energy consumption will definitely go down because in space, cooling is much more efficient in space, but the cost of the enterprise is not in cooling. It's about taking it into orbit the right way, using it the right way, and then disposing of it the right way. No one really knows whether this is the right marketing move or whether it's going to be worth anything. Okay, let's observe. Let's wait and observe. Do rejoin the audience now. And I'm now asking the Deputy Dean of Sai University in India, Ajit Abraham, and the State Scientific Research Institute of Aviation System researcher, Yuri Wieselter. Dear Mr. Abraham, great to welcome you. When we spoke the last time at the St. Petersburg Economic Forum, you shared your vision of the architectures and ML machine learning. It would be great to hear your opinion as one of the most cited experts in data science on this track, data for artificial intelligence. Please, sir, what do you think?
Good afternoon. First of all, I would like to thank the Deputy Prime Minister, Dmitry Chernyshchenko, for all his leadership and for the guidance during the last several months, for having various foresight sessions, summarizing the whole event. On behalf of all the participants, I again would like to thank you for your leadership and this energy. Back home, I tell my leaders that we can also learn from the administrators in Russia, the way they do things, lead the things, guide the scientific community, thanks to your wonderful leadership. It's a very interesting area. It reminds me 30 years ago when I started AI research. So I remember this very interesting analogy, chicken and egg, which comes first, whether it is data, whether it is AI. So in the case of artificial intelligence, we can build models, but without data and without any practical applications, without making an impact to the community, to me, such models are just good in scientific papers, will not have any practical implications. And we should stress and strive hard to do the best we can to innovate new technologies, new methodologies, to make data accessible and available at all times and all means. Because recently I would say that during the last 3 years, as I see it, a lot of enterprises, I would say countries which are economically privileged, having an upper hand in taking forward this domain. I feel like the field is being hijacked by few enterprises. And I think there is a big need for scientific cooperation. There is a huge challenge for all of us to balance this, what I call as data asymmetry. And there could be a lot of various challenges facing this. First of all, there could be regulatory issues, privacy issues, then the way data is curated at some places. For example, if you want to access data from Antarctica, definitely, then we need to think about in some other perspective. But the way the field is moving and the way we have the frameworks coming up, we need to look at the whole field in 3 different broad domains. I think there is a need for developing benchmarks, because that is how we usually build AI models. So we need to understand the performance metrics by which a model is evaluated. And for that, we need the best possible data available and associated benchmarks. Data forming and maintenance, how we get this data, whether the data is of good quality and whether it is reliable, and maintaining this, because many a times users come in and go, and then some data may get corrupted and some data could be used for some other purposes. So we need to ensure that this data is maintained and preserved very well. And finally, confidentiality is another major challenge, especially related to specific problem areas. At the same time, data protection. Many a times, I guess the previous pillar mentioned about government, healthcare, finance. So these data we cannot afford to simply leak out of any cloud or any platforms. We need to ensure that we balance this in the best possible way.
Thank you very much, Mr. Vice Chancellor. Yuri, after the speech of Ajit, I would like to hear your understanding of how requirements for data is changing and what benchmark this sets for data for AI. Thank you. I think there are 2 main things in play here. First is how fast the AI solutions are changing. In spring, there was a research by the Meta Group that showed that in the last 6 years, every 7 months, the level of complexity of tasks solved by AI doubles. So, every time, we need new and new benchmarks which are capable of estimating these new tasks, this new level of AI that is always being raised and raised. There are also new classes of tasks, the ones that were mentioned in Foresight, multi-language, character, working in the open world, collecting data of robotics, what's required for robotics, and the professional competencies. So I think today the strongest frontier here is the data for professional competence. As an example, I can mention the GDP-Wall benchmark published by OpenAI. GDP is using AI in the economy, and it includes the examples of solving professional tasks for 44 professions from 9 areas of the economy, which the experts with big experience created. And these are the benchmarks that set the frontier in data and AI. Now I have a question to Ajit Abraham. There's an understanding that the data is being limited, the synthetic data do not give the variability, and it sort of leads to a closed circle, and we risk getting into a digital echo and losing or even getting the lack of efficiency curve. What do you think about that?
Yes, I guess as President Putin mentioned on the first day, there is a need to secure data and develop own curation methods, specifically when you deal with high-level sensitive data for various applications. Of course, it is a big challenge because data nowadays is considered as an asset, and many a times getting this data from nowhere it brings a lot of challenges. And typically in practice, what we do for many applications is we use so-called data augmentation. We try to curate data using various generative AI means. But again, nowadays, because of the availability of several platforms, we don't know what is authentic. Even the differences are very small. For example, if you look at the text generated from LLMs, it is very difficult for us to make out whether it is from LLM or it is generated by humans. So looking at some high-level features, some statistical measures, we can of course categorize them as curated or synthetic. But again, for images, for medias, I think there should be means like watermarking is one way to understand whether it is coming from some generated platforms. At the same time, we need to ensure that these data are not misused by some other stakeholders. So employing standards, for example, GDPR and ISO standards are, I think, is mandatory moving forwards, because nowadays, absolutely there is no control, it's absolutely chaos. Because we are dealing with data in a very big scale. I remember 20 years ago we could do data analysis, analytics in a lab, but nowadays everything is in the cloud, and we are seeing that thirst is like drinking water from a fire hose reel. And the data comes in streams from various sources, could be videos, could be signals, could be healthcare data, could be text. We also need to handle all this variety of data. And also veracity. Sometimes we don't know this data is coming from this authentic source. Could be someone is injecting something to cause problems or confuse the model. So there are several layers. We need to ensure that security is in place so that we are able to protect and offer the necessary confidentiality for the various stakeholders.
Thank you. I absolutely agree with you. It's good that you remembered our president and what he said. It's true that the standards are obligatory for us to be able to talk to each other, especially in data usage. Yuri, what are the breakthroughs? What do you think, your forecast? What do you expect in working with data?
Мне кажется, что все-таки наибольшего прорыва мы можем...
I think the main breakthrough can be awaited in working with synthetic data, because it's also the main challenge that we're working with, because in many areas we have the situation of the so-called wall of data, where the majority of data that could have been gathered has already been used for learning. This is one of the challenges for the modern AI. Can we create new data for learning? If we can validate it well, for example, in coding, we have very good progress that we're seeing in the last years, and it can go on and go on. And in cases where we cannot validate it very well for complex tasks, here the question is whether we can generate the synthetics. It's more of a philosophical question, whether a teacher, a person, can teach the pupil, which is the AI, something that he himself cannot do it. Because, you know, the learner must overcome the teacher sometime. We'll learn if it's true when we work with synthetic data. Well, if it's based on bad quality synthetic data, and if they're going to mislead or hallucinate or generate additional new data and then train someone around and making the data worse, it's the matter of validation. This is a task for all of us to prepare for the next year. Thank you very much. Please take your seats. And I now invite the professor from Anhui University, Ye Tian, and chairman of the Laboratory and Transport of the FISTEC Lab of Modeling, Dmitry Yudin.
Professor Tian.
Professor Tian, I think your name is known to many people who work with optimization and specific computing methods. You're called as the best, youngest scientist in AI in China, and you became one of the most quoted Chinese researchers, and we're very happy to welcome you here at this stage. In Foresight, you're representing the area of AI for narrow tasks, specific tasks, and following the forecasts, the narrow AI will be 95% of the economic viability of this. What is the future of this area? What do you think? What are the approaches that can set up the tempo for the coming years?
Thank you very much. Dear Prime Minister, thank you very much for your introduction and invitation. It's my great honor to be here to discuss with you the future development of artificial intelligence. For me, I think the core function of artificial intelligence is to reduce the human workload and to improve the efficiency of industries. And I think currently the neural networks will still be the mainstream technologies for narrow AI in the near future, including for example, fully connected neural networks, convolutional networks, transformers, and diffusion models with their applications in computer vision, natural language processing, and other industrial scenarios. Also, as pointed out by the President on Wednesday, currently the large language models and content generation models would be the most popular AI applications. And both of these two applications are also based on neural networks. In the future, we may shift from the scaling to architectural diversity. And with this, we can innovate some hybrid and also multifunctional models. But this is still under the framework of neural networks. And the paradigm of narrow AI development will not be changed in the near future.
Спасибо большое. Уважаемый Дмитрий Александрович, вы как эксперт в области...
Dmitry, as an expert, what's your view on the development of narrow AI on the international level, including the embodied AI? What may hinder moving from the lab research to the existing solutions? Dmitry, thanks for this question. Actually, the narrow AI is about practical models and the methods which are very well and organically used for robotics, for self-driving cars. And even in robotics, I must say, not just the delivery robots, the walking robots, that one of them was presented yesterday at Air Journey. These are medical robots and other types of service robots. And I must say that what must we do for that? First of all, we must support open joint projects, international projects, which can integrate modern engineering methods and develop them. In Russia, they are meetups, even in this community, are used. There are international big projects which integrate the technology of self-driving cars, for example, Apollo from Baidu or AutoWare from their association, and also big projects and their creation and support of them. It seems like it's very, very prospective and we can develop them. In addition to that, what is important? The development of the AI that could be aware, find itself in 3D scenes, and now language models cannot do this nicely, and so the modern methods for narrow AI could help do that and raise this awareness. Professor Tian, question to you. Now the difficulty begins where the system must see and understand, and as well as understand how to act. So moving from just getting the information to acting, what's your thought on this?
Thank you very much for the problem. For me, I think this conclusion is correct, and for the future development of narrow AI. Currently, under the framework of neural networks, based on the supervised learning paradigm, I think AI can learn the mappings between input and output. For example, the images and its labels, the description and the generated content, the biological sequence and the analysis results. For this goal, we should have a large number of datasets to deeply train the neural networks so that it can work. But in many scenarios, especially those in science and engineering, we cannot obtain such a large number of datasets for each scenario. It's not a big data, but a small data. In this case, AI are expected to be able to reason, plan, and act in the complex real-world scenarios by themselves without the supervision of human experience. I think it's possible. It can be achieved by reinforcement learning, intelligent optimization, and other technologies other than supervised learning paradigms.
Thank you very much. Dmitry, what's your thought on the realistic trajectory of the development of AI, a narrow and smarter AI, up to the end of next year? To the end of next year, I must say, it's not a simple task. I think the trajectory is as follows. So the academia, the research organizations will create new fundamental models, small ones for the computer vision or natural language processing. And then going on, companies will use them and we will get feedback from them. And then we'll correct these algorithms. Also, we'll get a better quality, the economy, or maybe positive applicable effects, even in healthcare and robotics. And all this up to the end of next year. Small movements, yes, we'll do. We'll be able to do them. We'll track that. Thank you very much. Please take your seats. And now I invite Professor of the Engineering College, RMK, and a specialist in AI, Nilakandan Subramani, and Director of the Center of Bioelectric Interfaces of the Higher School of Economic, Alexei Osachi.
Господин Subramani.
Mr. Subramanian, among your scientific interests that define the technical foundation of interaction between AI and humans is the infrastructure that makes systems more responsive, more personalized, more secure. In human-to-AI interaction, the tech foundation and user experience are directly related. What other challenges in your area do you see to be the key ones?
Thank you for your question. Actually, the human-computer interaction, how the people are interacting with the technologies by using some machines. You know, day by day, even we are developing a huge number of technologies that is the only purpose for interacting with the human being, and it has to be very easy to use. Then otherwise it is no meaning for developing a new technologies. And here the key challenges for the future human-computer interactions, take a brain-computer interface. And actually, brain is not a static one. It changes over a time. And for this brain-computer interaction caters for changing over a period of time, we cannot predict how the neural code is working behind of that. That is the biggest complexity here. And also, the blending of physical and digital world technologies like using virtual reality, augmented reality, and 3D environment. And these are the biggest challenges when you focus on cyber sickness in terms of healthcare and other things. to overcome this, nowadays we are interacting with like emotional classifications and text-based emotional classification, voice-based recognition system, and text-based recognition system. But in the future, how we are going to integrate all these model into a single picture, that's what we can say multimodal AI. So these are the key challenges I'm seeing this. And also in terms of AI ethics, like the developed AI model, how it's how we can justify whether the AI model is correctly developed or not. The prediction of developed AI model is also a huge question mark here in terms of explainable AI.
Спасибо, профессор Субраманиан. Алексей Евгеньевич.
Thank you, Professor. Neurointerfaces, they can read the signals of the brain, rebuild some functions of the brain that have been lost. When is this going en masse, or is this still committed to a laboratory going forward? Thank you very much for the question. The neurointerfaces, they're perhaps split into invasive and non-invasive. Non-invasive are obviously those that read brain activity from the surface of the scalp, of the skull. And it might seem that the devices that could use that technology have been in operation for a long time. You're looking at my scalp with some particular interest. Well, devices like that could accompany meditation, track human emotions, etc. If you talk about further development of technology, we should not perhaps listen to the brain per se, but we should register the activities of autonomous neurosystems, following eyeballs, whether they are diluted. They are a good indicator of how immersed people are in the situation. That might be an area of development. You don't require very strong AI. You just need some ergonomic devices to register those parameters. Talking about invasive interfaces, well, invasive, so far they have remained committed to the lab, yes, and they probably will for a while, but the spectra of such solutions will be expanding. So far we have had very successful trials of the interfaces for the eyesight, for the eye, stimulation of the periphery vision, retina stimulation. That is a good, promising technology. Reinstatement of speech capability. Some systems are able to rebuild the speech capability. Without those interfaces, speech is pretty much unintelligible. So invasive interfaces, yes, still the domain of the medicine, professional surgeries, but they are going to become cheaper and more accessible. Non-invasive, if it's not just about the electrodes, if you talk about the autonomous things, skin reactions, eyes, heart rate reading, we are going to hit the new level of processing for the data and new level of devices. Well, thank you very much. Wish you every success. Do take notice of what Veronika Igorevna Skvartsova is doing in the Brain Institute of the Academy of Sciences. Yes, we are very much involved. Dear Professor, your colleague spoke of emotions. What do you think is going to be the time when machine starts reading emotions correctly? When are we going to learn to sense the humans?
Actually, the human-machine interaction, the AI model and machine will always read the human brain. Okay. Now you can see that people, how many of you sitting with the stress and anxiety and depression, we can easily identify by seeing your facial expressions. And this is also one of the model we can identify the human emotional states. And these emotional states as well as that sentimental classifications also will be the future in integration of a single model. And the critical questions for here in the ethical issue, the model which you have developed, it should be a reliable one for the future world. And also, if the data, if you are feeding into the AI model, if it is not a reliable one, then it will be a chance to bypass the human interactions, because the error rate will be very high. So it is our responsibility of the AI engineer to feed the correct data and to develop an AI model for the human-machine interactions. And also, the model which you are developing, and that should be fit to the social impact and social development and for the betterment of human being. So it's our responsibility to develop an ethical guidelines and ethical framework, and it should be reliable and transparency.
Спасибо большое.
Thank you very much. What are your plans for the next year? What are you going to be showing us in about a year? Well, I would very much like to transition from registering brain activity to high-density matrices. If you look at this line in front of the stage, that's what 1 centimeter of the human brain looks like. Right now we are reading this activity by electrodes that are about the size of my palm. Hopefully we can use electrodes that are going to give us dozens of spots per square millimeter. The interfaces that we have about the systems that are pretty much breaking down this wonderful matrix. They are building into the cortex. These are sort of needles. So the desire would be to use the surface electrodes. Yes, and we are doing a partnership with Tsinghua University, initiated by Sber. Hopefully we can advance in this direction in a year. Thank you, colleagues. Do rejoin the audience. And I'm now inviting on stage Secretary General of the International AI Alliance, the Managing Director of Sberbank, Andrei Vladimirovich Neznamov, and the researcher of Center for International Security at Tsinghua University, Mr. Song Bo. Andrei Vladimirovich, in 2021, the National Ethics Code in AI was developed and open for accession by citing. Do we run the risk that a critical number of nations might actually join this code? Is that a probability? Well, we're very much hopeful that this is going to happen, but that has not come to pass. UNESCO adopted the recommendation. Yes, we have not yet achieved that. UNESCO in 2021 adopted the recommendation on the AI ethics, but the implementation has been lame so far. Struggling? Why? Because the ethics of AI is inalienably related to the culture of civilization. That is something that we studied at the Science Foresight. Right now, most propositions really translate the ethics of the Western countries. So together with Tsinghua University, we are studying the other types of ethics that we should probably note as we develop the global AI ethics. So far in Russia and the countries friendly to Russia, we have been largely successful in doing this. For instance, the Russian Code of Ethics was acceded to by, there's about 150 signatories. We've got about 35 members, so there's demand for that, and hopefully we can develop some kind of a global ethics code under the auspices of the International Alliance. Mr. Song, your research of the Russian region, Chinese foreign policy, allow us to view not just AI, but AI as a factor that changes the rules for global competition, cooperation. And then there's dilemma. Either AI is enhancing structural asymmetries between the countries, or it is an opportunity for a more balanced international environment. Thank you very much to Mr. Chernyshenko. I will try to speak Russian. I'm not the best of the Russian speakers, but still.
I'm not
the best Russian speaker, but I did study Russian. I think we live in a world where Technologies penetrate all spheres of human life. And our report is saying that we need a new social compact that would include AI, a society AI compact. We are facing very serious challenges.
Технологии или система и увлечивает разрыв между странами.
Technology has been enhancing the gaps between the nations. Some countries are running ahead, some countries are getting left behind.
Проблема о разнице регулярного управления поэтому
The AI governance is just about as important. So what we think is that the entire world needs to transition from statements to actions and ensure equal opportunity for all nations.
Решательный вариант, мы считаем, но самый главный, нам нужно в будущее создать международный механизм.
I think we should create an international governance mechanism for AI. That's my answer. Thank you. Thank you very much, sir. Andrei Vladimirovich, this July, a global index to assess AI governance was published, the AI Governance Evaluation Index, where Russia came 30th of the 440 members. Yep, we showed a pretty high index of regulation of AI, although we do not regulate AI. What do you think should happen for us to come higher in this index? Yes, this is a very paradoxical situation. We actually did come 9th of the 40 countries in the quality of governance. That is about both the laws and the lack of barriers, the ethics, technical standardization. We're actually in the top 10, although we completely falling through on all the other directions. We are pretty much next to zero on publications in AI governance. AI governance is generally written on by lawyers. We've got several PhD theses in Russia. Not all of them target Russia. A lot of theses have been published in the world on all kinds of things. And we have the metrics on the number of publications. In Russia, we've got zeros here. So the important thing is to start, for the scientific community, is to start paying attention to these topics. Together with Tsinghua counterparts, we have been doing a lot on the area, researching the law, studying the law. In some points, the index does not have anything about the opinion on AI in Russia, and the surveys place the overall public opinion on a much more positive level with respect to AI versus other countries. So we've got every chance to go higher in that index, but hopefully the scientific community joins us on this.
Shall we raise this index? I hope people are watching us on the internet, a couple of dozens of thousands or maybe more, hundreds. Thank you very much for that, Mr. Sumbo. We're talking about ethics of AI. There is a AI code, voluntary AI code, and participants are joining. On the international stage, we see that there is an intention, a trend for a responsible AI. What do you think are the principles, general principles that will serve as the foundation of our approaches in ethics? Well, what I think, unfortunately, frankly speaking, I don't have the right answer. I think that I actually liked a lot the speech of the esteemed President of the Russian Federation 2 days ago here he said that it was a very interesting thing that children only want only to press a button instead of thinking and doing something on their own. I think that in China there's also this kind of situation that how we solve it. There are companies that create a new system, and in order to make children not just press buttons, but do something else. This is not the right path. I think we must create a new principle that would correspond to everything that the President of Russia said. I think that in the future we need to be protected the humans from losing their cognitive capabilities, and we need to make people, and especially children, think themselves. I found a quote. I found even a quote of of President Xi Jinping when our president visited Beijing. He said that according to the initiative, all countries, regardless of their wealth, must have an equal participation and equal opportunities in the global governance. We must raise the democratization of the international relations and expand the voice of developing countries, and that's what we are going to do. Follow our leaders. Thank you very much. Take your seats.
I invite to the stage Director of Tsingtao University of Science and Technology, Dianhu Wang, and Director of Skolkovo Institute of Science and Technology, Evgeny Burnaev. Professor Wang, your work on stochastic configuration networks and computational intellect are dedicated to how intelligence can identify complex patterns in data and adapt to changing conditions. What are the breakthroughs that you see in industrial AI, and can we say that lightweight training models can be the best groundwork for decision-making on AI basis?
Okay. First of all, I thank you very much for the good introduction. My job, okay, stochastic configuration network. I created these concepts in 2017. Okay, and then I deeply believe so this lightweight learning model will play the key role in the future, especially for industry AI, okay? Because we have real-time requirements, we have limited power, we have limited computing resource. So in such a scenario, we can't rely on the well-known training algorithm, for example, very well-known propagation, but resulting a very complex neural nets. Whatever is a deep structure, single layer. But when we think about this, how to use this learning model in edge computing-based application, so that's become a big issue. Okay, that's my understanding.
Спасибо большое. Евгений Владимирович, на вашей сессии совместной с президентом.
Thank you very much. Evgeny Burnaev, at your session with the participation of the president, he said that smart assistants, intelligent assistants need to be integrated in more and more managerial processes. Which kinds of technology do you think are the best suited now for scaling, and what are the barriers that you see for them to become the norm? What Mr. Wang was talking about is an absolutely crucial part of this process. Speaking of industrial systems, when a model is sitting on the equipment, that model being lightweight is absolutely vital. Such a model can only handle a specific function, though. If we talk about the management of the entire process, we will need a combination of models. Some of the models will be lightweight, some of the models will be in the cloud or on a premise, on local servers. So we're talking about a multi-agent system managing the whole process. Of course, there is a certain trend. These systems are being developed. We are recognizing their value. They are becoming more and more adaptive thanks to visual language models, large language models. The main problem with deployment is this. First, there is no established regulation for their installation on existing systems, especially when it comes to critical functions. Then, with the growth of investment, we are getting more and more frameworks of multi-agent systems, but the problem is that they are, to a certain extent, fragmented. We do not have some established best practice based on them. And then when we explore the interaction among different agents, when different nodes are located in different spaces, so messages are transmitted over a significant range, we need to ensure reliable channels and keep the whole process secure. And also, if in the system there is an LLM or similar model, generative model, this becomes a very sophisticated tool. When you're ranging some answers, for example, the language model can behave differently when answering certain questions, when you have the ranking, not to mention a multi-agent system. These are the challenges that we will need to face, but there are certain ideas, so the industry is developing very rapidly. Thank you very much. This gives me a hint for another question for Mr. Wang. We are discussing not even the autonomous nature of agents, but their ability to learn from each other. When one system borrows a strategy from another system and then starts improving itself, and it's very hard for us to keep track. So the question is, how do you think we should manage this environment where agents have learned to communicate with each other, sometimes in languages that we do not understand, in an environment where models create their own rules?
I'm not working in the field. Probably Evgenia can answer this question.
Ну, хорошо, мнение же можно ваше услышать?
Okay, maybe the manager can answer this. Regarding your question, I can say this. If processes in a multi-agent system are slow, a human being can, of course, control certain things, can get involved, but if the processes are very fast and the system is very complex, then the person can only do something outside of the cycle, and the only way about this is to combine different tools. Of course, you always need to test the system for vulnerabilities. Next, you need to have some sandboxes, barriers, where the process would stop altogether when you go beyond the barriers. And then the person needs to have access to the button that holds the whole system. And there should be gates in between the different systems that can be closed down, shut down if needed, to prohibit transmission of data. And also the two-key solution when you need to once again stop data from being transmitted. And this is what's being developed now. How can you regulate this? With which document, which framework? Europe is currently developing such regulatory framework, and we are following suit. We have different documents, different regulations for autonomous systems. We still have these standards for different machines, equipments. It's just that this is a new level for IT systems. Thank you, Professor Wang. For forecasting, we use deep models with a huge number of parameters. To which extent and which solutions do you think will be adaptable for actual industrial tasks?
That's a very good question. I think recently I got involved in 4 real-world industry projects. Okay, I think people are looking for some explainable model. Then the model should be knowledge informed rather than simply training from so-called deep learning algorithm. But people don't feel safety when they use the model for industry process. Okay, then I think explainable is one issue. And also, I again address these the lightweights. So I think traditional learning algorithm has a big issue. Okay, so that's I think now somebody told me we had long distance from academia of China engineering. So he said, in the future, we should have pay more attention on these advanced machine learning algorithms, so that can produce a real optimal lightweight model. Okay, so this is for industry AI, rather than for generative large-scale model for entertainment or information processing. So this is my understanding. Next generation, I truly believe industry AI will play the key role in the world.
Thank you. Thank you very much for your forecast. Please take your seats in the audience, and I now invite the final pair for today, the head of Fusion Braille Laboratory of Sberbank, Andrei Kuznetsov, and IRI, and Ivan Osoledzets, also from IRI.
Andrei Vladimirovich,
Mr. Kuznetsov, you are a renowned expert in GenAI. You're co-founder of Kandinsky models. We congratulate you with your release. Thank you very much. How's it going, by the way? Is it gaining popularity? Well, yes, the research of the product team show that the results are great. Thank you. In May this year, you have headed a joint lab of GenAI that was created by IRI and Innopolis. What are the outlooks for the GenAI model as part of our foresight? Yes, it is true. The GenAI models are going to the next level of multi-model architecture, where text is the basis. Around the text, a lot of types of data are being built with which the model learns how to work. This year, we went to the new era of reasoning and the possibility of self-editing and self-correction of the model. And as part of our efforts in Innopolis, we learn how to adapt these models for the industrial applications and for the industrial, using them for industrial data and engineering. This year, we showed some great solutions for reverse engineering in heavy machinery and construction. For example, our quadrille model is developing greatly and shows fantastic results. You can see that GenAI overall starts to converge and is intersecting with the industrial applications, which is very important. Thank you very much. It is my great pleasure to give the floor to a Russian mathematician, CEO of ARIA, the professor of Russian Academy of Science, Ivan Osaledets. He's in the top 20 researchers in the world in terms of the number of citations. You're one of the visionaries of Foresight, by the way, and you started working on it before it went global. And in your latest interview, you said that it is not possible to develop superintelligence and strong intelligence. Well, now you have to explain us. Why do you think that way? Could you tell us what is the stage of AGI development? Thank you very much. Well, it's good that I'm read, including the interview is read, but first of all, you have to create AGI. You said that it's a buzzword, but something that we're there, but we're not there, although the way the science is going and the industry is going is pretty understandable. We're talking about the scaling of transformers with a large number of GPUs, and something that happened in February this year with reasoning, and we're talking about DeepSeek. I'll try to switch that. Nope, that doesn't work. Some other agents are doing that anyway. I'm going to talk without the slides. Let them just slide away by themselves. Anyway, reasoning and DeepSeek, two major things. The models that reason for a long time with a large context. At the same time, the cost of inference went down because you have to work with large context, but at the same time, the cost of one token went down tenfold. So this is an innovative development. The quality of the model improves. All the benchmarks went through quickly. It's actually right there on the slide. Thank you very much. Yeah, that's true. Yeah, I remember. Yeah, that's written there. The other story that is related to the robot that we have showed, that's the embedded AI going to the physical world. This is vision language models, VLMs, that are at this emergent state. I mean, without that, true AI is not possible. Self-reflection, something that was already demonstrated, and the interaction with humans, I think for sure what we have to do, we have to have a proper assessment system, not the statical benchmarks that people just make repetitive tasks and train the model on them, and then they report 90%, and at the same time complicated tasks like finding new medications or working in healthcare or resolving some construction issues. They don't do that. So to create a real strong intelligence AGI, we need to resolve at least one task that humanity cannot solve by itself. Thank you very much. And to conclude, I'd like to end with a question. What is the leap forward that you expect? The creation of fundamental models for robotic systems, one of them, but for Foresight, not only in your area. What is your forecast when we reconvene a year after this conference? What leap through are you going to discuss? I think for sure we can talk about moving closer to the better understanding of the physics of the world and the time and space connections, because a large number of content, it is not only text but video, and this sequences, the temporary sequences with various links. It's a major challenge because it opens up a new wave of the synthesis of data that is needed in robotics, in driverless cars and driverless vehicles, with out-of-distribution situations or deviations in the behavior, and understanding in physics, understanding the laws of the environment is a very important task that we are going to go to. It's like building Zeppelins right now. People thought that you just need to build larger Zeppelins to transport more people, and then planes were invented. It's like here, maybe some new architectures will be discovered that work differently. Well, immortality is something that we were discussing for a long time. Well, you need to work out the mathematics first. Okay, so the immortality is not on the table as for now. Thank you very much. A round of applause. Now, in the end, please scan the QR code and select the best name of our platform, of our uniting platform. 52 ideas of the names. The table was given with the names was given to GigaChat. We uploaded the file together with the report on our foresight. RAG worked it out, and the prompt was the following. You are the expert in communications and in naming. From 1 to 10, rate the proposed names for the foresight research and about the future of the fundamental technologies. So I would ask you to give us the top 7 of the names, and we're going to see the best option in live mode. Right, so maybe I have influenced the audience, AI Horizons, or maybe it's just a very beautiful name. 9 out of 10, 51% of the votes. Brain OS, second option. For future site. Singularity. AI Optimi, and AI International Platform, and Global Sprint. Right, so I guess right Horizons, right? Yeah, okay. Everyone's voted for that. Thank you very much. The first name, AI Horizon, has won. Let's have a great flight together. We're moving to the next sections. Thank you very much to Sber for organizing the event, and see you next year. A round of applause for the participants of the plenary session. I would like to thank all the scientists, globally renowned scientists, as well as the experts in AI. And a huge thanks to Dmitry Chernyshenko for moderation and summarizing the one-year foresight on AIJ venue, moving the science together with the best professionals in the world. Some great and exciting reports and presentations and renowned experts are ahead, as well as the award ceremony. And now let's have a small break and prepare for the AI journey. We are reconvening in 10 minutes.
В начале 2025 года на Череповецком химическом комплексе группы «Фусагра» была запущена в промышленную эксплуатацию российская автоматизированная система управления производством. В отличие от зарубежных аналогов, функционал системы существенно расширен благодаря внедрению технологий искусственного интеллекта. В проекте используется большая языковая модель GigaChat Max, дополненная специальным модулем для работы с внутренним регламентом компании. Для повышения точности ответов внедрен модуль Context Protocol, предоставляющий модели доступ к инструментам и позволяющий реализовать логику ИИ-агентов. Агент выполняет поиск по базе знаний, обращается к прогнозным ML-моделям и другим внутренним системам, обеспечивая точные и актуальные ответы для технологов и операторов. Результат внедрения искусственного интеллекта – оптимизация производственного процесса, поддержание технологического режима, снижение перерасхода ресурсов и выполнение расчетов любой сложности.
Переходим к инженерии идей.
Moving to engineering of ideas, hybrid and cognitive systems, new architectures, and bio-inspired AI, where mathematics is coupled with intuition and nature inspires the design. We're continuing our keynote talks section, the new era where AI combines the digital, the material, and biology, trust, agro, energy, and healthcare. Everything is on the table. What works and what not? How do you ensure that you negotiate the issues across the countries and build trust? Institute of Computing, Unicamp, Professor Anderson Rocha. Artificial Intelligence in the New Era, Foundations, Trends, Opportunities, and Global Collaboration.
Thank you for being here. I'm going to be your provocateur now. I'm from Brazil, a very small city called Campinas with 1.5 million people. And the idea today is to talk about BANG. So BANG is an acronym for bits, atoms, neurons, and genes. Everything that we are living nowadays is related to one or more of these letters. Communication, internet, social media, AI, that's bits. Material science, energy, new forms of energy, renewable energy, that's atoms. Research in understanding the brain, this is neurons. Research in longevity, how to live longer and better, how to cure diseases, this is genes, this is biotechnology. And then when we consider all of this together, we have what's called convergence revolution. We have 5 technologies that are changing the way that we live. The first one is genetics, biotechnology. The second, nanotechnology. The third, robotics. The fourth, Internet of Things. The fifth, AI. In the years to come, we have number 6, quantum computing, and number 7, blockchain. An example, the vaccine of COVID-19, it was discovered in 3 weeks with AI algorithms and the technology of CRISPR-Cas9, the mRNA, the scissor that allows us to go to the DNA and cut it, edit it in the right place. Then, of course, we needed months to test it. If we consider nanotechnology, we have now mini bots, nanobots that we can swallow and it will image, for instance, our stomach for diseases. If we consider robotics, if you go to a warehouse, you're going to see lots of them in place helping humans to solve problems. Everything is connected through the Internet of Things, producing data all day long. And then we have artificial intelligence at the center of it. All of these together are called exponential technologies. Each one of them is exponential, not linear. Their growth is not like this, it's like this. And then if we advance one of them, it will influence the others. And they will converge to a single point. That's the convergence revolution. And all of this gives us the feeling that there is a big wave coming at us, just like this example in Kanagawa. And we have this feeling that everything is happening everywhere all at once. And that's true. As I mentioned before in the previous section, 1 year in technology in AI is just like a decade. Right? It's very fast. So for the purpose of this talk, let's define AI. It's not philosophical, it's not religious, it's an engineering definition. Every computer system, any of them, that we can collect data from the world, process this data, interpret it, learn from it, organize it, and then use this learning capabilities to solve specific problems and adapt over time, changing the world. This is AI. And then this is a new field that's changing everything, from automation to autonomous learning. It is learning, reasoning, adapting, and acting. And then we also have these systems that will serve as a general purpose technology, a GPT, for us in many different fields. We consider AI to work in perception, reasoning, and action. How can we perceive the world? How can we reason about the world? And how can we take action? It goes from vision and audio and language to prediction models, to forecasting, and then to decision making. We have to have a critical mindset in here. As President Putin put it yesterday, we should not just press buttons. We need to think. And to think is the most important human value that we have. So if you consider the last decade, we had key advances in different modalities considering deep learning. Generative AI in the last years for text, image, audio, everything. We started a few years ago with key advances in convolutional neural networks. Then we evolved to transformers, and now we are with foundational models. And then the next one is going to be reasoning models that understand common sense and understand the world. All of these are emergent technologies and capabilities. We know that transformers, the technology behind ChatGPT, DeepSeek, and others, they changed the paradigm. Attention allowed us to pay attention, to focus on the specific parts of the data. And with that, we can transfer multiple modalities and learn different things. So foundation models now are the key infrastructure. Everyone here probably already interacted with one of these Gen AI models, DeepSeek, ChatGPT, Gemini, and others. And it's very important to consider them as tools and not as replacements of human beings. So these generative models, they allow us nowadays to study proteins, molecules, material design, creative industries, simulation and digital twins. First question to you to think when you go home. If models invent new molecules, who owns the intellectual property? So to put this in context, I'm going to show you some of the research that we do in my lab in Brazil. I created in 2009 this lab with a few other colleagues. We are nowadays 350 collaborators around the world, and 200 inside the university, and 9 professors. So here are some images of our lab and what we do there. And I'm going to show you one example in health and well-being. This word in Portuguese, viva bem, means live well. How can we do that? Consider that we use wearable technologies like rings or smartwatches. They have a myriad of sensors, accelerometer, gyroscope. It can measure temperature. It can measure the amount of fat and muscles that you have with bioimpedance in your body. What can we do with it? We can do studies in neuroscience. We can do studies in physical education for performance. We can develop AI algorithms to help people live better. We can put this in the industry with software engineering. In this example here, we have 11 lines of research. The first one is how to detect early signs of Parkinson's. We do not want to detect Parkinson now. We want to detect the early signs years in advance. As soon as the watch can sense the first tremors, can we calculate the intensity? Can we detect early signs? If the person already was diagnosed with Parkinson's, can we see the effects of the medication and see if the medication is working? All of these are objectives of our research. Another example here is number 8. How can we help the elderly? We do not want to detect falling. Suppose that I have one watch here and then I fall. I could detect that easily because it changes a lot in the sensors. But I want to detect early on. I want to detect that this person is losing strength. There is a problem with the elderly when they lose strength, when they lose muscles. This is called sarcopenia. If the elderly lose strength, there is the likelihood that in the future they will fall. And falling is one of the major causes of death for old people. What we want here is to signal to this person, look for a specialist. There is something wrong. You are losing strength. Or with number 10, anxiety. We have now algorithms to allow us to detect with more than 90% accuracy when the person is anxious. And anxiety is one of the greatest problems of our times. We can prepare reports like last week you had 6 episodes of high anxiety. This week is 13. Something is going on. You should look for a specialist. We collect data to understand different activities and to help training the algorithms. Like this one, we collect different activities like sitting in a chair, dancing, drinking, watching TV, standing, just working. We call people to the lab and we have them to sleep in the lab. Yes, people will sleep in our lab for the good sake of science. And then we collect data during the night to prepare a report for them about the quality of their sleep. And then with that, we can learn the best features to help people live better and sleep better. For all of it, we collect the data also which areas of the brain were active during sleep. We do it for anxiety as well. How can we simulate anxiety in the laboratory? Of course, we could have some people putting the hands inside a box with a cockroach, but we don't do that. We ask them to do a mathematical calculation in their heads, just like how much is 13 times 396? Under 20 seconds with the watch in front of them. So the more the watch goes down, the closer to 0 second, the more anxious the person gets. And then we learn the curve of the biosignals that this person has. And this is this acquisition data situation. Here we collect brain activity, blood pressure, heart rate, exhaled CO2, electrocardiogram, all of that to learn how to detect anxiety. And here are some of the changes that we have for people that are anxious and not anxious. So we learn about the stressor, we learn about the condition of stress, detect the state of anxiety, and understand the semantic and physiological insights with machine learning. Here's an example. If you look down, on the left, you have an image representing the signal. It's a very low, very small red part. And then on the right, you have more active red. So that's the difference in the signal with our method. The image on the left is a person with low anxiety. The one on the right is a person with high anxiety. We also have a method to understand the activities the person is doing to detect sedentarism. People think that if they do 1 hour exercise per day, they are not going to be classified as sedentary, but that's wrong. If you walk 1 hour a day and then sit for 10 hours, you are in danger. So here we understand all of the things related to the biosignals that help us tell that person that something is wrong. So if you want to know more a little bit about our project Vivaben, you can go to this website. There is an AI translation behind it. Another example that I want to show you today is called synthetic reality. Synthetic reality is when people fabricate new species. Like in Brazil, we have lots of fabrication of new species regarding medications, fake doctors, magical treatments to help people cure diseases, but they do not exist. So how can we design algorithms to detect this kind of thing? So what we do is to develop AI algorithms. Just an idea for you. In 2023, as of August only, we had 16 billion images generated with AI. So data is all around. GPUs process this data with AI at the center. And we can produce marvelous things like this one. This is a painting, quote unquote, created a few years ago in an art competition. The thing is, the author, the artist, won the award, but then afterward he admitted that it was the creation of AI with 800 interactions. This is the artist. Important thing, about 3 billion people use image editing apps regularly. Every single day, we have 34 million images generated by AI in the internet. And most important here, every 2 pieces of fake news, one of them will use a fake image. So if we can detect a fake image, we can detect that something is wrong. What we can do? Well, we can combine different algorithms using mathematics and probabilities. We can develop specific detectors that analyze the noise of the acquisition of the image. Like this, on the left you see the face of a person that's real, so it's richer in terms of noise. Then when it's fake, you have like less information in the face, in the eyes. We are also developing methods to detect scientific forgeries. People are fabricating results when they publish. And this is bad because they fabricate new medications. They pretend to have the cure of cancer, but they don't. How can we detect they are faking results? This is what we do. And we develop these methods. They are open source, like this one that can detect when a person is imitating another. When an image has been edited with a software, or recently we proposed an algorithm to detect at the level of a pixel if it was modified. Or how to extend GPT or Gemini or DeepSeek to understand what is fake. So here you can interact with a chatbot, upload an image and ask, is it fake? Where? Why? How it was modified? So this is what we are doing. All of this is inside this project that we created a few years ago called Horus, which is the Egyptian god for truth, son of Isis. And with this project, we want to help society to understand better what they are reading, listening to, and watching. We design methods to detect when a person is falsifying identity, or posting something pretending to be another, or when you receive a fake contact with a bank in Telegram or WhatsApp, how do you know it's your real bank contacting you? This is phishing, and we do design algorithms to detect that. Or even people that are using AI to create child pornography. It's very important that we detect this kind of action. Phishing, as I mentioned, is when you get a message in your phone asking you to give your credentials. How to make sure that that contact is real. Or a deepfake, when a person creates another image or a video of yours that's exactly like you. How do you detect? Or when you have your phone, it's face recognition. What if a person presents another phone with a photo of yours or a video of yours or a silicone mask pretending to be you? How can we detect that that's happening? This is security. And we do develop algorithms to help detect that. How do you protect your children? What they watch in the internet. So this is parental control. How do you prove that someone that's talking to you is really there live, and that's really that person? So this is liveness detection. And how do you protect content that you put online? All of these are related to synthetic realities, and we develop algorithms to help in that. In scientific forgeries, there are people that get other people around and they fabricate results like fake doctors, fake medicine, We develop methods to help identify that. And we do mind about the protection of children online. So if you want to know a little bit more about this, go to recode.ai. Let's get real. AI is here and is here to stay, as this ad was in Davos some time ago. When we consider the key open challenges here, it's about trust. How can we make sure that the algorithms do not hallucinate? How can we measure the uncertainty? How can we make sure it's fair, or that it does not misuse our data? How can we make secure systems? How to develop governance in terms of regulation and innovation? Consider the energy problem, for instance. How can we scale to do all of these calculations without exploding the consumer of energy? We need efficient architectures. We need new methods. We do not want data centers that consume as much energy as the city of Moscow. We want to develop methods that are much more efficient and that really helps us solve real problems. Here we have the global inequality. Compute, data, and talent gaps. How can we bridge that gap? Language inclusion. How can we make sure that minorities are represented? How can we make sure that languages that are spoken just by a few people are not lost? So if we do not take action, we can increase geopolitical divides. Another question for you when you get home. We made machines smart. Can we make them responsible and aligned with our objectives? So here are some trends that we see in research and development for the next years in artificial intelligence. Instead of having these big, large language models for everything, we start having small language models for specific domains that are efficient and that really help us to solve problems. We are going to see AI more and more embedded in small devices instead of just connecting to the internet and doing everything there, consuming a lot of energy. We are going to have research in reducing hallucination and in increasing the truthfulness of responses. We are going to have better algorithms in terms of alignment with our objectives. Multimodal real-time systems and agents to help us solve different problems. AI for science more and more. You might have heard that a few months ago we had the first solution using AI to kill bacteria. So the first bacteria fighting algorithm, antibiotic, the first antibiotic ever developed by AI. So this is the new trend, using AI to help you design new medications, design new molecules. So what's on the rise right now? Lower latency models, lower cost, specialized small language models, new patterns, new UX interaction forms with screens and other devices. What are crucial here to truly require large language models? So instead of just deploying in your business large language models, ask, is it really necessary here, or should I use something more efficient? To reduce hallucination, we need to think about self-reflection. So the method needs to understand its presence. It needs to be self-consistent. So if I start talking to this chat 1 hour ago, during the whole conversation, it needs to be consistent. If I come back tomorrow, it needs to be consistent. How can we implement this with different agents in our day-to-day? Retrieval augmented models is just not the answer. So if I have this model here and I use this memory, it's not enough. I need also to implement other algorithms like causal and effect, understanding of the word. So in terms of multimodality, combining different methods, we need to consider text, image, audio. The word is multi-signal. I should not focus only on text or only on images. How can I process this together? So we need to go beyond the normal models that we have nowadays to consider also intelligent systems that will see, hear, and act. We need them to help us plan, to analyze big quantities of data. We need to have collaboration and think of AI not as artificial intelligence, but as augmented intelligence, as a way of increasing our capabilities. We should think of also how to generate data to help us train these methods. We call it synthetic data. So there are many opportunities here. In science, for instance, new medications, new ways of detecting diseases, or like just in the case of health and well-being, how to anticipate signals of something that's wrong. Creating digital twins to understand better a factory and how to produce better and more efficiently and more effectively. Precision algorithms, you know, in a few years, we are going to hit 10 billion people in this planet. How can we feed all of these people? We need better seeds. We need to be resilient to climate change. We need to produce food that's more nutritious. And to do that, we need research, we need science, we need technology. Where is your unfair advantage? Data, compute, algorithms, what we need to do better? Think about personalized healthcare. Medicine during all of history was designed for the average. So we understand what is a headache, we understand what is like measles, and then we prepare medications for the average of the population. But now, with biosignals, we have the ability to design methods specific for a person. And that can be much more effective and allow us to finally live over 100 years. Sectors most impacted now are finance, healthcare, biotechnology, industry, law, energy. New business layers in a few years, AI security. If you are starting your career now, one important career that's gonna be crucial in the future is security of technology, security of AI. Specialized AI models optimized for particular industries. Another profession in the future that I think, evaluation of the alignment of the AI algorithms to the human objectives. How do you make sure that it's aligned? What the human wants and what the algorithm is solving. Is it aligned? So probably we're going to have specialists to understand and to solve that. So let's think of this. Artificial intelligence should not be artificial. It should be augmented intelligence with the human at the center. Human-centered artificial intelligence. Once again, let's get real. AI is here to stay, but we need to drive where we want to be with it. We need to be in the loop. That's what I wanted to tell you and to provocate you today. Thank you very much.
Thank you, Professor Rojas. Thank you. We wish you a great success in your scientific discoveries. Thank you very much.
Thank you. Thank you.
А мы продолжаем.
And we are continuing. When there's a lot of data and not a lot of time, not only results, but the way you train neural networks is important. From classical black prop with its deepness and the limitations in the industry to stochastics configurations. What works in a more stable way on the real production line? And we will learn that just now. Professor of the University of Science and Technology of Tsingtao, Jianhui Wang. questions, problems, and developments in the field of machine learning.
Hello. Very glad to have opportunity to talk something in Russian. So that's my first time in this country. I think I spent some time travel around in the last 2 days. I found Moscow is a quite expensive place. Okay. I think today I will share my knowledge and my research experience on machine learning. Okay, so what I will say are issue, challenges, and developments. All right, so this is especially for application for industry. Okay, people talk a lot about machine learning, deep learning in the past. But from my perspective, for real industrial application, okay, or we talk about industrial AI, I think not enough. People start being aware something, okay, but where is the solution? So that's really, I think, significant for further development. Now, I think, let's see, where I'm living. Indeed, I'm Australian citizen, okay? My home is in Melbourne, Australia. But now, for some reason, I came back. Now, I'm living here, okay? So here is Beijing, and here is Qingdao, right? Here is Moscow. So this is a city where I'm living in now, Qingdao, okay? So it's a coastal city, okay? Very good environment. That's a university I'm working. Now, I think some philosophy for doing research. I think different people have different opinion, okay? To me, I think we need to understand something. Everything we hear is opinion. Probably not the facts. Everything we see is perspective, not the truth. Okay, so this is from Marcus, Roma Employer. Today I will talk, I think, 3 things: challenging, development, and perspective. That's from my personal point of view, okay? I think in the end, for doing research, I believe logic will work, and the great truths are always simple, okay? That means if you make the learning algorithms very complex, I don't think it's a good solution, okay? Now, I think let's talk something about AI technology meets process industry, okay? Composition of process industry, we have a device, we have a material, and then we have parameter, okay? So this process parameter really matter. So will affect maybe the power, the energy you used. Also will affect the quality, stability of your products. Okay, that's obvious. Then we have some association with machine learning about this, how we can make these products stable and how to save energy. So here we have several things, including modeling, automation, and intelligent control. So that's indeed my background from computation math and went to control theory. At the end, my PhD is industry automation. So that's why, so I can understand this stuff, okay? Now, take a look. Lightweight model we need in next generation of industry automation, okay? So it goes Scalability, so that means we use edge computing-based, IoT-based application, okay? So we have a system adaptation, so we need very fast tuning of your machine learning models, okay? And then real-time automation, so far we have a neural nets solution, different heuristic solutions. But to my opinion, I think probably we should go to randomized approach. Okay, so randomized approach, we never seek optimal solution, but feasible solution. Okay, and control algorithms. So nowadays, I think very popular. People use PID, and sometimes for delay system, PID doesn't work. So most of industry partners, they told me they are interested in developing nonlinear or adaptive MPC, so model predictive control. So in model predictive control, what's a big deal? A big deal comes from the model, predictive model. So that's to say, modeling, you build predictive model so the model can work with a high accuracy and robustness, okay, against some external environments change. So this is very important for industry, okay? So all things, I think, are certain, okay? Probably from the sensor, probably from the careless of the operators, nobody knows, suddenly changed, uncertain, okay? So in such environments, how we use the collected data to build a model, so the model can perform as expected. Now, so the first part, let's talk a little thing about issues and challenges in machine learning. The first paper, very influential, I think published in Nature, okay, 1986. So 1986, this paper is talking something about this type of neural nets. And ideally, the neural nets feed-forward, fully connected, we call it a multi-perception model, right? But this model cannot be trained because the active function is step function. So that's people feel very difficult. How to we understand the model is capable to solve some problem, but the key is we don't know how to find the parameter of the model. Okay, so that time, I think the paper come out, published in Nature, and people talking about we can use this sigma model function to do approximation of the step function. So in this way, we can use the bifurcation, gradient descent approach, very simple mathematical optimization solution, right? So that's old time. After this work published, I got 1,000 work published in different way to improve the learning algorithm, even use fuzzy logic. Okay, how to change the learning rates, how to initialize the weights, a lot of work. And then the next year, 1987, so 3 groups of people from Japan, from United States, from Germany, they published a piece of work, okay, talking about universal approximation property of such a network model. Now, I think 2 years ago, a group of people from Cambridge, Oxford, UK, they have a workshop talking about these kind of things, neural nets, robust, reliable, how to improve these performances. Then I gave a talk. I think in the end, people, after discussing, we conclude something. So universal approximation property just gave people hope, but nothing to do with design. Okay, because here I believe probably you know neural nets. You train neural nets and put this model into practice. Okay, but the first thing appear on top of your mind is how to design. Okay, how many neurons in the head layer? How many layers? Nobody can give a very clear guideline. Okay, so this is the current status. Now, because of this, so people already, when I can't say exactly wrong direction, I have to obey the facts. So bifurcation learning algorithms promote these AI developments. But I can't say too much about this. Okay. Maybe wrong direction, okay? Now, you say, why bifurcation? I will show you a simple example, numerical example, then you understand why we have to think the bifurcation is something, okay? Now, let's have a look at this simple numerical approximation, a function approximation, okay? So the blue is the function to be approximated. Now we run MATLAB standard tools, okay? I show you different epochs, so 50 epochs, and the neural net model perform like this, the red line, okay? So I don't think you will be happy with the performance, right? After, I think, 2,000 epochs training, we spent 35 seconds. Do you think you are happy with the performance? I don't think. That's people talk too much about learning, deep learning, but nobody really pay attention. So this is totally wrong. We have no trust, no confidence you can get a model well trained to perform your task. Okay? So this is a very simple numerical example. You can imagine if the task became so complicated, how you can believe your model, your training algorithm works. Okay? Now, another practical case study. So the data is, I think, from Northeastern University. We try to predict these three parameters. So this material. These three parameters play key roles. So let's try to use bifurcation, MLP with bifurcation, okay? So you look, we made 100 trials. The green is the area for generalization, prediction, okay? That's, I think you can see, very unstable, okay? What's wrong with this bifurcation? Because initialization make a difference. So every initialization of the weights can result a new model, and the model converging to local minima. Okay, whatever, done, finish. So then I test the model, okay? So you get 100 trials, and then the error very unstable, demonstrate this instability. So when people talking about reliability, do you think the reliability of this MLP with bifurcation is good? I don't think so. Very unstable. So I have developed with my students some we call the stochastic configuration network, and then the performance comparing with this bifurcation-based MLP, I think much improved. Okay, so you can tell that's a prediction performance. Okay, now let's say something development of these machine learning techniques. That's I'm citing my stuff. Okay, that's a stochastic configuration network. Now, that's I think I feel is original, innovative, and then real-time data processing, and then we tried to interpret the precise how we construct this model incrementally. Okay. Now, I just show you the example, the same example for function approximation. I use just 33 epochs. I spent the time 0.36. I can build a model exactly like this. 100 times faster. But I can make very accurate approximation, as you can see. Right? So this simple example shows something, demonstrate, so this stochastic configuration network really can work. Okay, especially is a lightweight model. Okay, that's why today I came here. I spent 9 hours and 40 minutes from China flying here. I share with the knowledge with you. Okay, now I just let me introduce briefly what I say it is. We have different versions. You can find it, even you can download the code from my research homepage. So this is, we have a term called a bridge MLP. Multi-layer perception model, but we have a bridge MLP. So that means from input layer to the output, we have a direct link. Also, each layer, we have a link to the output. So this is a bridge. The lines in red, we need to evaluate. Other parameters, for example, in the black, random assignment, finish. One pass. And also, we have this incrementally constructed. Rather than given architecture, you tune the parameter. Doesn't work. Okay. Even you think mathematically it doesn't work. At least, so the error for the learning, it cannot be zero, cannot be free, zero free. But this way, I can result the model, very quickly build a model, and then mathematically we proved. So that's error free. That means universal approximation property holds. Okay. Now, this is a key contribution from my group. So that's published in 2017 in Transsegment Cybernetics. So here is the key contribution. Before, all randomized learning, so they have no constraint, illogical thinking. Simply, they assign random parameter here in the black lines. Okay, and evaluate the right line just using least square. So very fast. You can see thousand publications about this. I do believe somehow it's misleading or poor understanding. Okay, so I'm the person just brought this illogical understanding. And I think draw a right direction for this randomized learning. Okay, let's have a look. Sorry, because this is a diamond, I don't know how to control this. Doesn't matter, okay. So let's share some practical application, so real case study, okay. So you can have a little bit more belief about this action, okay? So this we have a data-driven software sensing system. So that's widely used for industry, okay? That's inputs, and then we try to predict this grading particle size. Okay, so currently still I'm in the loop. Still in process, this project with a big company, okay? So now what I'm trying to show you is the comparison results with the well-known MMP, okay, trained by propagation. Look, MLP, this is a training performance, a test performance. And ours, so RVFL is a constraint-free randomized learning algorithm. So random vector functional link. Still, a lot of people around the world, they still trying to use this RVFL, but theoretically, I can prove, okay, cannot. SAN always outperforms than RVFL. So this is the work we published in Transaction Industry Informatics last year, okay? So obvious, so our SAN can outperform. Now, it's another example. So currently I got involved. I'm the director for these, the key contributor for developing intelligent control system, okay? So this system is very difficult to be controlled. Very valuable, but very challenging, okay? So this is polysilicon reduction furnace. Probably you don't know. You can check after this meeting, okay, conference. Now, let's use the closed loop data to model, okay, because I have no open loop data available, only closed loop data available. Okay, let's use the closed loop data to build SAN and see what's happened, okay? So this is the inputs, and then we have the output. So in total, we have 42 inputs, but these inputs we are sampling, okay, some inputs in different time instant. And we have 15 output. So this voltage and atomization level. So this is very important because we can't measure the temperature on surface. So no other ways. We have to do some indirect way to control the system. So hopefully this design, this MLP will have a good performance. Okay. Indeed, PID stopped working for this system already. Now, let's have a look at the performance. Okay, so we set up, set up the experiments like this. So 24, and the first layer, 903, and the second layer, 304 neurons, okay? Then we spent probably 2 hours time. We got the neural nets done. If we run MLP, the same architecture using bifurcation, forget it. Maybe you get maybe 1 day time, okay? Converging very slowly, and then the performance very poor, okay? So let's have a look at what are the results we obtained by using stochastic configuration network. So indeed, it's a deep version. We applied these terminal conditions, stop, early stopping, okay? Also, we applied the regularization. We proved a small perturbation. Then now, 40 runs, the real runs from the industry, we collect the data, right? And then we use another 20 runs data to do testing. So you look, so this is the, I think just for 1 voltage. You can see that's closed loop data. So we can predict model perfect, right? You look at this atomization level using SAN, right? The truth, backgrounds, and the model output almost fitting very well. So this is, I think, 2 industry case studies I saw you, right? Now, I think the last part, I express my perspective on this machine learning, especially for industry application for next generation of automation. Okay. First, I think scalability and flexibility. Here, scalability, everyone understands. So we goes the machine to be controlled, maybe not a single one, a group, right? A group of tasks. So we have to consider how you design the control system in I think IoT based, okay, control system design rather than like before, single one. And also flexibility here refers to adaptation capability because the data we collect just like a closed loop data offline. But in the real time, when we do this modeling, we have to tune the model using the nearly collected data, right? So this step, that's what we call the adaptation. So we need the very fast tuning. You think, imagine, if we have neural nets with millions parameters, can we do the job in real time? Because the sampling is very limited. For example, 3 minutes, even seconds, you have to get the job done. Okay? Tuning the parameter, adaptation, the model. Now, I think AI and machine learning offer more intelligent solution. So these, I think, we can't avoid in the future, next generation of industry automation system design. So now, I think we have this AI algorithm on our hands to further develop. Okay. A lot of people think maybe generative model, large scale language model is really something, but this is for social, not for industry. You think of this for industry. Do you think that's a big deal? More important than social information technology, your retrieval with interactive. So this is, I think, people have to consider this. I heard a lot of competition among the nations in the future is how you can produce lightweight model. Okay, so stochastic configuration network itself is lightweight already. So I can use binarized weights in the model as well. Okay. Now, I think physics-informed neural nets already became, in the past 10 years, published a lot in Nature, Science, and relevant journals. So that idea is we have governing equations. So basically, it's try to solve the problem. Limited data subsets cannot generate a good learning model with good generalization. So this is the idea. So we have something constrained, and we have some data available, collected. So how we use these two information to build a machine learning model. So here is something, I read a lot of publications, but I find still something wrong, okay? Not enough. Also, I believe, my personal opinion, I think knowledge-based informed neural nets should be a very promising direction in the future. For example, we understand output variable is monotonic with respect of special inputs. What to do? Can we embedding such knowledge into learning process? Okay, very important. Key conference, reference, that's my master supervisor, my PhD student, my lifetime friend, Ivan Turkin from Caltech. Okay, I appreciate a lot. We discuss a lot and collaborate personally and professionally. Thank you all for your listening and attention. Okay. Yeah, thank you so much. My contact information, dh.wang@deep HN.com, my research homepage, my WeChat if you are using WeChat. And here some advertisement opportunities for taking postdoc position under my supervision in China, if you like. Okay? No limits. The number is open now. We have CIC scholarship available. I think now it's still opening. If you like, you can apply online. So here, the last line is in Russian, so you can read easily. Thank you so much. Okay.
Thank you so much. Thank you for sharing your experience with us. Thank you.
Yeah, do you think you have a section to ask question, answer?
I
No?
think we could do it offline when you are working on conference. But maybe if anyone has question, you can ask.
Just one question. Any question you can ask me.
Just one question.
Yeah.
If our audience have.
No question, that's fine. So we can talk after the conference. Okay? We'll come.
Thank you. Thank you very much. Thank you.
Thank you.
Ну а мы продолжаем исследовать китайский.
We continue exploring Chinese experience. When we have more tasks than hands, algorithms have to be designed by algorithms. The point is artificial intelligence designing solutions in a cheaper and more accurate way than we do manually, from neural networks to evolutionary approaches. This is the topic of the next speaker's presentation. Professor of Anhui University, Ye Tian, with a presentation on automated design of AI algorithms.
Good afternoon, everyone. I'm a researcher working on the fundamental technologies of artificial intelligence. So today, I would like to share you an emerging topic in the era of fast AI development, that is the automated design of AI algorithms. So my name is Ye Tian, and I'm from Anhui University, which is located in a central city of science and technology in China called Hefei. My research experience includes some AI technologies such as evolutionary computation and reinforcement learning. Also, I have some AI applications in intelligent manufacturing, transportation, and medicine. With the help of AI, I have made some AI-assisted systems such as the assembly line scheduling system and the material topology design menus. So today, my presentation about the design of AI includes 3 parts. The first part is about some introductions to basic AI algorithms. During the development of human, from Archimedes, Euler, Turing to advanced AI menus, people use more and more complex algorithms to solve more and more challenging problems, from the calculation of pi to large language models. With the development of mathematics and computer science, the menus goes from mathematical algorithms, computer algorithms, to the advanced AI algorithms. Currently, AI algorithms have been adopted in many different applications. For example, the image processing, the content generation, the science, the automation, the decision making, and the design. In these applications, the first 2 applications, image processing and content generation, are highly related to our daily life. Everyone maybe use them. But for the other applications in biology, manufacturing, and economics, they are also very important to the revolution and the development of the whole society and the industry. So Although these problems are totally from different areas and have totally different objectives, they can be broadly divided into learning problems and optimization problems. The learning problems are to find a function f to make input x and output y satisfy that y equals fx. It's a simple mapping problem. For example, in image processing, the input may be an image observed by a camera, and the output is the label of the image. In content generation, the input may be a description, and the output is the content generated according to the description. In science, the input can be a structure of proteins or materials, and the output is the performance of the structure. And also, in automation, the input can be the current state of the system or environment, and the output can be the next action to be conducted for the system or environment. Also, in optimization problems are to find a solution, the best solution, x, to make a function f optimal. For example, in decision making, the solution x can be a decision for the program, and the functions can be the profit objectives after making the decision. In design, the solution can be a scheme to be conducted, and the functions can be one or more performance indicators of the scheme. So currently, there have been many methods to solve the learning problems and optimization problems, from mathematical algorithms, computer algorithms, to AI algorithms. Currently, in AI, the most representative methods are neural networks and evolutionary algorithms for solving learning problems and optimization problems, respectively. The neural networks are inspired by neural connections in brains. They can act as a function f to learn the mappings between input and output. Some popular neural networks, such as fully connected neural networks, non-short-term memory, convolutional networks, transformers, and diffusion models. Also, evolutionary algorithms are inspired by the biological evolution in nature. They can iteratively search for the best solution to make a function f minimized or maximized. For example, there are some popular evolutionary algorithms that include genetic algorithms, particle swarm optimization, differential evolution, ant-colony optimization, and the multi-objective optimization algorithms. So, compared with other mathematical methods and computer methods, these two AI algorithms have their advantages in solving very complex learning problems and optimization problems. For example, for neural networks, they have the abilities of nonlinear model and data-driven learning. As a higher nonlinear model can be obtained to learn the complex mappings between input and output in the chaotic real world. Also, owning data is required to train a model where domain-specific knowledge is unnecessary. On the other hand, for evolutionary algorithms, they have the abilities of multi-objective optimization and black box search. It means that for evolutionary algorithms, they can optimize multiple objectives and constraints simultaneously without the need for combine them into a single one. Also, only function evaluation is required to search where the domain-specific information is unnecessary for evolutionary algorithms to search. So there have been many variants of neural networks and evolutionary algorithms. As a neural network architecture has many components and parameters to tune. For example, the type of layer, the collections between layers, the parameters of layer, and the training configurations. Also, for evolutionary algorithms, they also have many components and parameters to tune. For example, the type of operator, the collections between operators, and the parameters of each operator. So here's an important question comes. How can we tune the parameters and components of neural networks and evolutionary algorithms? Or on the other hand, in other words, can we find the best components and parameters for neural networks and evolutionary algorithms? So the answer is no. We cannot find a single neural network or evolutionary algorithm to solve all the problems. This is because of the so-called no free lunch theory. This theory has been theoretically proved. It's correct. It says that all algorithms perform equally well when averaged over all possible scenarios. Unfortunately, it means that we can only find the best components and parameters for each scenario. And the best components and parameters for different scenarios may be very different. That is, we cannot have a single AI algorithm to solve all the problems with the best performance. In practice, AI algorithms can automatically solve problems, but AI algorithms themselves are manually designed by AI researchers and programmers. The design of AI algorithms is not easy because it requires heavy expertise, novel innovation, laborious experiment, and expensive cost. It's a very difficult and challenging problem. So here another very challenging question comes. Can AI algorithms be automatically designed for different scenarios so as to reduce the expensive requirements in the design of AI algorithms? So the answer comes to the second part of my representation, is the automated design of AI algorithms. In general, the use of AI algorithms is labor-intensive, since AI experts and problem domain experts need to perform algorithm selection, component combination, and parameter tuning, and also the algorithm performance evaluation many times, so that they can get a good AI algorithm with good components and parameters to be used in different problems. With this case, we can use the automated design methods to automatically generate new AI algorithms. The automated design is a higher level of automation, as it can totally make the expensive procedure totally automatic. In other words, we can use computers to design totally new AI algorithms instead of human experts. The automated design has several advantages. The first one, it can improve the development efficiency. The automated design of AI algorithms reduces the requirements of expertise, innovation, experiment, and cost. Second, the automated design methods can improve the algorithm performance, because the automated design AI algorithms can be better than those designed by humans. They can break through the design limitations of human experts. Third, it can improve the cross-domain transferability, since the AI algorithms designed on existing problems can be adaptively transferred to be used in other problems. Generally speaking, it seems that the existing AI algorithms is good enough in many applications, such as large language models and content generation, as well as playing golf. But in fact, these applications need a large number of data sets to fully train the neural networks or searched by evolutionary algorithms. However, in many other scenarios, we cannot get such a large number of data sets, especially in the applications in industry and manufacturing. In this case, we should have the automated design methods to design more effective and more efficient AI algorithms automatically to break through the limitations of human. So the issue comes to what to design, where can it be used, and how to design. As for what to design, the automated design methods can achieve the combination of components, the tuning of parameters, and the creation of totally new algorithms. As for where it can be used, the automated design methods can customize new evolutionary algorithms for solving optimization problems, and customize new neural networks to solve any learning problems. As for how to design, in fact, the automated design methods are also based on existing AI algorithms. That is, we can use existing AI algorithms to generate more effective and more complex new AI algorithms. AI algorithms can develop and evolve themselves. Then I would like to introduce some representative automated methods for the design of neural networks. For example, the parameter tuning aims to tune the parameters of a neural network. The architecture search aims to find the best architecture of neural networks. And the network quantization aims to find the best quantization bits for neural networks. Also, the prompt optimization aims to find the best prompt text for large language models to be used. As can be observed, all these automated design methods are in fact learning problems. No, are in fact optimization problems. That is, this task aims to find the best parameters, architectures, quantization bits, and the prompt text. Therefore, these automated design tasks can be handled by existing optimization algorithms. For example, the existing evolutionary algorithms, Bayesian optimization, gradient methods, and heuristics. Next, I would like to introduce some automated methods for the design of evolutionary algorithms. For example, the algorithm selection aims to select the best evolutionary algorithm for each problem. The component combination aims to switch between different components in an evolutionary algorithm. The parameter tuning aims to find the best parameters for an evolutionary algorithm. And also, the algorithm creation aims to create totally new algorithm source codes for new problems. The first two tasks, algorithm selection and component combination, they are in fact learning problems. They in fact aims to learn the mappings between the best components and the problem features. Therefore, they can be handled by existing learning algorithms. For example, the supervised learning and reinforcement learning based on neural networks. On the other hand, the parameter tuning and algorithm creation are in fact optimization problems, as they aim to find the best parameters and algorithm source codes for each problem. Therefore, they can be handled by existing optimization algorithms. For example, the evolutionary algorithms and the generative model-based search. In the third part, I would like to introduce some representative applications of the automated design of AI. The first application is biological sequence analysis. This problem aims to build models for biologists to analyze, evaluate, and create new DNA, RNA, and other biological sequences. It's an important learning problem in the field of biology, where the input can be the biological sequence and the output can be the analysis result of the sequence. However, this problem is very challenging because biologists lack AI expertise to build effective neural networks to biological sequence analysis. Therefore, automated design methods can be used to automatically find the neural networks, to automatically find the neural architectures and tune their parameters to achieve the best performance of neural networks for biological sequence analysis. The second problem is edge AI. It aims to process images using neural networks in edge devices with limited computational resources, not the large computers. It's a typical learning problem in the field of deep learning, where the input can be images of users and the output can be the labels of the user. It's also a challenging problem because edge devices cannot run large neural networks due to the limited memory and GPU performance. So it requires a balance between efficiency and performance. Therefore, automated design methods can also be used to automatically find suitable quantization bits for the neural networks used in different edge devices so as to reduce the computational complexity of the neural network and make it run more efficiently and reduce the requirements of hard devices. The third problem is mathematical discoveries. It aims to discover new mathematical algorithms for solving challenging problems. It's a typical learning problem in the field of mathematics, where the input is a problem statement, and the output is the source code of the new algorithm to solve the problem. This problem is difficult since large language models suffer from confabulations and make plausible but incorrect statements, and the problem cannot be solved. Therefore, automated design methods can be used to automatically revise the prompt text of large language models to make it generate better and better source codes so that to solve the problem better and better. The first problem is assembly line scheduling. This problem aims to find the best production sequence for giving orders in assembly lines. It's an important optimization problem in the field of manufacturing, where the solution can be a production sequence and the functions can include the lower production time and the lower production cost. This problem is also not very easy, since multiple evolutionary algorithms are effective for handling different constraints in different assembly lines for different scenarios. Therefore, we can also use automated design methods to automatically select the best evolutionary algorithm according to constraints in advance, so that we can more effectively solve different assembly line scheduling problems in different scenarios. The next problem is a structured design. This problem aims to find the best structure of vehicle components based on finite element analysis and evolutionary algorithm. It's also an important optimization problem in the field of manufacturing, where the solution can be a two-dimensional structure, and the functions contain lighter weight and higher stiffness of the structure. This problem is difficult because multiple solution representations are effective for different geometric structures. To address this issue, automated design methods can be used to automatically switch between multiple representations during the optimization process of evolutionary algorithms so that it can make the evolutionary algorithm use the best representation all the time. The last application is radiotherapy planning. This problem aims to find the best therapeutic field of electron accelerators for each patient based on evolutionary algorithms. It's a very important and challenging problem in the challenging optimization problem in the field of medicine, where the solution is an aperture shape and the functions contain the higher dose in tumor filled with cancer cells and the lower dose in organ filled with health cells. This problem is difficult since existing evolutionary algorithms are not efficient enough to solve this problem, where the patients are waiting for the plan and they cannot wait for too long. Therefore, we can use automated design methods to automatically design new evolutionary algorithms with better efficiency for radiotherapy planning. Well, in the near future, neural networks and evolutionary algorithms are currently the mainstream methodologies of AI. As we can observe from the reports published by different countries, the terms like neural networks, genetic algorithms, evolutionary computation can be widely observed from these reports. Meanwhile, the automated design methods exhibit a bright prospect in the development of AI, where the terms like automated machine learning, automated design of meta-heuristics just means evolutionary algorithms and something else, and also the automated large language model architecture search. These terms can also be widely observed from the reports. The automated design of neural networks and evolutionary algorithms are very popular in the academic community, as can be observed from the higher figure. The paper with automated neural network or automated evolutionary algorithm increased significantly in recent years. Also, the researchers pay more and more attention on the automated design of AI, as can be observed from the lower figures. The projects with automated neural network or automated evolutionary algorithm in a region also increased significantly in recent years. So as a result, I think the automated design methods of AI is very promising and can change the paradigm of the AI development in the near future. And unfortunately, the demand of more effective automated design methods is urgent, since currently the performance of existing automated methods are still far from satisfactory. So we should make effort on the AI theory, method, as well as hardware simultaneously. First, we need a unified framework to make the parameterization and representation of AI algorithms more easily. Second, we need an effective method to accelerate the search and evaluation of promising AI algorithms. Lastly, we need powerful hardware to improve the efficiency of the expensive automated design process. So that's all my talk. Thank you very much for your attention.
Thank you, Professor Yetian. Thank you.
Thank you.
Thank you. Thank you for such a deep dive in this topic. Thank you very much, and we wish you a great success in your future science and your future experiments.
Yes, yes. Thank you very much.
Thank you.
Okay.
Maybe anyone has a question in the audience? Пожалуйста, приготовьте микрофон в студии.
Please, the microphone. What is the question?
Professor, thanks a lot for interesting presentation. Talking about the thing that you're probably trying to tell, that you need different approaches to train models. Don't you think that entire approach might be in the different field that is like philosophical understanding of the roots of wisdom, which makes us think in the right direction, might be as different as understanding of the things you're trying to say? Like, we have classical models and we need to train them in a different way, but shouldn't we first understand entirely different thing of where we should go? So I mean that paradigm shift required to train what we have as classical models. I hope that that's more or less clear, or at least just give your answer to the way you understood my question. Thanks a lot.
Okay, thank you very much for your great question. It's a very good opinion about the future development of AI. Personally, I think currently the neural networks and evolutionary algorithms and also some other technologies are still the mainstream technologies in AI. At least in the near future, we cannot make totally different AI technologies. So we can only to create new, for example, new evolutionary algorithms and new neural networks based on existing ones. So they may be very similar to some existing ones, but they can be automatically designed that can break through the design limitations of human. For example, some parameters, if human experts to set the parameters can be 1, 2, 3, 4, 5. But we use automated design methods. The parameters can be, for example, 1.1, 2.2, 3.4, some not integers. These parameters and other components cannot be defined by human because of the expensive procedure of manual design. So we can use automated design methods to save many experiment cost, expertise, and the time in the design of AI algorithms. Of course, we cannot use these methods to find totally new AI algorithms that are totally different from existing ones, unless we have make a framework that is totally different from existing ones. In this case, we use the totally new framework, and we can find totally new AI algorithms. I think this is the way we can do. Thanks.
Thank you. Thank you for our audience for the questions, and thank you, Mr. Etienne, ваши аплодисменты.
Mr. Etienne, thank you. Moving on, when a model says something stupid very confidently, it's not charisma, it's hallucination. How do you spot it? Attention patterns as a detector, logical rigidity, logical accurateness as the goal. The Russian professor who knows it all about the reliability of an LLM with a discussion on compromise. Doctor of Physical and Mathematical Sciences, Director of the Artificial Intelligence Center at Skoltech, Head of the Learnable Intelligence Research Group at the IRI Institute, Yevgeny Burnaev, with a presentation on the reliability of modern LLMs through the lens of attention pattern analysis. Hello, colleagues. LLMs are the buzzword of the day. Everyone is interested in LLMs, so we've been discussing at length about how we are using them in different applications, business systems, critical business systems as well. Without managing and ensuring reliability of such models, we will not go too far. How do you handle these systems? How do you work with them? If we look at the concepts, we will first have to delineate the three important terms: security, hallucinations, accuracy or precision. Very often, with some of these concepts, people can be very arbitrary, so they create a lot of confusion. Before we talk about how we solve this, let's first talk about the terms and definitions. All of these three concepts and terms are based on data. They are defined by data. The data that we use to train the model and the data that we use to validate the model. What I mean is we have these three terms. Let's start with security. Security is the way the model aligns with human values. Next, we have the model correctness. It's pretty clear. We have a validation sampling that we can use to make sure if the model is aligned. We have the model's reasoning. Once again, it's pretty straightforward. There is an example on the screen about penguins. And as I said, it's pretty straightforward. We see if it fits the logic or not. If there's a fit, great. If not, there's been an error. So we have these terms. We can validate them only based on data. If there's a historical fact and the LLM gives you that historical fact, once again, you can validate it based on the validation data set. And now some different types of hallucinations. There's an example here. The first example is an LLM tells you that the Summer Olympics happened in Cape Town. That's completely wrong. It's not true. They never took place in Cape Town, and with the evolution sampling, something else was mentioned. It's just that this is a hallucination of the LLM. Another example of hallucinations is the LLM tells you about a place that doesn't exist. You will not find it anywhere in the sampling. It's a different type of hallucination. A third type is you have a document. The document says the Summer Olympics took place on Mars. And the model retrieves information from the document using RAG, but still the model says, no, they took place in Paris. It might be correct in terms of its alignment with reality, but we gave the model specific information, so it needs to base its answer on the information that we put in. So there are different types of hallucinations. They are very much context-based. So when you start detecting them and validating the responses, it's very important to remember that there are different types, and you need to classify hallucinations correctly. Clearly, this is critical for all kinds of industrial applications and systems, such as driverless systems, for example, where generative AI is used extensively, as well as healthcare information systems. Such hallucinations there could do a lot of harm. They could give you unexpected results that are less than desired. So now that we have it covered, let's talk about the way that large language models are tested or are validated across different parameters. When we ask a question to the LLM and we want to validate the answer, if it is a general question, as you see here on the slide on the left, it's not that simple to see whether the answer generated by the LLM corresponds to reality, because the LLM will be answering differently than what the ground truth says. This means that you need to come up with some unorthodox metrics that will let you know whether the answer and the historical fact are aligned. That's one thing. Another thing is that we are using question and answer pairs to validate models of this open type, but there are all kinds of benchmarks, LLM as a judge and others. But the basic option is when you have several answers that are preset and you simply need to choose one. But this is a very limited approach, and it is a setup that very often has little to do with reality, with practice. Now, we also need to be able to understand whether the LLM has been trained well, that it doesn't have any biases that are connected with its data sets, with its internal structure. And this is once again an unorthodox job. Let's first evaluate the effect. We have certain types of questions and answers. You have a list of preset answers, and you simply need to choose one of them. And we have three setups. The first setup is where and the correct answer is always the first one. Also, for the correct answer that always comes first, we tell the LLM that there is a specific score assigned to it. So 1 is correct, 0 means incorrect. So we are hinting very explicitly at what the correct answer is. It always comes first, or it may come last. The second data set is where, for the answers, we say that all of the answers are definitely wrong, are definitely untrue, so there is no correct answer in the list. Yeah. And the third setup is when we use no scores, and the correct answer can be anywhere on the list. This is what happens when you test an LLM in different languages across these three data sets. you can see that Qwen, for instance, performs really well, surprisingly, when there are no hints at all. It would seem that when you nudge the model towards the right answer, it would be easier for her to give you the right answer. Presumably, that's not the case. I personally wasn't really surprised when we were telling the LLM that there may not be a correct answer on the list. We were trying to confuse it. But then we have a setup where we do give it expressly the correct answer and tell it what the correct answer is. And still, it performs worse than with a setup where there are no tips from us at all. There's also a difference between languages. On average, the quality of answers by Qwen for the Russian language and the Vietnamese language is a bit higher than for other languages. As for Llama, as opposed to Qwen, Qwen in a situation where we say that there are no correct answers on the list, Qwen works better than when the answer always comes first, and Llama, or rather not. For Qwen, it's when the correct answer comes last, and for Llama, it's when the correct answer comes first. That means the models have some bias against where the correct answer is on the list. When we use RAG or a similar method, a lot will depend on the representation of answers in the sampling, the placement of the answers, the language, and that doesn't bode very well for systems that have zero tolerance for errors. There's also this interesting statistical metric called entropy. With the problems I just showed, an LLM can perform badly. Maybe we could rebalance the answers, the biases, using statistical methods that measure, statistical metrics that measure uncertainty. Let's measure this uncertainty, this entropy. We will find out that entropy is lowest. What does it mean, entropy is lowest? That means the LLM is most confident in the answer that it gives. So the answer is most confident when we told it that there are no correct answers on the list of 3. So if we want to apply entropy as a statistical metric of answer uncertainty, this will not really work. Offsetting biases with this obvious tool will not work. What's the conclusion? LLMs have biases, and in situations where the slightest change in accuracy is critical, this may perform very badly. This means you need to select a different method to ensure another accuracy. Entropy does not correspond to the correctness of the answer. Low entropy LLM is confident. It doesn't mean that the answer is correct. And also, even though we may nudge the LLM towards the right answer, it turns out that we're doing it a disservice. Perhaps we could penetrate this internal structure a bit deeper to figure out what's happening there, what's happening with the heads of the LLM. Are all heads equally useful? No, clearly they're not equally useful. Let's elaborate. How do you run experiments and get some value? Let's take the experiment where we have several options of an answer, and you need to select the right option. From the previous experiment, we saw that unfortunately an LLM is sensitive to bias, meaning where the correct answer is located. Let's remove positional encoding. Let's not take this into account with the statistic that we will use to select the options in setups where the LLM is most confident about its answer. And this brings us to this very obvious heuristic. For example, we have a question. We end the question with a special character S, and then all of the information about the question is contained in the embedding that corresponds to the final character S after the LLM has read the whole question. We calculate the query with the attention matrix and the corresponding head. Then we have the key. We estimate the key for the last character, the full stop. That is the end of the answer. And we calculate the scalar sum, QK score, which describes to which extent, semantically, our answer corresponds to the question. We can calculate this QK for all heads and for all layers of the transformer. The next step is you calibrate the score using a small sample. We have some labeled sample, and then for all heads, for all layers, we can calculate the score and figure out which score is the most effective in helping us select the right answer for the right question. Very interesting result. On the slide, on the left, you see the charts with selection of an answer out of multiple answers for a specific question. The black line is what happens when you use regular probability to select the option, and the x-axis is where you add examples to the prompt, a question and an example of a correct answer. You can add 2 or 3 examples. 6, I think, is the maximum. And we see that the quality of the neural network grows depending on the number of such examples, but if you do that, the selection of the right option based on the QK scores, seemingly straightforward heuristic, but the quality is way better.
But it doesn't work well on MMLU. No surprise here, because MMLU is the benchmark that is based on some very complex information. And here we're talking about the statistics about some semantical closeness of the question and the answer. It works good in reasoning chains. Now, you made some reasoning. We ask a model. You got some output. Is this reasoning sequence is correct or not? Yes or no? It's kind of the same picture. Looks like a very affordable way to do the score, to remove some of the reasoning sequences that are not of great quality. Now let's dive deeper in the structure of the attention matrices. We're going to base on topological ideas here, because all the data that are correlated between the different components of this data are not filling this manifold space. It's like they're grouping in this non-linear surface. And to process this data, you just need to describe this manifold model. One of the characteristics here are different topological characteristics like barcodes. We have an example here. We have some dots that are sampled on a 2D circle. We can, for each dot, put a circle. The circle expands, the radius increases, and if for x-axis you will have this scale, and the y will have the this. You see these lines. These lines appear when the circles touch each other, and there is this this hole. And if this hole is being closed, you have this barcodes, this bars. I mean, obviously, you can do the same in the multi-dimensional case, and you can calculate it pretty quickly. There are various topological ideas behind that describe, that are related to some invariant properties of this manifold spaces. Here you can use the attention map. It's a pretty simple way to do it here because it is all based on graphs. Now what do? We take an attention matrix that is calculated based on a formula on the slide. This matrix of attention describes how various words in the phrase, in the sentence. I mean, here we have the example where the edges represent relationships between the tokens. And if we have some threshold, the attention matrix is reset by us. And this is how we can build the level of relations between the words. If we look at different graphs, and in some way we're talking about the research on how various parts of the text and voice are relating to each other based on the scale. Now you can do it the same here. Why is it important? Because this is how we can compare the structures that are represented by these graphs that are explaining the relations in the text, dependencies in the text. If you have the graph for the attention matrix from one text and the graph for the matrix of attention from another text, by comparing their topologies, we can compare how the texts, how these two texts compare with each other based on the dependencies. It's very important. For that, there is a specialized metric called mtop_div. This mtop_div metric has a very simple interpretation. What is the idea? Now, if you want to detect a hallucination that is related to the extent in which the answer is different from the data set or the request that we put for a model. So we can calculate this topological metric in such a manner, comparing whether the answer is in line with the request, the prompt. And we are going to compare the questions with the answer in whether these two graphs are topologically the same that you get from the attention matrix. So what do we do next? We take a small sample of questions and answers. For them, we know that the model hallucinates or does not hallucinate. And then we're doing basically the same thing as we did with the QK scores. We take a couple of heads that help us to better detect the hallucinations from non-hallucinations. So this average topological similarity for the hallucinating answers should be the maximum. And we look at the difference and we see for which head, for which layer, it is the biggest. This is how we select one or a couple of heads that can detect hallucinations the best. And the result is very interesting. Basically, it's unsupervised method. We don't need a huge selection here, huge data set. I mean, if we have a couple of dozens of examples for this and that, that'll be enough. This is an unsupervised learning. The second one, self-check GPT. The first one is supervised learning. Anyway, self-check GPT is when the LLM generates the answer, checks whether there are hallucinations or not. The things you see here are ranks. What method is the best in terms of detecting hallucinations? And it turns out that the ranks that this topological heuristics gives us on language models, it's pretty high on average. It's like second place, or even the best one, the first place. It shows that in the internal properties of the model, there is some very important and useful information that you can see in this manner to understand whether the model hallucinates or not. And these are not all aspects of hallucination, because hallucination is a very wide term that has many different options to understand. I mean, if we want to understand if hallucination really happened, we need to look at different statistics. To wrap up, I would like to also say that the topological characteristics can, in a non-trivial manner, understand whether the text was generated or not. There are many different statistics that correlate very well with the quality of the text, and the topological dimension that we calculate based on these graphs can help us determine on the various languages in unsupervised learning method the fact that the text was generated, or maybe it was written in natural language. The dimension of generated text is smaller. And the interesting fact is that in Chinese language has a topological dimension that is smaller than other language. So, in conclusion, I would say that all that strongly correlates with quantization, because we obviously want the LLMs to be lightweight. And the empirical fact is that if you quantize LM, so basically you replace weights with some, you add some random noise and replace it with some round figures, then if you do it like that, the alignment will not be removed. So the safety of an LM will go down, but it'll still be pretty safe. If you start fine-tuning after that, on the orange you see some accuracy graphs, and it will go down dramatically. You will need a special fine-tune to make sure that this alignment is here, that it's safe. The safety topic is not really philosophical, but we need to understand how we measure it. In what situation do we do that? Another important empirical example, obliterated, is a LM, Llama, without alignment. So it answers your questions. So it answers the non-safe questions with non-safe answers. So it's not controlled. And there is this model with removed alignment. And we have a P16 model that is quantized. If you ask a model
to what extent the answer is safe or not, the quantized model, as well as the model without alignment, will answer with a pretty good precision. Even if alignment is removed, a model understands pretty well that it gives an unsafe information, unsafe answer. However, if you assess what it generates, then the quality of the generation is going to be the following. The model without alignment will generate mostly unsafe text. So if you take a quantized model, that overall, I mean, I have said that the quantized model, for them, the alignment goes down, and if you ask it some pretty serious questions and debatable questions from the selection, the quantized model will still be aligned. Yet, if you ask these questions to the model with the removed alignment, the situation will be very bad. So we took a data set and removed the questions that were not that controversial. I mean, not all questions were that controversial, but still. The experiment shows that the models can understand that they're given in the dangerous response. At the same time, when you assess the quality of the answer, of the response, I mean, it is not in line with the quality assessment. So, alignment-free model understands that it says something wrong, but it's the same as it generates. So, the most important thing is that when you check the alignment, the safety, you need to put the benchmarks correctly. So today, based on our research, have highlighted how these notions are related to each other and what statistics from various properties of the matrices of attention can be used to detect hallucinations properly, to detect some errors, and the reasoning chains, whether they're good or bad. That's it. Colleagues, any questions? Yevgeny Burnaev, a round of applause. Yevgeny, thank you very much. Your contribution to science is invaluable. Okay. Yevgeny Burnaev, a round of applause again. Teaching a car to react correctly means showing it everything that can happen. World modeling generates these cases, and the system learns to self-correct. Our next speaker, Associate Professor of Westlake University, Kai-Chen Yui, with the report, The Generation of the Data Flywheel Concept Through World Modeling for Self-Correcting Autonomous Driving.
Thank you very much. So it's been a great honor to be here. Okay, so today I will present some of our lab's previous work actually regarding self-driving. So I was told that most of here people know about at least machine learning or something, but after this couple of days, I find maybe it's a little better for me to explain, let's say, to take a deep dive to what is self-driving and what are we working on, at least for this directions. Okay, so we give a topic of outlook on next generation generative autonomous closed-loop data flywheel, and I will basically explain line by line what they are and why this is very important to this self-driving community. So a little bit introduction. I mean, this is the outline of my introduction, my presentation, and a little bit introduction of myself. So I did spend some time in Europe before I go back to China. So I studied in Switzerland for my PhD. Before that, I go to Hong Kong University for my bachelor. And after that, I thought it might be interesting to see the opportunities across the world. So I do get some offers from some top-tier United States companies and also maybe some UK companies. And then the time when I make a decision, it's the COVID time. So basically, I then find maybe it's better. I mean, it's both way, right? The first thing is I thought going to China is very interesting to me. Even for me, I born in China, but I literally, like after my high school, I didn't spend time there to actually work for a while. And then I find maybe this is a good time. So after I spend half a year in the US tech company, and then I go back to Alibaba. And then there, I begin my research in autonomous driving industry, actually. So this is rarely known. Alibaba is also doing self-driving for logistics. Actually, it's very similar to the Navi.io, I think, company downstairs. So after a few years in Alibaba, I go to Westlake University for my continue to working on this industry. So essentially, there's a couple of things. I'm also average here at CVPR and also iClear. So to work on this industry a little bit more, and also I got some scholarship from Qualcomm company to support my research. Essentially, let's dive into the topic. So what we are actually working on is self-driving. And why self-driving is important, this is kind of like, many people know this, right? Self-driving sometimes can save people's efforts when you're trying to drive. And I'm not sure if any one of you have ever tried self-driving technology, but as personally, when I first time try a self-driving car, and I find even though they are, they fail sometimes, they cannot be, they cannot be really called fully self-driving up to now. But still, when I take my car in the highway, I try to use this technology, and then it actually saves a tremendous amount of time when I, for example, drive from Shanghai to Beijing, for example. It's over 1,000 kilometers, and it's very boring, right? It's on the highway, and people just keep driving. But with this self-driving on, actually, I don't need to pay that much attention to put my foot on the pedal. Instead, I just watch on the road. I just watch what happens on the road, and if there's nothing happens, there is a very good weather, and it's not chaotic. I find it's very interesting and easy to drive after using this technology. But what's the problem of this tech? So essentially, I'm showing on the screen a traditional development mode of self-driving. So first of all, we need to do, we actually working on this, we call this long-tail data scarcity in data-driven machine learning because this is actually true for any machine learning algorithms, even including the large language models. People keep talking about they have the problem of hallucination, right? But hallucination is actually one representation of they are lacking sufficient data to train this algorithm. So essentially in this case, a traditional development strategy is like the following. People firstly collect kind of like data for the machine learning to be trained. And then people trying to annotate the data. Essentially the annotation part is how people can try to teach a computer understand what we want. So this is very important. Second step is called annotation. The third step is, of course, you heard of this everywhere, right? People are trying to buy the high computational cars to train the algorithm. The process of training is very important. And then, before you actually give out the algorithm developed by, for example, some company to every user, we need to test it. So this formula is kind of like a closed loop, and this is also unanimously true across different industry. But in autonomous driving, this is what we can see. Okay, so instead of these three steps, they actually have pretty different difficulties. First is it's kind of like difficult to train the algorithm after you get some really simple baseline models to work. How do you make a better model? Especially when you have many new collecting data every day, right? Because if you have, for example, 1 million cars on the road like Tesla did, and then you have actually collecting data every day. And how do you make this data work? And the second thing is, how do you afford a high kind of like efficient data annotation to teach the algorithms? This is also very important, right? Because manually doing them is very expensive. People can spend like minutes to only labeling one 3D box, for example, a 3D location of a car. This is not easy, actually. Even for a human being, for us, if you are not specifically trained for it, it might take even half an hour to provide a very fine-grained labeling for one. And also, when you're trying to train, this is even harder. First of all, because the cars are very expensive. they are pretty expensive because everyone is trying to use it. So this cost is tremendous. And also you need to maintain this every time when you have new data. So this is also what we call the training algorithm. And the finally is simulation is also very hard. Because you know that this autonomous driving, on the good hand, is it can save people's effort. On the other hand, it can kill people, right? If you're doing this incorrectly, and actually can kill someone who are driving normally. So there are a couple of accidents happens across the world. I'm not going to mention it, but this actually, emphasize how important it is we should treat this technology. So essentially, to solve the problem, we actually, as me or the lab, in the last few years, we are tackling the three major parts in three aspects. The first one is we're trying to find a good way, try to train the algorithm with less efforts, at least less human efforts. The second thing is we are trying to make use of the largely collected data and try to find a way automatically to give a label to them. And especially when you have LiDAR sensor and also the camera sensors. Another one is we're trying to deal with the really long-tail data scarcity problem, which means that this scenarios is something you never see, but still we are managed to make some new cases out of the old stories, okay? So essentially we are trying to solve this problem in three aspects. And essentially, the lab's research can be summarized in this following figure. Okay, so basically we cover, except for now, the development and testing. We try to solve the problem with hybrid training algorithm, assign the automatic annotations, especially with multi-sensor. When you have multi-sensors, you will have alignment issues, and that's a big problem when you have different sensors. Okay, and then we are trying to solve the problem from the beginning. If you are not even able to collect such data, how do you deal with it? So essentially, the first line of research we're trying to do is we called neural architecture search. So neural architecture search is something in this domain trying to solve a problem of how to design an algorithm. So this is very similar to Professor Tian Ye's talk. Okay, so he's trying to make AI automatically design AI, and this happened to be my PhD research. So this is what the first thing we're trying to do. So essentially, the motivation is pretty simple as well. So instead of trying to train the algorithm, design the algorithm by, let's say, hiring a very knowledgeable machine learning engineer, instead, we can try to formulate certain rules and algorithms to make it work. So the first thing, but the problem is, when we did this research in like 2020, around 2020, and we find that the most state-of-the-art research on the world is no better than a random search, which is the simplest thing you can even think of, right? Just rolling a dice. That's the if you compare to the algorithm back then, so finding a good algorithm is similar as running a dice. This sounds not very good, right? So essentially, in this research, we try to do two things. The first thing is we identify this problem, especially with a careful design framework. And the second thing is we propose an anchor-constrained neural architecture search strategy to solve the problem. So essentially, we improve this algorithm's performance by 5%, and also when we try to deploy this technology inside Alibaba's internal product, we actually gave a boost of 97% of the performance, especially when you interact with the algorithms. So essentially, actually, this is funny thing is when we present these results to LeCun, and when the LeCun is not a Turing Award winner back then, and actually he thought it's pretty interesting. And also with these achievements, we also get the acknowledgement of the Qualcomm Innovation Fellowship in Europe. And then the more interesting thing is when we deploy this algorithm inside Alibaba, we actually find it, before we try to train an algorithm, there are, roughly speaking, 150 steps an engineer should follow through the process. It lasts over 3 months. And after we do this, and actually we find a way, most of them are engineering work, of course, but they cannot survive without the scientific inspect inside. But after we develop this, and people only take 7 steps to finish the retraining of one algorithm, and which is very important to the efficiency of a company. So the second thing is, when you try to, the first rationale is, when you have the same amount of the data, you want to squeeze the most of the algorithm. But after you have it, how do you solve the problem of we have many unlabeled data. How do we deal with this unlabeled data? So this is essentially, we are giving a summarization of this data, are widely collected unlabeled data, and how we can make use of it. And we can make use of it with two ways. Maybe some of you, if you are familiar with machine learning, there is a way of semi-supervised or unsupervised learning, which you don't really need a label. But essentially, when you look back in the industry, even for the large language models training or for the 3D scene training, the labels are the most important thing to the world. That's why people have, for example, Scale.ai, that's a very big company, only targeting for this, what we call data annotations, right? So essentially, this is important, but what's the problem we are facing? The problem is Tesla already built an auto-labeling system, which is very good, working very well. However, this is not the case that when you have multiple sensors installed on your vehicle. For example, I mean, of course, this is a debate. There is always a debate that pure vision versus multiple sensors, but at least when there is no one trying to say that when you have LiDAR, you have disadvantages, because the LiDAR is what we call proactive sensing, right? You are shooting out the laser to a point, to the objects, so that even though the camera doesn't work, camera is passive, taking inside the light signals, right? So these two signals, they are quite different in principle. So at least doing this is important. This is what we have a consensus inside Alibaba. So in this case, we find out actually there is a problem when we do this in real life. First of all, when the time 2022, when we are trying to develop these algorithms, every algorithm running on Earth, for example, trying to do this fusion algorithm is always starting from a LiDAR point. Either you take the LiDAR point, do some kind of projection to your camera, get some features from the camera space, and then merge it together, or they are just trying to use a transformer, trying to correlate some camera features to the LiDAR point. Doing this is fine when you have a perfect sensing. If you have, for example, 360 degrees LiDAR points, that's very good because you have every corner covered by the camera and also by the LiDAR. However, most of the cars, as you might see some cars in the current, the road on the road now, they only have a forward sensing LiDAR with a round, with everything else is camera sensor. How do you deal with this? We find out that back to 2022, the algorithm trying to do the sensor fusion failed miserably if you don't have a LiDAR point. So in this case, we develop a new algorithm. So first of all, we identify this problem. And the second thing is we develop a very simple but effective algorithm called BV Fusion. And BV Fusion just changed the problem by separating. Okay? We separate the LiDAR feature extraction and also the camera feature extraction so to achieve a point that both sensor fusion actually helps each other rather than decreasing the performance of each other. So in this case, we actually find out that by doing the simple thing, we improve magically the performance over 127 from, I think, around 5% to something 30 to 40% accuracy, if I can say so. They have a specific name, but accuracy is good to capture it. So by doing this, we also notice another interesting thing is we should not use actually depths to measure the distance when we talk about autonomous driving. Because depths can vary, right? If you, for example, predict a depth of a car that is 2 meters away from you versus predicting a car's distance over 140 meters from you, the difference between 2 meters and 3 meters appears pretty big if you care more about the local density. However, because if you know that when you are changing a very small angle from the very short distance to a long distance, if you change the angle of the prediction by 1 degree, if you are at 140 meters long, maybe the difference is like 20 to 30 meters away. So this is pretty bad. We actually discovered this. There is more efficient algorithm for let's say feature extraction by doing the height. Instead of using depths, we should measure the distance between the point to the car versus to the ground. Because every car on the road is only 2 to 3 meters high. So essentially, by doing this, we improve the robustness by a large margin, and this seems to be very effective, especially when you put the cameras on the truck, for example, especially maybe even higher on the road camera. This works even better. So essentially, with this technology, we also try to solve the problem of the robustness. And by doing so, essentially both algorithms, no matter BEV Fusion and BEV Height, are officially included in NVIDIA's official repo for the autonomous driving. And also, we think this is a pretty big acknowledgement as NVIDIA is trying to provide the most efficient algorithm to the world. And also, when we deploy this algorithm, the auto-labeling system inside Alibaba, we find that actually the 3 annotation fees for a box reduce from 1.4 RMB to only 0.13 RMB, which is over 90%, saving tens of millions actually RMB for the annotation budget internally. So this is a pretty important aspects of the advance in this field. And also BEV Fusion now is also quite, this is pretty safe to say that everyone is using BEV Fusion if you are trying to deal with LiDAR and camera for the same time. So essentially we find out 2 things, right? The first thing is if you have the fixed amount of data, try to get a better model. The second thing is if you have the way to annotate more data, the performance is always going better. But what happens realistically, actually, so after the 2 steps, this is only the beginner lessons of autonomous driving because everyone can do it. However, after the 3rd step, this is really enter a corner. What do you mean by corner? The corner just means that the case you've seen is rarely happening. For example, there is even an extreme case that one autonomous driving vehicles recorded a plane landing on the US highway. So this is something you might never imagine in your life, right? A plane just landed in front of you. I mean, as a human being, we know what a plane is, and this is very dangerous. We shouldn't crash on it. But for a machine learning system, if it's the first time seeing this scenario, it's very likely that they will not understand and just crash it. So essentially, the point is, how do we make such case even better to try to do the data balancing issue? Another thing is, as I mentioned, this corner cases rarely happens. They only happen probably 1 over a million times. However, if you know about the machine learning training algorithm, there is a phenomenon called, let's say, data balancing issue. What is data balancing? Balancing means that if you throw one case into a million, for example, normal cases, it is very unlikely the machine learning algorithm will remember the one case you throw to the system. It's like you throw a stone to the Pacific Ocean, right? There will nothing will happen. So in this case, if we cannot find the sufficient way to enlarge this data portion, for example, at least to maybe 10 to 100, I mean, there is likely to be no chance that you're training the algorithm, you alter the algorithm by only one case. So this is the 3rd thing we noticed inside the company and also move to the university trying to do is when you don't have much collected data, try to make them. So essentially, the rationale behind this data algorithm is what we call the neural field. Okay, so this is a special term, implicit neural fields. So let me just briefly explain this. Before people have this technology, what people are trying to do, they are making a game. So, I mean, even inside autonomous driving, this is not a joke. Even inside autonomous company, people, when you try to make 3D data, the best way is you construct a similar environment like a game. Maybe some Unreal Engine, maybe something else. You do a 3D simulation. You buy or create some assets, like a car, like a pedestrian, you stack into that simulated 3D world, and you using the simulated 3D world to solve your data generation problem. But actually the pain is the 3D world drastically differs than the real world captured by a camera. There are many, many things. I'm not going to go over them one by one, but there are many things that are different so that there is always a big gap. But implicit random neural field actually solve the problem by providing a different solution. They are trying to use the real data, train a machine learning algorithm, predicts what's the underlying features embedded in a camera, rather than using a fixed parameterized 3D camera model like in a 3D engine. So in this case, people discover that actually we can try to really generate high fidelity sensor simulation by doing this. But the problem is people only do this for camera. There's no one doing this for radar, okay? So for the LiDAR or even radar. So this is our work. We are one of the 3 groups actually in the world develop this 3D LiDAR rendering by using implicit field, and also we generalize this to a double fidelity. We're doing this for LiDAR and for camera at the same time. And again, the alignment is an issue. So when we do this, the merging, the fusion work, actually people finds out, the different modality hurts each other. You only find algorithm on the world maybe make LiDAR better, but the camera worse, or vice versa. This is not very good, at least to us. So essentially, we try to solve the problem by generating this in the new algorithm, and we managed to, for the first time, actually make both modality improve in the same implicit field, in the same 3D representation. And also with the same core technology, we moved it to diffusion fields and trying to do a generative work. And this work actually wins the ECCV challenge for the first place and in the previous time. And also, this technology underlying, we partnered this with Li Auto. Maybe Li Auto is pretty famous in Russia. I see many of them in here. It's also very famous in China. And we actually do partner with them to trying to serve their serve in their data engine realistically in their industry, try to solve the corner case problem. So essentially, up to now, we actually finished this. We tackled the problem of closed loop data flywheel to solve this long tail problem in 3 aspects. Firstly, we deal with when you have the same amount of data, but try to squeeze the best from the model. The second thing is we try to do auto-labeling. The third thing is we are making some new data to solve some rarely seen cases so that people can, being protected from the autonomous driving technology, I would say. So, but what's next? So next is generative world modeling. So this world modeling is very, very popular recently, especially by Feifei Li. Okay, so Feifei Li is advertising this concept a lot in the US, and also there are a couple of counterparts. But I'm going to provide a little bit, perspective from my side why this is important, especially in the autonomous driving industry. So as I mentioned, we mentioned over 4 in the first part of the presentation, right? We mentioned about how to train, how to make more, annotate more data, and how to make some new data out of nowhere. But we didn't mention the last part, which is testing. And testing is very difficult to do. Traditionally speaking, I'm not sure if you're not in this industry, you might not know, but when we work in the industry, we actually need, when you're trying to do some real testing, you need to actually, for example, find a highway that no one is not a very popular highway, and then you pay a large money to rent this highway. You block the highway for example, 1 or 2 days for like $500,000 in China, and then you drive your cars there. Try to find the realistic testing for your vehicle if you are not familiar with some cases, right? This is the ground truth we call. This is the truth we can rely on because everything is the same, right? You have the same road, you have the same car, and you have some audience, you have some model cars that your employee is driving to run around to simulate some dangerous situations. And this is real, but this is very costly. I remember the days when we do this. Actually, I'm part of the fleet. I'm trying to drive a car, cutting the truck. First of all, this is very dangerous, even for me, for the company's employee, right? And the second thing is this is very inefficient. But the problem is, if you have no better ways to test your algorithms, how do you do? You can only do this, right? And the second thing is we can only try to test a very tiny fraction of the rules we have, but these materials are coming from Chinese traffic laws, but I assume everyone on the earth have a very complex traffic and also comprehensive traffic rules. And essentially, how do you test each rules one by one in the realistic scenarios? Literally, there's no way, right? Otherwise, if you are a car company of autonomous driving that have 1 million cars on the road, maybe you by luck running all of the cases. But still, what happens if rules are trying to stack to each other? And the second thing is the traditional third-party simulation is very easy to hack. As I mentioned earlier, right? This is a very simple case that you can hire a road or build a simulation, for example, play yard for the autonomous driving vehicles. However, machine learning is, doing the best thing machine learning can do is memorizing. And if you have only one play yard, it's maybe for the first time it will fail, but after a couple of seconds, it will just succeed without problems. So essentially, this is the problem we're facing, right? How do we trying to solve the testing problem by doing this? So essentially, this is one video I recorded on my own car in China, and you can see this is a pretty complex junction road, and then we have, maybe this is not in Russia, but in China we have this dash lines, which when you are waiting the red light for very large junctions, you can move ahead instead of waiting behind, okay, just to make it more efficient. And there is actually a policeman there trying to coordinate everything, and there are a bunch, many, let's say, cycler trying to ride this little bike, and also you have many words on the screen. You can see that there is a road sign. There is also road signs with words. This is also very common. But how autonomous driving system understand the composition of everything? So this is essentially the complex road structure, complex interactions, and also traditional this testing block is just insufficient to solve these combinatorial problems. So essentially, this is also why we see the industry have a development of the autonomous driving technology from the rule-based. In the beginning, I mean, 2012, for example, people are trying to use the rule-driven approaches. For example, if you see a red light, stop, something like this. This is very simple, yet works. But it doesn't work when it's getting pretty complex. People gradually move from this rule-driven to what we call divide and conquer-driven, and then gradually to this end-to-end, which you actually put all the data to the same model, trying to learn. And now we even have this what we call the vision language action. This is another version of a large language model. Instead of trying to put the language, you also put images and also actions into this model, okay? So this is a counterpart of language models, and then some new technology maybe in the future. But the process of doing this, upgrade is not for fanciness. It's more like because the number of the scenarios you are dealing is getting more and more complex, trying to use traditional approaches to solve the problem is going to be impossible. So what happens is now is we might encounter some cases that are written in the traffic rules, but you never collect it on the road. How do you do? So essentially, our solution is we are trying to use a generative data model, try to serve as the traditional, because traditionally speaking, there are many research in the world, especially in the transportation side. They work on how to decipher a traffic rule. They work on how to generate some traffic rules, traffic scenarios. But if I may say so, they are just little blocks on the screen, okay? So if you have a car here, instead of you really see the car, you said, okay, this is a block. So this is what people have tried to do before. And what people are trying to do now, especially for this, what we call end-to-end, or this recently, if you see Tesla, if you see Li Auto, everyone is not doing this little block by block. It's more or less, you just see the driving scenarios, and then they predict the results. But this is insufficient there is a gap between these two, and the generative model modeling is just the middle part, the middle layer, trying to solve the problem. So essentially, in essence, we're trying to generate a new scene to solve the issue by doing the generative modeling. And these are a couple of examples we can see. So everything here are purely generated. So nothing is really filmed from the road, okay? So you can see that it looks pretty same as what you can see. And this is, we use this as a case because it's a wide region, it's a large chaining, and on a very wide junction road, so to see the performance. And also we can provide this kind of like control. We can try to draw this road, and this is also a demo case. You can draw the road freely, and then you can render a scene correspondingly with the very accurate 3D aspects. And more importantly is we use these two technology, combining them to build a self-correcting autonomous driving algorithm system. So this is what we call self-correcting self-driving system. And here, actually, this paper is recently admitted by this IIII, which is one top-tier conference across the world for AI. And we actually managed to drop 39% of the failure cases automatically by generating some new cases. This basically evidenced the effectiveness of this approach. And also, more interestingly, in the future, and this is something ongoing, we are trying to do generating a more complex roads, for example, different traffic signs, different kind of junction roads. I mean, these are all in China. Maybe you don't see them, but you can see that there are little big cross on the road. This is just to indicate this is a dangerous area, for example, and also control the traffic lights. So this is basically in essence, we try to make the world model know more about the rules, okay? And the second thing is we are trying to unify the generation and understanding, because generation understanding is a very interesting topic nowadays. As our group always do, we are trying to unify these two basically different approaches into one, so that in the future we can be more efficient, and also generation also being helped by understanding problem. Another one is we also try to design a more interesting end-to-end driving algorithms with the previous research foundations. And essentially, this also can be used as a reward for reinforcement learning, which is also very important. If you notice in this field, people basically are running the vision language action models with the reinforcement learning to help it being better, to be more, human-like, for example, in this field. So essentially, we are also capable of doing this. And essentially, we are trying to do the same thing again for the humanoid as well, because everything in the humanoid is quite similar as the self-driving. I mean, in China, we have a saying that embodied AI, but embodied AI actually is a very broad definition, and it covers humanoid, it covers tripod, it also covers autonomous driving for navigation problems, right? So essentially, we also try the same thing and also works on the humanoid, at least. We observe a roughly 40 to 50% rate of succession just by generating some new data without any hurt. So essentially, we basically just concludes of what my research is, and I'm just use last couple of minutes to introduce our university. So first of all, we want to thank all the industry supporters and also academic supporters of our lab. We have many collaborations, especially with Xiaomi, with Li Auto, and this is some companies in China which are working specifically for autonomous driving. And also, the university is here, so it's a newly founded university which are specifically for research, and we are pretty proud to say that they actually are very unique, even in China or across the world. So we try to be more international. So if you have anything, you can try to reach out to me. And also, to be summarized, we just trying to deal with the autonomous driving problem, the corner cases problem, gradually. Firstly, by training more model efficiently. Second is labeling this unlabeled data. Third is trying to make some new scene based on original existing ones. And lastly is trying to create the scenes that you never seen even in the training data by doing the composition. Okay, so this is what we do. And last but not least, we want to thank the team, and also we are hiring. So if you have anyone who are interested in us, please consider joining us. Okay, so that would be all. Thank you very much.
Thank you, Professor Kai-Chen Yu. Thank you for sharing your experience with us. Enjoy Russia, enjoy Moscow, enjoy the conference.
Thank you.
Thank you.
And we're moving on. From model to movement, we have only one step, but it is the most difficult step to make. Embodied AI, where sensors, maps, and decisions converge into a trajectory about the practices and errors of the real world, is going to be discussed by our next speaker, the head of the Mobile Robotics Lab at Skoltech, Gonzalo Ferrer Minguez, with the report Embodied AI.
Okay. Thanks everyone for having me, and I will try to present slides. So the question is, what is robotics doing in the AI era? Okay, so today there have been very good speakers talking about different variants of AI, right? So autonomous driving, natural language processing. So I will discuss from the perspective of my lab, right? And we work on robotics. So first of all, as introduction, the lab is a mobile robotics lab. Okay, so we have PhD students, master students, researchers. This is a picture of us, right? We have several robots, and this is a university group, research group, okay? So, well, basically we have limited resources. What are the topics that we are interested in studying? So, SLAM, planning, sensor calibration. Today I'm going to talk mostly about planning, okay? What can we do for navigating robots? And there's also some courses that are related to these topics that are perception in robotics, explaining all these problems about SLAM. And the second one is planning algorithms, right? Which is happening right now. Okay, so this is the summary in one slide of what are our research projects going on. Okay, so the main goal is to make robots navigate in the real world. Okay, so we want to go outside the lab because the real world is very rich. There's very unique structures, objects that are not commonly found, and a lot of corner cases that are required for having true autonomy. Okay. We have some robot manipulation, like this one in the image. Okay, this is also like mounted in a wheel platform, and we also have we also are interested in studying wheel robotic platforms. Okay, so let's do a little comparison with other AI fields. Okay, so for instance, natural language processing on computer vision, they had tremendous success. Okay, we have all seen like some of these models being developed and really advancing very quickly. Okay, so I'm gonna compare later with robotics. So all of them have in common like this approach. There was like pre-2010, okay, before the deep learning era. And after this, there was like rapid succession of network architectures, and there was more and more data available. Okay, and we see how the path actually bring great success to both of these topics. So just to have an idea of what the magnitude of this data we are talking about. So for instance, for images in 2011, I think, appeared ImageNet. It was revolution for computer vision. There were other data sets appearing later. But the amount of data we are talking went from millions now to trillions, right? So trillions of data that, for instance, Llama 2 is using, or other NLP models out there. So, this data is available. It's obtained in the internet. Either text, either like images, you need to mine them, but basically the effort was on obtaining them. After you get this, then with enough computational resources and a team of people working on getting all these models trained properly, we see like these tremendous success cases like image generation, segmentation, like this is scene understanding. We also have like many families now of chats, like really being capable of providing solid answers. And well, this is kind of summary that I think has got to most, to many people already, right? To most of the population. This is outside research now. It's kind of being deployed. So I think almost majority of people have access one way or another, one of these large models. So the question is, how is this road of success looks for robotics? So there's great cases of success, okay, but still it's not really taking off as as quickly as maybe the other disciplines, right, are doing. So let's analyze this a little bit. We also start with classical methods, and I'm going to discuss what these classical methods mean, okay, because we start with these representations already. So everything has inertia, right? It comes from story. And then there's the same network architectures that are available for everyone, okay? All fields could be using them. And then there's this question about massive data, okay? So what this massive data means, robots can generate a lot of data, but this is not useful always, right? Or not exactly like that. And then what we see is that although there's cases of success, this growth has not been as spectacular as in other fields. Okay, so this is just like criticism. It's not really like pessimism. Okay, I'm really optimist on success and road ahead in robotics, but I'm just bringing here a little bit of discussion, right, on current state and comparing with other fields. So the classical methods for robotics start with paradigm that is very strict. Okay, so let me explain about this. Most of these applications rely on a representation that is an accurate map. Okay. So after you have this accurate map, it could be like equivalent to the blueprints of a building. Okay, you have walls, you have all these spaces. From this, you can start like defining robotic tasks, like go to places and other similar things. Okay, this approach requires high precision sensors like LiDARs and a little bit more expensive sensors, okay? So with this, you create high quality map, then you are able to kind of also update it and localize in this map. And the problem is when this map representation fails, all this approach is not so useful, okay? So that's why I'm discussing that maybe this representation is very strict, is not as flexible, and this is the initial point, okay? So from here, there's many problems that come, because now the new paradigm that we are discussing is data-driven, okay? So somehow we cannot really take away all these classical algorithms, but we need to build on the more powerful algorithms that are all the machine learning and the AI are giving us, okay? So on the network architectures, I think there's not much to discuss. They have proven to be very effective, so it's just a problem of how to train them properly. And for this, well, you have like ways of training, but also the most important part is the data, okay? And this is this question that we are raising now. What is this equivalent to massive data? So internet scale, right? Like all images in internet, all text available, all these kind of things. What is the equivalent of this for robotics? Okay, so the problem is there are several ways of obtaining data, okay? We have seen examples, but it's not exactly the same kind of data. And this is what is making this problem more complicated for the field. So if you imagine a task that requires manipulation, holding an object in your hand, it's very complex, okay? So this is structured over time, okay? There is physical interaction, there is cause effect. If you think about it in text, okay, in text, there will be a sentence saying that a person is holding an object. Okay, so there all these kind of complexities are disappearing. This is just a representation, right? Language is representation. So the data is simply more complex and we need to deal with this. We need to find ways of dealing with this. It's also more expensive to acquire. So imagine someone here like providing examples on how the robot should be manipulating, how it should be moving around. Acquiring these examples in the real world is expensive, so this is another problem. And basically also the complexity is very high. Environments have a lot of elements. You cannot know for sure if all elements are important or only some of them. You cannot discard any of these, right? So this basically means that representations are important. Remember what we had before for the classical approach is maps, high quality maps, and from here we build stuff. So in these maps, we have like static objects, walls, and these kind of other objects that are represented there. So if we go away from this paradigm and we just have like data, and from this data we train algorithms, then understanding these scenes becomes very complicated. Okay, so it's also a problem of representation. So, well, we can discuss on this, but too simple, which is what we had before, what you have is limited results. Too complicated, then there is no interpretability, and you can even fail on understanding and executing tasks. Okay, so there must be some balance here. Okay, and then the question, and this is the discussion I want to bring to you, right? So what can we do? What can robotics do? I mean, we hope to get like great success on our research, developing new models, but we see that there are some limitations, right? So one of the main things of the success was the amount of data, okay, collected. And for this, we can do several things, okay? So we could produce these examples from robots and then just generate enough data to train algorithms, similar as it was done before. This is realistic, but very expensive, okay? So this is always something that people try to avoid, if not done properly, okay? Second is we should be using augmentations properly, and by augmentations means like maybe changing objects, maybe changing little things on the scene that are enough to provide variability on the data that we are going to be used for training. There's the whole different approach, which is simulation. Okay, let's simulate environments, and here there has been massive progress also. Every time models are more realistic, images generated are undistinguishable from real images, right? So it's getting really great, but still there is a gap, okay? So simulation is not the only thing. And then there's also a very interesting approach, which is you could be mining videos from the internet and solve the domain gap, let's say from seeing some people doing manipulation or some task, transferring this problem to robots, okay? So there are some differences. This is what we call like this gap, okay? But if you can solve this, you can use like a tremendous amount of data that has been recorded in films, in videos, etc., etc. Okay, so then a proposal, this is just a view, is that just to make this path robust and solid, to continue progressing, we need to go back a little bit. So we need to create like ways to generate more data, and not just more data, but also data that are quality data, okay? So we also need better representations, and this means that we might have to develop new algorithms that might be fundamental algorithms. We will be using all the network architectures that are there, and with this kind of new data, progress should be, progress in what capabilities are for robots should improve. Okay, so let's look a little bit on some of the things we are doing in the lab now. So this was more like general discussion. I think it's important, right? Because this is the time we are living. Many of the speakers today were discussing about data as one of very important things, not just for robotics, but in general. So some of the things we could be doing is, let's record data, but it must be high quality. What does it mean, high quality? It should have annotations, maybe trajectories, maybe semantics, traversability if you're a robot that wants to understand how to move in the world, and these things. So, for instance, this was an effort that we did recently. So this is the EgoWalk dataset. We were providing a lot of examples of walking examples in the region of Moscow, and we were using this for training our model, okay? We were including all these other extra annotations because imagine you just have a video of someone walking, okay, fine, you understand that things are going on, but maybe you require more data than that, okay? Maybe you need the context, maybe you need like annotations of what is going on, maybe you want to annotate when you have collisions. All these things is what I'm discussing about high quality data. Okay, so in the EgoWalk dataset, we were comparing with others. Of course, this is an approach that people are taking in other places. At the end, some of these models are trained in jointly. So they take data sets from everywhere, they put this together, and this ensures more variability. So our data set was composed of scenes, indoor, outdoor, annotations, everything. This is examples of where we were recording here. So we have parks, indoors, museums, night, day, different times of the year. This actually matters when we are recording, when we want to gather as much diverse data as possible, okay? And well, you see the kind of environments that were considered here. And this is distribution of the times of the year and maybe the kind of regions that we were exploring, okay? So quality data also means that it needs to be diverse. If I collect like 100 hours in the same environment, it's not going to help us at all. Okay, so this was the acquisition platform. Here, well, we also did development. So this is other part of things we need to do in the lab. This is system integration, okay? In this case, working with sensors and with recording platform. And well, this is like some of the other augmentations, in this case, traversability, just looking at more lightweight algorithms that later can navigate in environments. Okay, also like thinking about this idea about efficiency, there is like this whole question about knowledge graphs. Okay, this is very important topic in retrieval. Okay, just for text, but it can also be used for us in robots. And this is a way to represent the scenes. Okay, so we are going to have now a bunch of objects in the scene, and we are going to have places represented only as images. So this is a substitution of this high-quality map that I was talking before. There is relation between objects. Okay, so chairs are on the floor. Maybe chair is standing next to a table, or a door is open or closed. Okay, there's relations there that need to be considered when we do navigation. So in this case, we were proposing how to create like this scene representation. Okay, we were collecting videos, breaking it into chunks, creating graphs, and this graph is actually holding all the important information in the scene. All objects that are segmented, and we also look for consistency of objects. Okay, and you need to think about it as open vocabulary graph representation, where maybe an object is detected here as a chair, and then a little bit later is detected as blue chair. Okay, but they are the same object, so we need to unify this. And after creating a graph, we are capable of doing simple tasks. Okay, so the task could be like find me a printer or navigate me to the exit. Okay, well, basically this is the idea also, how we are constructing the graph. Okay, and at the end, yes, this is the important thing. We want to preserve identity of objects. So it's not just the objects, but it's also the places and the objects, right? So all these nodes live in the same graph. Okay, so navigation query will look like this. We just find like a task, and the most relevant things are just search over it. Okay, let me find maybe like this example will be better. So we are asking here how to get to where to put our code. Okay, so in this case, we look at the graph, and it's telling us in which frame. Frame here is like what picture is that the most relevant that gives you the information. So in this case, it's successfully giving you this information, looking for a printer, asking questions about the scenes, and these kind of things. Okay, so after we have this, we can have actually robot living in this kind of environment and having like very rich set of tasks that are just every time check with the with this scene representation. Okay, well, I think I'm running a little bit out of time, so let me go fast on this. We definitely think this is good representation for us. This is on top of the data that we were collecting. Another project that is going on is, I didn't talk about this until now, but manipulation. So it's very similar kind of robots, okay? They have more degrees of freedom. But this problem is also like how we are giving data. So there is a manipulator, volunteer that moves the robot, and the robot then takes what the arm is doing on the volunteer, it's exactly replicated on the robot. Okay, so that's how we are manipulating these robots. And with this, we can collect data. And then the question is what kind of augmentations we could be doing, okay? So these two images are from the same scene, but if you see, they are a little bit different, right? So the chair is different, the robot below is different, the table is different. This is just like augmentations we do with computer vision, okay? So this is just to have a little bit more variability. Okay, so, well, that was like very fast, but just to say, look, there's different robots, but at the end, all of them have the same problems. So in this case, this data is more complex, okay, either for manipulation or for walking around, it's more complex. We need to deal with this. At the same time, this is an opportunity, right, because we still need to understand what is a data, okay? For other disciplines, data might be a label. It's a cat, it's a dog, or maybe a sentence, right? You can remove parts of this and it's fine. Maybe for a robot, data sample, removing parts is not an option because then you are missing crucial information. So this quality data, okay, we need more augmentations, more modalities, the more we can get because still the data is so complex that we need here still better ways of presenting it, okay? And we also think that representation of the environments is important. So this is a problem that cannot be solved with brute force. Okay, so better representations will give us algorithms that are a little bit more, I think, capable, just by less using less resources. Okay, so this is something that we should not lose. Okay, so. That's the presentation. Thank you so much. Yes.
Гонзало Ферrer-Мингес. Thank you, Professor.
Okay, goodbye.
Мы благодарим всех докладчиков.
We thank all of the keynote speakers, all of the participants. Today, science is showing what it's capable of. Fewer dogmas, more testable hypotheses. Over these 3 days, we now have gained a clearer understanding. Finances, regulations take the speed from AI, and science gives it depth and sustainability. Thank you for the frank conversation and the readiness to ride the wave with AI. We are going to learn about the authors of the best papers for AI Journey Scientific Journal, the winners of AIGA contest, and the more effective participants of AI Challenge. Very short break, just 5 minutes, and we resume here for the ceremonies, for the continuation.
Церемония награждения.
We are beginning the award ceremony for AI Journey Contest 2025 winners.
Мы начинаем награждение лучших исследователей.
We are ready to give out the awards for the best data researchers, the finalists of the 10th International Online AI Competition, AI Journey Contest. 10 years is a significant journey. 10 years is a powerful number. Over this time, participants solved 26 problems, and we have received over 14,000 registrations and more than 67,000 solutions. This is this powerful energy that led us to today's finals. Every year, participants propose cutting-edge AI solutions. They expand human capabilities, improve the quality of life, and optimize business processes for companies of any scale. And now we will find out the names of those whose projects were the best. Let's begin the award ceremony. To summarize the competition results, I invite to the stage Vice President, Director of the Department of AI and ML Technology Development at Sber, Maxim Yeremenko. Good evening, everyone. This is day 3, Science Day, and we began this day with a conversation with winners of the International Olympiad on AI and winners of AI contest, and we're going to see even more winners of AI Journey contest. We have people coming from different countries. I'm happy to see that some of them already started their own families. AI Journey goes on, and people start families. Thank you, Maxim. You know the right words to say. And now, let's learn about the first problem. Agent as Judge. This is where participants were supposed to create a judge model with the generative LLM agent capabilities in a fair and unbiased manner. To give out the award, I invite to the stage Director of AI Technology Development, Head of Division for Experimental ML Systems at Sber, Sergei Markov. Sergei, the floor is yours. Well, what can I say, guys? I remember the days when I myself participated in all kinds of competitions, and I made lots of friends there, people who we worked with side by side on many great projects. I remember this atmosphere of this incredible drive in our competition, but a very friendly competition where you are competing, but at the same time you're ready to help each other and share something about your own solutions. It's great to see many young faces, and it's great that this tradition lives on. I'd like to thank all the participants, all those who were involved in organizing these competitions, because it does take time, it takes effort. Thank you very much, everyone. I'm very happy to be standing here on the stage. And I wish everyone the best of luck, especially when it comes to creativity and future competitions. Thank you, Sergei. Shall we start with third place, bronze medal, who will receive the award of 600,000 rubles. Third place in the Agent as Judge category is taken by Dmitry Voinov. Dmitry, welcome to the stage for a photo op. And congratulations.
Ваше решение – сильный результат. Этот шквал аплодисментов.
A pretty good result. These applauses are for you. Moving on. silver, and 800,000 rubles. Second place in the Agent as Judge task goes to Mikhail Golubchik. A round of applause, please. Don't forget to smile to our photographer, so that next year you are motivated as well. A round of applause. Mikhail Golubchik. And now a special story. A story of dedication and commitment. This year, one of the participants sets a personal record, the 5th time on this stage, and today on his birthday, his anniversary actually, he is again among the best. Let's welcome the winner and the recipient of 1.1 million rubles. The first place in the Agent as Judge task goes to Amar Ali. Amar Ali, congratulations. Yeah, now it's a great time. You are pretty successful, not only in contests, but, you know, after work hours are fruitful as well. How many months? For the kids? 3 years and 1.5 months. Well, not bad. Congratulations. A couple of words about the contest. Amar, what was the most difficult part? The task was very interesting. Agent as Judge, you know, it was hard to understand the approach to train the model, you know, finding a new principle on how to assess LLMs, because right now there's no proper approach there, clear approach. It's early to say that it can be achieved, but, you know, gradually we will achieve it. Okay, congratulations, Amar Ali. Maxim, Sergey, next award. Giga Memory, Global Memory for LLM. The participants developed a long-term memory module for the GigaChat language model. Proceeding to awards, who will open up the top 3 winners and take home the check for 40,000 rubles. The third place in the Giga Memory, Global Memory for LLM task goes to Alexander Perevalov and Vladislav Raskoshinsky. Alexander is going on the stage, and another winner was not able to be here in person, but he is connecting through the video call. Vladislav, hello. Yes, hi. Why didn't you come? Okay, understood. Yeah, some problems with the connection. Yeah, that's the glitch in our metrics. Anyway, congrats. Yeah, Vladislav is thinking about the next contest of the next year. We wish you success in the future, Vladislav and Alexander. A round of applause. Raising the level, he will get the check for 700,000 rubles. The second place in the Giga Memory, Global Memory for LLM task goes to Denis Shustov. Denis Shustov, a round of applause. Don't forget to smile. So that these photos inspire us for many years to come and for new discoveries. And now, not only the renowned experts, but also a family team. Maybe you have guessed it. This family union inspires you for new discoveries, especially now when they brings the winners 900,000 rubles. First place in the Giga Memory, Global Memory for LLM task goes to Omar Ali and Vala Osman. Once again, congrats. Guys, you are very productive. A couple of words. Is Dad using the computer for a long time? I guess that's a yes. You have quite a potential. What, 4 big cells of memory? Yeah, Mart, talk about the task. Maybe your kids will help you. Yeah, well, the task was exciting. It was hard to train GigaChat since it's a big one and we don't have any, research capabilities. But, we tried together a couple of approaches and it worked. And about the next task. The third one? No, I didn't participate. Okay. Because you're taking all the places. Okay, anyway, congrats. Omar Ali and Vala Osma, big congratulations to you. Hope to see you on this stage next year. Probably your family will grow even larger. Sergey, thank you very much. The next challenge and the third task. Human-centered AI assistant. The contestants created an autonomous AI agent based on the GigaChat LLM model, was capable of mimicking real human behavior. To announce the results, I invite the Vice President, Director of the Data and B2C Recommender Systems Department, Ivan Kuzmin. Ivan, please, you have the floor. Good evening. Welcome, everyone here present here and those who watch us online. I think our journey is a major benchmark, really, and our contest is of great interest. A lot of experts are participating. They are interested in the problems resolutions, and we are interested in these problem-solving techniques. Because, it's not only because I work with recommendations, but everything connected to search and ads. You need to deeply understand your customers, and there were more than 300 teams, more than 4,000 assignments, ready-made assignments were sent to us, and there were very interesting solutions, including a part among the winners. We are going to actually look at them, and maybe we will make the lives of our users better by implementing them. And let's go to the award ceremony. Who won the bronze and become the owner of 400,000 rubles? Who is motivating us for further discoveries? Third place in the human-centered AI assistant goes to Vladimir Kalyuta. Vladimir unfortunately couldn't come and could not connect. We connect him. Oh, here he is. Wow, fantastic. Yes, hi everyone. I'm really sorry for not being able to come. Your hobby says that you like oceanology and hydroacoustics. Yeah, that's what I do. How did it help you, oceanology? How did it help you to resolve the human-centric task, not fish-centric task? Why not fish-centric task? Well, the task was pretty interesting. As with oceanology, you can see the patterns of those who live in the sea, and to see the patterns of the behavior of the fish and different types of fish, and basically apply this model on people. That's interesting. We're going to have a totally different perspective on many things from now on. Bio-inspired in action. Vladimir Kaluta, a round of applause, and thank you for being present with us today and sharing your experiences despite the distances. Moving on, 700,000 rubles, that's the second place. Second place in this human-centered AI assistant goes to Mikhail Popov. A round of applause. Maybe a couple of words about the contest. The task was interesting. It's very exciting. The fact that we're using LLM as recommendations. And as you said, you know, as the previous person said, the previous contestant said, you had to find patterns of the behavior of the people. Thank you very much for participating, and hope to see you next time. And who got the check for 900,000 rubles? Who climbed to the top? The first place in the human-centered AI assistant goes to Dmitry Mikhailov. Geography is no barrier to victory. Unfortunately, Vladimir could not be with us today here, but technologies removed the borders and distances. Dmitry, can you hear us? Yeah, hi everyone. Dmitry, well, first congrats. Thank you very much to you for organizing that. Thank you for participating. About the task, a couple of words maybe about the solution. I think the most exciting part of this task was, you know, how high you can get to the top of the tournament by operating pretty simple things. But if you are very cautious, if you're very strict, and yes, I do agree with the patterns was the key to success. Are you going to participate next year? 97 submits. It's quite a lot. Okay, congratulations, and the first place goes to you. Goes to St. Petersburg. Ivan, thank you very much for participating in the ceremony and awarding the best data researchers. Thank you very much. And this concludes the award ceremony for the AIJ Contest 2025. Maxim, the round of applause for you as well. Thank you. We thank everyone. A lot of things in store for you. Today we saw how participants receive recognition and rewards for bold, effective ideas. Thanks to the organizers for the cool tasks that make the future even closer. Participants, we thank you for your incredible involvement and bright competition this year. And we are moving to the next ceremony. The award ceremony for the AIJ Science Journal 2025. A round of applause. I'm glad to welcome everyone to the smartest moment of today's scientific day. On this stage right now, we announce the authors of the best scientific paper. The Russian Academy of Sciences traditionally acted as a strategic partner in this competition. Senior Vice President, Head of the Technology Development Block at Sber, Andrei Belevtsev. Director of the Ivannikov Institute for System Programming of the Russian Academy of Sciences, Arytun Avetisyan. Academician of the Russian Academy of Sciences, editor-in-chief of the journal called Doklady of the Russian Academy of Sciences, Mathematics and Informatics Control Processes, Alexei Semenov. Andrei, please, you have the floor. Good evening, friends. It's okay. So, yes, I'm very happy to welcome you all here, because for us, obviously, AI is based on science and technology progress, and for me, we lack in Russia the scientific awards and scientific paper. This is something we lack. We're working on that, because we think that this should be, I mean, the winner of our contest should be one of the best awards you have ever received. I'd like to thank you, your very high-level jury. I've had 13 countries participating, and the colleagues helped us to select the winners. The winner went through very hard selection process, and thank you very much, and giving you the floor. Andrei, thank you very much for these kind words. Well, actually, there were a lot of papers and articles. Some were not selected due to technical issues. 42 papers went to this journal, and 150 were given to review. So less than 1/3 of the articles were selected. We could have been even stricter if we wanted, but I think we need to find a proper compromise. And we will be able to create proper journals that would be in line with all of the requirements. We have them, but I mean, we need to do that so that it is of international nature. And you know, this advertisement for us is very important. And these steps that we're doing together with the entire community, this Sber, I think this is a fantastic event. And you know, we had what, like 300 reviews, but you know, people are involved and they are engaged. But anyway, having a good journal, having a good award does not come just because our large companies invest, but because we all contribute. Alexei, please. Yeah. You know, to build on the previous remarks, I would like to ask you to prepare for the competition before the official announcement. The competition of the reports, as well as the articles that we published. The journal is the leading journal in computer science and informatics. It has been there for more than 100 years, but it's really honorable to be on the par with the leading conferences and journals in the world. The range of topics increases. All the topics of AI are covered, and for us it is very important that the mathematics is very serious, especially in the work of the winner. It was used for image analysis, and well, image analysis, you know, when AI came, it resolved everything thanks to very simple mathematical things. This is not so right now. I mean, to have this segmentation and do other things, we use complicated graph models of mark fields and other things. And I would like to say that for me it is very important that the serious mathematics is more and more permeating the space of AI. And now we're going to the announcements.
I will simply say that we are living in a world where AI is a co-author of different discoveries. It helps write papers and design experiments. The journal Doklady of the Russian Academy of Sciences is the North Star in this regard, and it helps you assess the scale. The journal will include the best research papers from the competition. You can browse it for the best discoveries of this year. Let's hear about the winner of 1 million rubles. We announce the title of the best scientific work and the names of the authors. MMRFIGN, an ensemble graph model for segmentation of imbalanced high-resolution images informed by multi-component Markov random fields. I invite the authors, Andrei Gershenin and Anastasia Dostovalova, to the stage. We are very glad that you were able to join us in person today. A round of applause for them. Let's capture this triumphant moment with a photo. Andrei, Anastasia, please tell us what you think. I'd like to thank you for the kind words said here today. It's a great pleasure to be receiving this award from such big, renowned scientists. This is a great privilege for us. A couple of words on the research. Sergei said earlier today that we need physically motivated, mathematically motivated models, and this is the approach that we were guided by in our work. We were analyzing images to improve the challenge that was set for us, the image segmentation for high-resolution images that you can get from drones, for instance. We used mathematical methods, and we proved theoretically that the results that we get are not just a result of training or benchmark testing or testing on open data sets, but it's actually what you get from theoretical research and theoretical rationalization of the challenge. We used Markov random fields, as was said. In this physical world, we're using variable models with the challenge of image recognition. This is something that is rather new, so it's great that our work was recognized as the best. It's a great privilege for us. It's a great achievement for us. Thank you very much. Your applause for Andrei and Anastasia. Congratulations. Hopefully your work will resonate with the readers and serve as a stimulus for new discoveries. Applause for the winners and applause for Andrei and Alexei. Thank you very much. We continue with the next ceremony, award ceremony for the winners of the International AI Challenge Competition 2025. Development in the world of AI opens up opportunities for the future. The AI Challenge International Competition for young people and teenagers brought together participants from 170 countries. The competition has high school students, school children, and university students. Some of the youngest participants are 12. I like to participate in such competitions. It helps me remain ambitious. More than 29,000 submissions and 10 areas of research, from auto-review of school essays and validation of an electronic pharmacist to combating deepfakes. I really like to tackle different challenges, be it creativity or mathematical challenges or just learning something new. I am training in artificial intelligence and I would like to build a career there. I've decided to participate in the competition to test myself in programming and to compete with talented young people. For many people, this is a chance to make their dreams come true, hone your skills in AI, and unleash your potential. And now, finally, we are giving out the awards for those who respond to the challenge in the most promising areas. I welcome to the stage First Deputy Chairman of the Executive Board of Sberbank, Alexander Vedyakhin. Dear friends, can we just begin with the ceremony? Let's do just that. Track beginners, participant 14 years and younger. The challenge is automated review of school essays. The first challenge was proposed by Sber Education. Participants faced a task relevant to their age, developing a system for automated checking of Russian language OGE essays using LLM GigaChat Lite. We start announcing the winners. Third place goes to Ilya Baklin. Ilya, where are you? Ilya, your solution can already help thousands of school children. Congratulations, auto review of school essays. Is that a good thing for a school child, do you think? Yes, it helps to assess your knowledge and then take this into consideration. So you're just sitting there thinking, what if I write an essay and then I will have an algorithm check it? No, it's very useful when you need to prepare for the exams in the 9th grade. Ilya Baklin, 14 years old, from the city of Ryazan. Congratulations, this money is yours. And the third place as well. Your applause for Ilya. We move on to the silver medalist. Second place goes to Roman Khabirov. Roman Khabirov, among 10,000 participants from all over the world, you, Roman, at 11 years old, have proven that talent has no age. Standing next to Roman, I feel so tiny. Just because Roman is only 11 years old, and you're already standing here on the stage, you are second in a great competition. Can you predict the pace at which you're going to move on to new heights? I cannot believe it. Today we would like to give Roman not just the silver medal, but a special award, Young AI Ambassador, as the youngest participant of AI Challenge. Congratulations. Keep at it. I want an award for image generation. Really? I think I can speak with the organizers about this. We can arrange something. Great, you've already set a new challenge for yourself. Roman is truly an inspiration for all of us. Roman was from the city of Salavat. And the gold medalist, the one whose algorithm checked essays like a strict but fair teacher. The highest award goes to first place, Arseny Marfin. Arseny, hi, congratulations. What was the most challenging part? I think the most challenging part was to write the server part of the backend. No, wait. No, yes, that's backend. I meant backend. Well, what can I say? You did a great job, as far as I understand. An interesting fact about Arseny, he's the finalist of the Russian competition on recognizing Russian classical prose. When you're talented at everything. No, you need to give it a bit of a flash when you say backend. Okay. What's your challenge for next year? Say like a TV presenter. Well, I hope the challenge will be interesting and useful. Well, what kind of challenges do you enjoy? Something that is interesting. I think we're caught in a loop. It's just that I can make arrangements to make challenges extra interesting. No, that wouldn't be very interesting. Thank you, Arseny. Congratulations. Don't drop it. Arseny Marfin. And yet another task for beginner developers. It was prepared by VK Education. Participants were creating a model that predicts how many people will see a specific ad in the future. The challenge of predicting ads seen by users. First one in the top 3 is the participant whose model showed impressive accuracy. Third place goes to Olga Svatalova. I really enjoyed when women come up on this stage. Let's give a round of applause for Oля. Great job. Your hobbies are knitting, astronomy, computer sciences, and Chinese. I wonder what you're knitting. Why did you choose this challenge, showing ads to users? I thought that for me this would be the most interesting challenge. Why? You want people to see more ads? Or you want to see relevant ads? No, it's just that at some point I was selling my the items that I knitted myself, and I was buying ads on VK. Oh, I see it now. Well, what can I say? A very practical challenge, then. Let's give another round of applause for Olga. Olga turned a complex challenge into a brilliant solution. Keep it up, and please smile for the photo. A crash course on entrepreneurship with Olga. Your applause for Olga Svatalova. Congratulations. Second place goes to Fyodor Stepin. Fyodor's model sees the future, and we see the future of IT in you. Okay, what was the biggest challenge for you? For me, the biggest challenge was to combine the two models that we had written at the previous stage into a single convenient and practical suit, or a bot for the users in Telegram. Did you have any problems with the backend? None. Programming, football, and chess. Moscow, school 777. Fyodor Stepin, congratulations. Thanks again. Your applause for Fyodor. He will go back into the audience to enjoy the victories of his colleagues. Yes, another photo op with Alexander Vedyakin. It's never too many photos. And finally, first place goes to the one whose algorithm predicted ad demonstrations almost like a crystal magic ball. First place goes to Grigory Bogdanov. Once again, coming from Moscow, Georgy, hello. What was the biggest challenge for you? I think the biggest challenge was to validate many options, running experiments again and again to come up with the most accurate one. Well, you did it. What does Wushu do for you in this, and also football? Football keeps me fit, it improves my mood, and it keeps me motivated. Okay, what's best? Is it Wushu or football? Press-ups. Your applause for Georgy Bogdanov. A great start. Make sure to capture this with a photo. I really like those photos because later on I will be telling people, you know, I have this photo with this great guy back when he was a school child. And Kandinsky will always make your photos even brighter, even more colorful. We continue. The school children category, participants up to 18 years old. The challenge is called White Balance in Mobile Phones. Let's start with the case presented by the IRI Institute. To open the awards in this category, we invite the participant who managed to find a new approach to color correction. Third place goes to Andrei Naimushin. Hello, Andrei. Very briefly, what was this challenge about for you, for the layman? What does it mean? Predictions, histograms. No, go again. Predictions of the brightest area in an image. Why is it called white balance? Oh, because it's the brightest one. I see. I thought I understood. And is it a big problem in Perm? In the city of Perm? Yes. Hopefully this is the biggest problem in Perm. Anything you'd like to add? Nope. Congratulations. Andrei, you taught AI to see the world in perfect colors. This is the future of computer vision. I'm sure our photographers have color cameras, so make sure you take the best photos for your social media. We're only one step away from the gold medal, whose white balance in mobile phones had a slight shadow. Second place goes to Kirill Labzin. Kirill created a solution that will improve the quality of visual content. Kirill, please come up on the stage to make it brighter. Serious, right? Hello. Hello. I'm sure you're ready for my question. Go ahead and answer it. You mean the question is what the challenge was about? I don't know what I wanted to ask you. You answer it. Well, you asked what was the most challenging part. I would answer it like this. The most challenging part was to keep the model stable, for it to give the same scores for the public and the private sets. And I think that was the most challenging part. What about the white balance on your phone? It's fine. That's the key. I think it employs some models for it. Most likely. I think we should swap it with the model that you created. Agreed. Kirill Abzin, second place. Your applause for Kirill. Let's take a picture. This photo will definitely have the perfect balance. The highest award goes to the participant whose model handled white balance better than the human eye. So, who has the gold medal? First place goes to Diniar Muratchin. Diniar, you have a proper fan club. Hi, Diniar. Hello. It says city of Sterlitamak and Itmo. So, where are you from? No, I love my home city. I decided to indicate it there.
Great idea, but you're from Itmo. I mean, you're studying at this university, yeah. Wow, fantastic. How to put the white balance? I don't know. I mean, I could have won the competition. Well, I guess so. Maybe a couple of words about algorithms. I was trying to find an article that I want to remake. A lot of things that I've learned, and it worked out great. There was some article of 2021. You can read it when you have free time. Yeah, right. So, Daniar, thank you very much. Diniar Muratchin. Let me take a picture. Yeah, he's just running away. Just put these pictures for me. I would say, okay, I know this best engineer from Google and Apple or whatever. Digital control of ad placement, a case from Rest Telecom. The participants had to create an automated system for analyzing photo reports. The bronze winner is third place, Miron Bubnov. Fortunately, he couldn't come and couldn't connect online. He's in Irkutsk. Different time zone. Silver. Shodzahon Israilov. Your system is a great example of AI applications in business. Hello? Hello? So AI in Tashkent is a big thing. No, not at all. Well, Tashkent is a very beautiful city. Maybe you can do without AI there. One of my favorite cities, by the way. Have you been there? No, just look at the pictures. Presidential school, Tashkent. AI is popular there as well, right? At least, no. Okay, so you are the only person there. No, just some classmates got involved. Did they participate? No. Well, not good. Not some effective involvement strategies that you used. Hope to see you next year. All the success to you. And finally, the gold goes to the one who's developed a system who's working with the precision of a Swiss watch. Diana Komarova, first place. Ukhta, that's the name of the town. Yeah, I really like it when girls are on the stage and especially get in the first place. Why have you decided to go to data science? You also have a degree with the cheerleading sport, right? Yeah, well, a couple of areas there. I'm doing hip-hop, sport dances. Okay, where's AI here? Well, I wanted to develop myself not only in sports, but in education as well, you know, to find some new things in AI, and this is why I decided to do it. But, I mean, then you're going to some university, right? Yeah. These guys will tell you where to go. Diana, all the best to you. Diana, for sure you need to have a photo. Maybe you can even show us some of the hip-hop things. Well, this is not hip-hop, so wouldn't work. New goals and ambitious goals. LLM teacher, the name of the task. A complex task from the Central University. Essence was to develop a system for solving mathematical problems. We award the teams whose virtual teacher explained the material with enviable patience. The boys, the name of the team: Konstantin Sigolov, Radmir Zosimov, and Timur Garifulin. Timur and Konstantin are here with us today, and they go to the stage. Fantastic achievement. Shows how AI can support education. You have a fantastic fan club. What is important for an LLM teacher? That guy is with the phone. He is the head of the Sber Education. His name is Artyom. Tell it to him. To make sure, you need to make sure that this model does not hallucinate, does not give improper answers. It's especially important in mathematics. And during all the stages, we were able to develop all the solution that helps to resolve the tasks and make solutions. And it even put marks. Yes, that as well. Yeah, that's your future partner over there. I hope that you get only the best marks by AI teachers as well as human teachers. Congratulations. And silver. Second place. Time to Prime Delabr, the name of the team: Stanislav Davichenko and Mikhail Kondrashov. Mikhail is with us. Hello? Yes? Hello? Tell me, what is Team to Prime Delabr? Team to Prime is a team in the top, a team in the prime. And what is Delabr? Just the name of our... just the name. It's from the name from the Olympiad, the team of the Olympiad. Yeah, deadlines. If you are champions in Deadline Championship, you have a very bright corporate future ahead of you. We actually put everything there in the last moment. I would like to say hi to my team member. Thank you very much for being with us, with me. And now we are able to get the second place. Congratulations. Yes, congratulations, Mikhail. Your system does not only give the response, but it helps to understand that this is how the educational future will look like. This is the person who asked to have an internship at Sber, and he just got it just right now. I just gave him the internship. Yeah, well, a round of applause for that. And the creators of the most understandable AI tutor. Sidim Не Рыпаемся is the name of the team, from Alina Kudryashova, Maria Labetskaya, and Daniil Smirnov, Andrei Chetverikov, and Nikita Bakutov. Andrei is here with us. Andrei, where are the girls? Yeah, okay, so you just go here and all the others are just sitting there and not moving, right? How did you decide with the name of the team? Well, my teammate proposed it and I just said yes. Yeah, well, I just said that. Well, yeah, well, I'm someone who can sit still. Well, you have a great corporate future with that one, for sure. This guy with the phone taking a picture, Artyom. So, LLM tutor is the task that is important for Sber education. I think Artyom will have a talk with you for sure, and he will think with you how to use the developments that you came up with. Yeah, I will wait for that. No, you'll just wait and sit still, and Artyom will come to you and we will find you for sure. A round of applause as well. Moving to the next task, RL for the ISIN model. Let's proceed to the final task of the track from Rosatom. Young developers created and trained an agent to optimize the energy state of a graph. The third in the ranking is the team whose agent demonstrated amazing ingenuity. Third place, SOTA team, Daniil Antonov, Artyom Mazur. Daniil, Artyom, thanks to your talent and work, you showed how modern methods solve classical scientific problems, and it's no problem for us to take a photo at this stage. Guys, congrats, state of the art, that's how you call the company. What is Izinga? Izing is a scientist. Oh, that was the name. Okay, sorry, I'm not state of the art. Yeah, I have a question. How do you plan to use that in Sber? That task for ML in Izing in Sber. You know, in Sber, when you put a question to a top manager, I just say Maxim. And yeah, Markov Sergey. That's how we do things in Sber. Yeah, data scientists, they say they know everything. Model of Izing model. What it is about? Tell me in simple words. Well, optimization based on graphs, like how to go to go through the shortest way, right? Yeah, but it's like RL, it's reinforcement learning, right? So you get awards and you get the fines. Yeah, well, Maxim just saved his job from downgrading. A round of applause for Daniil and Artyom. Who took the silver? Data Boom. Grigory Demidov and Roman Pahomov. Grigory is here with us. Grigory, your model successfully solved a complex optimization problem, and we are sure that many interesting challenges are ahead. Organizers show me that I have to shorten my remarks. So, in a nutshell, was it easy or not? Was okay. Okay, I was okay. That's great. Yes, the algorithm was optimized. Nah, he didn't even want to take a picture with me. Yeah, whatever. First place. Baseline. Artyom Chernobuk and Yegor Mitkin. Yegor charged for success. You can make a photo with AI right now. No need for human photographers. Yegor, baseline. How did you manage to go above baseline? We didn't go above it. Just a baseline, and we just got it, and we were the first. That happens. Yeah, I mean, last year there were complaints that there was no baseline, and this year no one was able to go through it. Maxim, you got complaints that there was no baseline last year. As a data scientist, I made sure that you should have a baseline. Well, anyone can do it with the baseline. Why not? I mean, if you give baseline, that's okay. Try it without baseline. Okay, these guys just don't want to work. Anyway, congrats. Thank you. I'd like to take the opportunity to say hi to Artyom from Prokopyevsk. Yeah, Artyom, hi. The team spirit in place. Track students, participants up to 25 years old. EPI Health task. The task for students, which we will start with, was devised by SberMed AI. Young programmers developed a system for classifying diseases based on DNA analysis. Now let's find out who will open our ranking. Third place, Maxim Kobylev. This solution brings the era of predictive medicine closer. The future is yours, really, and this solution is the future. Congrats. The task, in a nutshell, to predict diseases. Have you tried it? Have you test-driven it yourself? No. Why? I have forgotten to test it. Yeah, right. Okay, anyway, congrats to you. We hope that your algorithm is working properly with high quality and that you have good health. Photo and a round of applause. We are continuing our ceremony. Second place, Denis Zhuk. This solution allows building a real bridge between AI and clinical practice. Denis is a talented architect. I think Denis he was here last year. Was it more challenging? Well, since I have become a student, the task has become more challenging and interesting. In the school kid track, it was easier. Anyway, congrats. Thank you very much. Thank you. A round of applause. Denis Zhuk. The first place. Timofey Ilyin. Thank you, thank you. What was the most challenging? You need more data, very few data. Well, I mean, anyone can do it with data. Try to do it without data. I will try, okay. As for the analysis, yes, I want to answer. For my colleague, analysis is expensive, so maybe this money will be enough. And the tests, that's expensive. Okay, yeah. Stay healthy and take care. Timofey Ilyin. Congrats. Next task. Fighting deepfakes. As part of this case, from MWS AI and Visual Labs, participants had to create a reliable methods for detecting fake videos. The bronze. The third place, Andrei Kuznetsov.
Андрей, я не знал, что тебе 21 год, а ты в Липецке.
So, we have two Kuznetsovs here. One is fighting with deep fakes over there. Stanislav Kuznetsov over there fights with deep fakes. Andrei Kuznetsov is creating deep fakes. Fantastic duo. I guess all people who have a surname of Kuznetsov love deepfakes. Yeah, a lot of Andrei Kuznetsovs, very famous people, also those present here. Anyway, congratulations, Andrei Kuznetsov.
great opportunity. Well, you have different patronymic names at least. Stanislav, Mr. Kuznetsov, could you also please go here, 3 Kuznetsovs on one stage, and you also fight with deepfakes? We optimize some algorithms and resources, and the most important thing is that we save time. I congratulate all Kuznetsovs.
Thank you. A round of applause. The most common surname in Russia. The silver goes to Alsu Aldag. It's probably not that easy to teach AI to recognize artificiality, but Alsu managed to do just that. Please come up on this stage. Congratulations. Hello. Hi. What would you like to say? I'd like to say that the challenge was rather interesting. The most difficult part was the execution. I had to write the code to make sure it executes the way I wanted to, and no surprises come up down the line. Did you make it happen? Yes. Great job. Congratulations. Let's take a photo and let's move on to the winner. First place, Nikita Korshunov. Well, Nikita, are you happy? Sure. Great job, thanks. What was the most difficult part? Fighting the overfitting of the model, correct data, and UI was the least enjoyable part. Are you using it in real life with deepfakes? I tested on deepfakes interviews with presidents. Did you test it for creating deepfakes or recognizing deepfakes? What do you mean? Well, when you're fighting deepfakes, you can have different approaches. So you took deepfake interviews and you recognize deepfakes. What's the accuracy? Rather high. How high? A lot. Right, a deepfake response. Go ahead and take your certificate. Thank you, Nikita. I wish you ever success. Nikita Korshunov. The challenge called AI Judge for assessing the performance of an electronic pharmacist. We welcome all 3 teams on the stage. Third place, the team called WhatsApp. Second place, Amnyamy. And first place, Mrs. X Alpha Beta Gamma Prime. We welcome you on this stage. Guys and girls, congratulations. Thank you. Well, what can I say? Maybe just 5 words per each one of you. What did you like, what you didn't like? In my mic to make sure I stay silent. Great data, great labeling, thank you. I have a mic. Okay. What I liked the most was the part concerning model training. What I didn't like was building the front end. No, we're not going to skip you. Give the mic back. I agree with my teammate. I agree with everyone. Great response. I agree with all of you as well. Congratulations. Great result. I don't think I'll be able to say the names of the teams. Oh, we did that already. Do we have the picture? WhatsApp, Amnyamy, and Mrs. Alpha Beta Gamma Prime. Your applause for the 3 teams. And let's welcome the winners back in the audience. On this stage, you do not control anything. The one who controls everything on this stage is the one holding the camera and the photo camera. Congratulations. Next challenge, multimodal search of CAD objects. Once again, we welcome on the stage all three teams. Third place, Muse. Second place, Ambassadors of Oatmeal Cookies. First place, 12.5 Squad. Welcome. This very final challenge was suggested by Sber AI. I hope the team called Oatmeal Cookies are bringing cookies to the stage, right? Are you bringing cookies? No? Muse Squared, Ambassadors of Oatmeal Cookies, and 12.5 Squad. Okay, 5 words per each. What did you like, what you didn't like? All great, nothing I didn't like. I have to agree, it was great. Yeah, super. Agreed. I'd like to take this opportunity to give my regards to Timur Sarvarov, my teammate, my great friend, watching this conference now. I think he's in the metro. Why isn't he here? He's in a different city. Oh, so he's under the ground. We need to speed up. Thanks to the organizers, it was very interesting. I would also like to say hi to my teammate, Alexander Smirnov. He was extremely helpful. We wouldn't have done it without him. I think that's it. Congratulations. Congratulations. If you'd like, you can take the picture. If you don't want it, that's fine with me. The future of AI is just around the corner, is not far off. It's already here among us. It's in the reliable hands of the younger generation. We congratulate all the winners on their excellent results. Thanks, everyone. We also thank Alexander Vedyakhin. A round of applause for him. We also thank the winners. Without you, it wouldn't have been as exciting. The 10th AIJ Conference 2025 is closed. Thank you very much. And I would like to ask the organizers to stay behind.